will be a Starfreelancer. Learn new skills. Set your goals. Increase your skills. Browse over 100 plus videos and ebooks. Jump to starfreelancer.eu.
Alright, so let's discuss parsing values from a string. In many cases, you'll have to parse the value from a string, meaning that you'll have to convert a string into some other data type, such as a number string into an int. Now, one use case where we might need to convert a number string is when reading input from the user, perhaps after it's been entered into the console or after being retrieved from a user interface. In later videos in this course, you'll see this in action when you learn how to read values from the user using the scanner class. But let's first discuss how we can convert a string value into some other primitive data type. So we're going to begin by typing some code, and you can see I've created a new project here and I've called it parsing values from string. So the code we want to type in there now is string number as string equals 2018 in double quotes. Then on the next line we're going to print out number in double quotes as string equals the space ending double quote plus number as string. Alright, so this is a string that we've defined on line 6, meaning that it's interpreted as text and not as a number value. So the goal here is to convert this piece of text into a number. But firstly, let's just quickly run this. You can see we've got the output down the bottom of the screen there, number as string equals 2018. So again, the goal here is to convert this piece of text in our string into a number. Now, one way to convert a string into a number is by means of a parsing method. Now, with these methods, we can convert a string into various primitive types depending on the specific parse we choose to use. Now, in this case, since we want to convert our string into an integer, let's type this out. I'm going to do it on the line after the output line, and I'm going to type int, make a space there, line space between lines, so int number is equal to an integer with a capital I dot, and I'm going to select parse int. Then in parentheses, I'm going to put our string we defined on line 6, number as string. Alright, so line 9 contains some code that we haven't yet seen in the course. So first off, we're using a class called integer. And you can see that it's a class because I'm using a capital I there. Now this is a wrapper class for the primitive type int. Now don't worry too much about wrapper classes at the moment because we will be discussing them in more detail later in the course. One thing to note though is that the wrapper class integer contains some useful static methods like the one that we're using, parse int. Now this method, parse int, will try to convert the string that we're passing as an argument, it's number a string here, into an integer. Now if it's successful, the number is converted from a string to an integer, but if the conversion fails, we'll get an error. Now you may also notice that we typed integer dot followed by the method name parse int. In order to convert type string into some other data type, in other words, parse the string, we need to include the type we're converting to so that we're able to get the parsing method associated with that type. So in our case, the result is integer, then dot, and then the method name, in this case parse int. But later on, we're going to see similar methods to this. So simply put, this parse method is a static method that we can use to convert or to parse a string type into a number. Right, so let's actually print that out just to confirm that it does work. So on the next line, I'm going to do a print out, and in double quotes, I'm going to type number equals double quote plus number. But this time I'm going to output number and not number of string. So we want to print out the variable number, which is an int, that we've hopefully got the value for the string value 2018 in it. So let's run that. And you can see down the bottom of the screen we've got number equals 2018. So parsing is useful when we need to convert a string into a number in order to use that number to calculate something. So let's test this by adding 1 to both number as string and also to number. So what we can do, we're going to come down here and we're going to type number of string. Then I'm going to type plus equals 1. Then on the following line, I'm going to type number plus equals 1. Now when we add the integer 1 to number a string, Java will automatically convert the number 1 into a string and then concatenate these two strings. So that number string will now have the value 20181, and that's really not what we were hoping for. But by using number plus equals 1 on the next line, line 13, we're actually incrementing number by 1 because it's an int value and not a string. So therefore the value of number should be 2019. So to confirm this, let's print out both to see that it is actually correct. So I'm going to start by printing out number of string. In double quotes I'll put number as string again, equals, then plus number of string. Then on the next line, let's print out the value of number. So number equals plus number. Alright, so let's run this. Alright, so you can now see the difference that we've discussed. When we use the plus operator with a string type and a number, the number is concatenated to the string. It's appended, in other words, to the end of the string. So Java's converting that number to a string and joining it to that string. And you can see the result here, 20181. However, after converting a string type to an int type, we can then use the number, as in perform operations with it. So in our case, number is originally defined up here as an int on line 9. And by incrementing it by 1, which we did on line 13, and outputting it, we've now got the value 2019. Alright, so moving on, let's pretend now that a user entered in some data. In this case, they entered 2018, which is a valid number. But what would happen if the user typed something by accident? Say they added a letter to the number sequence. So let's see the result of that by changing our number of string up here on line 6 to 2018. We're going to add an A on the end of it. So what will happen when we actually run this? Well, let's actually run it to see what happens. Now you can see that we've actually got an error down the bottom left-hand corner of the screen. So it didn't work as expected. So we've got this error, which is also known as an exception. And you can see on the screen there it says java.lang.numberFormatException for input string 2018A in double quotes. So the problem here is our string. Since its value is 2018A, it cannot be converted to an int because that's not a valid number. And so Java throws this or gives us this number format exception to indicate that the format isn't correct. Now, there are a couple of ways to handle this problem. One way is to handle the actual exception, but we're going to be covering handling exceptions later in the course. We could also create our own method as an alternative, but that too will come up later on in the course. So instead, let's just revert this change by removing the letter from the string for now. So I've gone back to the original value of 2018 now. So a similar process for conversion can be done with other number types. For example, the double type. So let's try adding a decimal value to our string. We're going to change number to be of type double, and we're going to use the double class and the parse double method. So it's going to be very similar to how the int version works, but with a double. So to do that, I'm going to come up here firstly and type, or change rather, the int type to double. So it's now double number. Then we're going to change the word integer here to double. So it's going to be double again. And then we're going to change the word int here to double since we're wanting to convert to the double primitive type. Now let's run our application again and see what happens. So far so good, but let's actually now change this value, 2018, we're going to change that to 2018.125, which of course is a decimal number, just to make sure that our double calculations are working. I mean, we've got an idea that it is working here, given that we had a dot zero, the period 0 added to the end of the number. But let's run it now that the value is 2018.125 and see what happens. So you can see here we've got number as string equals 2018.1251, and that's what we would expect because it's of type string. remembering that if we try to add a number to a string, Java automatically converts the type back to a string and appends it to the end of the string. But in the case of the number, where we've defined it as a double, and we did that on line 9, adding 1 to that, we started off with the value of 2018.125. That's the value it got on line 9. We've added 1 to it. And the final value there is number equals 2019.125. And just to be consistent and check this, if we added an A on the end of that and run it, we'll find that we'll get the same type of exception. In other words, error, trying to convert what is now not a valid number to a number. All right, so I'll delete that. Now there's a similar parsing process that can be used for other types like float or long, but keep in mind that when we call methods such as parse double, the associated class name must be used before calling the method. So in this case, obviously I changed what was originally the integer.parseInt, and I changed that to double.parseDouble. And again, notice how it begins with a capital letter, while primitive types, such as this one here on line 9, this start of the line starts with a lowercase letter, as in double. So we've got uppercase here, first letter, and lowercase over here. So keep that distinction in mind, but again, we'll be covering these wrapper classes, which is what this double entry here is, this class. We'll be covering that later in the course. So that's it for converting a string to a number type. I'll see you in the next video. Alright, so let's discuss reading input from a user. So the goal of this video is to make an interactive application where a user will enter his or her name and year of birth, and then the application will calculate the current age of the user. Now, in one of the previous videos, we learned how to parse, in other words, how to convert a string type into a number by using the methods parseInt and parseDouble. In this video, we're going to cover another useful method called nextLine, as well as a few others. And we'll also use a class called scanner, which is a simple text scanner that can parse both primitive types and strings. So essentially, scanner uses methods like parseInt internally. Now, one method called next returns a string, allowing us to save the returned value to a variable. So the application we're going to write will prompt a user for their name. In other words, we want the user of the application to enter their name, and then our application will store that as a variable. So to start, let's actually get our scanner set up. We're going to type some code in our main method, noting that I've created a new project called reading user input. So I'm going to type scanner, a capital S, then a lowercase scanner, and I'm going to press to select that option, and I'm going to make sure that I'm importing the scanner java.util. So if you get prompted for multiple options, make sure the scanner.util is the one you choose. So the code scanner equals new scanner, then in parentheses it's going to be system with a capital S .in, and semicolon to complete the line. Now you've seen system.out before, and that dumps text to the console. In other words, it outputs information. And in fact, we've actually used that all the time in pretty much every project that we've worked on. So system.in, on the other hand, is the opposite, in that it allows you to type input into the console, which then gets returned back to the program. So that's what we're doing here when we're defining a variable of type scanner. So as mentioned previously, this case here is very important. So scanner is one of Java's built-in classes, and it allows us to read user input. So in other words, we can parse primitive types and strings using methods from this scanner. And notice also there's this new keyword that I'm using here as well, again on line 8. We use that to create what's called an instance of scanner, meaning that we're creating a new object of type scanner. Now so far we've been using primitive types, so we haven't needed to use the new keyword. But later in the course, we're going to discuss in depth what an instance is and why we use new when creating an instance. So keep in mind that we can create as many scanner instances as we need by using a new line with the new keyword again. But for our current example, we're just going to use a single scanner. All right, so if we've defined our scanner, on the next line, let's now type system.out.println. I'm going to put in double quotes, enter your name, : a space, and then close off the double quote, parentheses, and semicolon. We've seen that before. We're just outputting a message there. And on the next line, let's type string name equals scanner. This time I'm using the lowercase scanner dot next line. So I'm selecting next line and parentheses. All right, and then after we've finished using a scanner, we should close it using the close method. So note that after closing the scanner, calling methods like next line or next int will cause errors. So we should really ensure we're done with using the scanner before closing it. So it's recommended that we close the scanner after we don't need it anymore, as it then releases the underlying memory that scanner was using internally. Now this might seem a bit confusing, but later we're going to use scanner more frequently, so things will become clearer. So for now though, what I'm going to do is add an extra line there and put scanner dot close with parentheses on the end. Alright, so what have we done here? Well, to sum up, we're using the variable scanner defined on line 8, and we're calling the method next line, this one here on line 10, scanner.nextLine, to read a line of input from the console. And then what we're going to do now, we're going to add some output to print out what was typed. So we're going to put after the next line method, put another space there. We're going to print out another message. And the message in double quotes will be your name is space, another double quote, plus name. We're now using the next line method here on line 10 to retrieve some information from the console. Then on line 12, we're printing out a message, your name is, then whatever was typed in by the user. So let's now try running the application and see what happens. All right, so you can see down here on the bottom of the screen is asking for entering your name, enter your name, or asking to enter your name. So I'm going to type Tim into the console. I'm going to press enter. And notice that it come up and said, your name is Tim, and then the process finished at the bottom. So in other words, our program finished after doing that. Note always that IntelliJ displayed what I typed in green, which is really a handy way of knowing that these were the letters that were actually typed in from the console. So you can see now that by using this next line method in conjunction with scanner, we're able to retrieve some input from the console, in other words from the keyboard, and then we're able to store that in a variable, in this case called name, and then we were able to print out the value, in other words what was entered by the user. Alright, so far so good, but obviously the main goal for this application is to not only ask the user for their name, but also for the year of birth, so that we can then calculate the current user's age based on what the current year is that the program's running in. Now, we've already handled reading the name, so let's move on to the next part. In a previous video, we learned how to parse a number from a string by using the parseInt method. Now let's try retrieving an int from the scanner so that we can calculate the user's age from their birth year. Now we should begin by displaying a message to the user so he or she knows what to do, in other words, what data to type. So let's ask the user for their birth year before asking for their name. So I'm going to put that code above the code where we've asked for their name. I'm going to put a line after the line 8 that had our definition for scanner. And I'm going to start by outputting a message, enter your year of birth. Then on the next slide, I'm going to type int space year of birth is equal to scanner dot, this time I'm going to select next int and put an extra line there just to make sure that it's clear. Now to read the age we could have used a string, in other words we could have used the next line method like we did for the user's name on line 14 and then converted that to an integer as we've done previously. But scanner actually has a method that will parse the string to an integer for us, and we're able to use that by using this scanner.nextInt method called here. So essentially what's happening there is that the integer, what the user has typed is automatically converted into an integer and saved into our variable called year of birth, which is of type int. Now I'm going to explain shortly why we put this code above the name retrieval section, so don't worry about that too much for now. But now we've got an int value for year of birth thanks to the next int method we're using on line 11, allowing us to read an integer from the console. So to figure out the user's age, we just need to calculate now the difference between the current year and the year of birth entered by the user. So let's calculate the age of the user and then we'll print it to the console. So to do that, I'm going to add the code after the code that has asked for their name. I'm going to type int age equals, we want to enter our current year, which is 2018, minus year of birth. You can put a semicolon there. So that's how we calculate how old the person is based on the year of birth that they've entered and deducting that from the current year, which is 2018. So now that we've got the user's age, let's print out a different message to the user. Now in the existing printf statement, I'm going to add age as well as some additional text. So let's go ahead and do that. So at the moment we've got your name is, let's change that to your name is plus name. We're going to the end of it here. We'll put plus, comma, and you are, and a space, another double quote, plus age, plus, and another double quote and a space there for years old, and closing off the line like so. Alright, so let's now run this application and see if it works. So enter your year of birth is being asked for first. So I'm going to enter my birth year, which is 1964. Press enter. And notice what happened. Automatically, I didn't get a chance to enter my name, and it automatically came up and says your name is, a space, comma, and you are 54 years old. So the application didn't give us a chance to enter a name, even though the message enter your name was printed. So what's going on there? Just to make sure, let's just run it again. Being very careful, I'm going to enter my year of birth and press enter. And you can see it automatically goes past the enter your name and prints out the message. It didn't give me a chance to enter my name. So what's actually going on here? Well, this is actually one of the mistakes that beginners usually make, which is why I've ordered the birth year prompt before the name one. Whenever we read a number from the scanner, be it an int, a float, a double, or some other type, we press the enter key on the keyboard as we just did with the age. So doing that ends the line. So it's recommended after a next int or a call to next int to call next line again without assigning it to a variable. In other words, to handle the enter key issue, we have to call next line so that the scanner works as expected. Now internally, the scanner is checking for a line separator, and when we hit enter, we're typing a line separator, so that's interpreted as input. When we reach the next line method, that retrieves the name. The input for name becomes enter, so is essentially skipped. So knowing that and knowing that that's an issue, we can now add another call to next line right after next int and include a comment to that effect as well, so we know that we had a reason for doing so. So after the year of birth up here, I'm going to type scanner dot next line to call that. And we're going to put a comment here to say handle next line character enter key. So now that I've actually done that, let's run this again and see what happens. Into our year of birth again, in my case 1964. This time it's now asking me for my name. I'm going to enter Tim, press enter. Your name is Tim and you're 54 years old. So the program is now working as expected. So keep this in mind for the future. After you read in a number with a scanner, there must be a next line method call to handle the enter key like we've done on line 12. Alright, so upon looking at the birth year entered by the user, we can see that our application easily calculated the age. However, there are a few potential problems, and let's talk over those problems in the next video. Alright, so in the last video, we got our application working, but I alluded to the fact that there were a few potential problems. So let's go through in this video and discuss those problems and also how to resolve them. So the first problem is, what if the user enters a negative number for the year of birth? What will happen to the user if they enter some letters instead of only numbers? So let's actually test these two conditions by running the application again. So firstly, for year of birth, I'm going to enter minus 20 there, and I'm going to enter my name again. And it says now that I'm 2038 years old, which is obviously not correct. So what we need is to add some condition that would check if the birth year is positive, or even better, check a valid range. So what we'll do is we'll check an age range of 0 to 100, and if the age is not in that range, we'll print an error message to the user. Alright, so that's the first test, but let's run our application again now to test what happens if we enter some letters instead of numbers. So here what I'm going to do is I'm going to type in Tim for the year of birth. And you can see what's happened there. We get an exception, an error, and the program exits. And in fact, it's a similar message to a similar exception to the exception we saw in a previous video that had a number format exception, but this one is an import mismatch exception. So basically the program crashed because NextInt cannot pass the text Tim as a number, and it crashed for that reason. And you can see that conveniently here, main.java 11 is telling us that this is where it crashed on line 11, and that's that call to NextInt to try and convert what was typed into a number. So it's clear at this point that we've got two problems. One is with negative numbers as years, and the other is with entering letters into the parseInt method, or in other words, entering numbers in the area where it's asking for an age. So let's first deal with the problem of negative years. So after we calculate age, we want to check it against a range of years from 0 to 100. So to do this, let's add an if statement. So I'm going to add that directly below here, the age. And I'm going to type if, parentheses, age is greater than equal to 0, then two ampersands, which is indicating and, age less than equal to 100. We've got the closing parentheses there. And if that's the case, I'm also going to put a left curly brace there and press enter. The right one gets added for us automatically. And what we're going to do is move the print line statement into the block. So what I mean by that is I'm going to come down here and I'm going to copy this line, going to cut it out and paste it into that block now. So basically what that's checking is to see whether age is now greater than equal to 0 and it's less than equal to 100. And then, and only if both of those conditions are true, will it print out this output. So if age is in the range, it's going to print that. But if age isn't in the range, what we should do is print out a message to the user. So let's do that. So we're going to come down here after the closing right curly brace and add else. Now open another code block by typing a left curly brace, and the right one gets added for us automatically. Then we're going to print out invalid year of birth. Alright, so this else will be executed if age is out of range, meaning if age is a negative number or the number entered is greater than 100. So let's actually run this to see that it works, confirm that it works. So for the year of birth, I'm going to start this time by typing -20. And now we want to enter the name. So we're going to enter the name as Tim. And now it exits the program, but it prints out a message to say invalid year of birth. So that's good. It's now actually working, whereas it wasn't working before. And we'll run it one more time, this time with a valid value. So I'll enter the value again, 54. Actually, that was an error, so I'll just close that program down and we'll start it again. So year of birth should be 1964, and my name, Tim. And it's still calculating it correctly, and you can see that the output we're getting is consistent with us entering a valid age. Alright, so far so good. The next step is now to cater for the fact if the user enters some letters for the year input. Now for that, we want to use a method called hasNextInt, which returns a Boolean type. So let's type the code in and then I'll discuss it. So we're going to come down, I'll close this window down first, so we've got a bit more space. And I want to put the code here after the year of birth entry here. So I'm going to put that here. So what I'm going to type there is Boolean. This is immediately after the enter your year of birth system output. We're going to put Boolean hasNextInt equals scanner dot hasNextInt and semicolon. So that method that I've used there, that hasNextInt, that checks to see if the next input entered is a number, in this case an integer, because we're using the int by component. However, it will not remove it from the scanner. So in other words, it'll ask the user for input, and check to see if it qualifies as an int. If it doesn't qualify, the method will return false. So what that means is it allows us to avoid generating type errors when using nextInt. But we need to add some extra code to add to the flow so that is the case. So what we need to do is check to see if the Boolean, our hasNextInt, is true, and if it is, we can continue with our calculations. So to do this, we need to add all our code below the Boolean except for the scanner.close inside an if statement. So let's go ahead and add that if statement and close it out after the last else. So I'm going to come down here and put if hasNextInt. We're going to open a left curly brace and the right one gets added automatically. We then need to take a copy of all of this code up to but not including the scanner.close. I'm going to cut that and paste it in the code block. So in other words, after the left curly brace and before the right one. I'm just going to clean up these blank lines here just so it's a bit more readable. So now we're catering for the fact that it is a valid number, but if it isn't a valid number, so in other words the hasNextInt up here, if that returns false, currently nothing will be printed. But we want to inform the user that they've made an error, so let's add an else to the hasNext if statement. And just as a side note, notice how we're able to test one if statement inside another if statement. So we've got an if here on line 14. We've also got another if here on line 22. So that's pretty cool. So let's add this else. Then the else is going to be now down here. And you can see that IntelliJ helpfully puts a line to show you where the if is. You can see there's a line below the first if there telling you that this is all related. There's also a line down here telling you that this part's related. So we know we want to put an else there to handle the situation where the user hasn't entered a valid number. In other words, if the hasNextInt Boolean returns false. So if that's the case, what we want to do is print out a message. Unable to parse year of birth. Alright, so now that we've written that code, we've catered for an invalid number being entered. If a number hasn't been entered using valid digits, so in other words, numbers, not using numbers, using letters or symbols, we've got that catered for, and we've also got it catered for the fact that an age has been entered outside of a valid range that we've defined as being between 0 and 100. So let's run the program. We're going to type ABC for the year of birth. Notice that straight away we get an error, unable to parse year of birth, because we used letters, and the program immediately exits and it doesn't do any more processing, including the fact that it doesn't ask for the name. Now the reason it's not asking for the name is hasNextInt at a value of false, and we're only running this code here if the value was true. So that's why that didn't get executed. The only thing that got executed was the else here, because hasNextInt was false, and we got the error message unable to parse year of birth. So let's try it again. In year of birth, I'll enter a valid one. We're still getting the right results if a valid range is entered, and we'll do one more. Let's just try another one. We'll try 101 this time, which we know is invalid. Tim, invalid year of birth. So that's also working. And just to do one other final test, we'll put a -20 again. Tim, and we're correctly getting an invalid year of birth showing again. So I'll end on a positive note. Let's put a different number here, 1980, Bob, and it's correctly returning 38, which would be correct in 2018 if Bob was born in 1980. Well, so as you can see that we've got an application now. We've built in some logic and some validation. And although there's only a few lines of code there, it's managed to do quite a few things to validate, to make sure that numbers are entered, and also a number within a specific range as well. So the application is interactive, meaning that we can interact with it by entering some data to the console. And you saw in this case the year of birth and name, and the application then calculating the user's age based on the year of birth. Alright, so that's all for this video. I hope you got a lot out of it. Let's move on now to the next one. Alright, it's time now for a challenge. This is the Reading User Input Challenge. So the challenge goes like this. Read 10 numbers from the console entered by the user and print the sum of those 10 numbers. And you want to create a scanner like we did in the previous video. use the hasNextInt method from the scanner to check if the user has entered an int or an integer value. Now if hasNextInt returns false, print out the message invalid number to the console, and you want to continue reading from the console until you've read 10 numbers in. Use the nextInt method to get each number and add it to the sum. Before the user enters each number, print out a message, enter number hash x, where x represents the count, 1, 2, 3, 4, etc. And as an example there, the first message would look something like enter number hash 1, colon, the next enter number hash 2, colon, and so on. And the hints, use a while loop. Secondly, use a counter variable for counting valid numbers. Thirdly, close the scanner after you don't need it anymore, and the project we'll be creating should be called Reading User Input Challenge. So that's it. See if you can figure it out. Pause the video now and try out that challenge. And once you're ready to see my version of the code, come back and we'll go through it. So pause the video now. Okay, welcome back. Hopefully you managed to get it working. So let's break down this challenge into smaller pieces. First off, we need to read 10 numbers from the console, as well as count them, and in addition calculate their sum. After we have 10 valid numbers, we're going to break out of a while loop. In this instance, we should set a condition in the while loop which checks that a user, when a user, has entered 10 valid numbers. So let's start off by creating the scanner and also its setClose method on the next line so that we don't forget to add that later. Alright, so firstly scanner equals new scanner, and in parentheses it's going to be system.in. I'm going to select that option there to bring up the pop-up. I'm going to make sure I select java.util, and you can always know that you've got the right one there incidentally. If you can see in the import, it shows java.util.scanner. Alright, and then next I'm going to type in scanner.close, parentheses, to close that off. Alright, now we're going to add two variables, counter and sum. So moving forward, all the code we'll be adding will be written between these lines, the scanner definition on line 9 and the scanner.close on line 12. So for the variables, let's start by typing int counter is equal to 0. Then we'll also do an int sum equals 0. Now the counter variable is going to count the valid numbers, and the sum variable represents the sum of the counted numbers. So our next step is to loop until we read 10 numbers that the user of the application has entered into the console. For this purpose, we're going to use a while loop. So I'm going to start with a while loop that never completes, so while true. And the opening and closing curly braces there. So I said that it never completes, so what does this while true actually mean? Well, by typing in, as we've done there, and I'll just fix this typo before I continue. So by typing in while true, we're effectively creating an endless loop, or a loop that doesn't complete, since the condition that we've entered in parentheses on line 14 is always true, because true itself is always true. In other words, the loop never ends, and it's a situation we have discussed in previous videos. But later in this video, I'm going to show you a solution to this challenge without using an endless loop. Now, since this type of loop never ends, we need something to break out of it. In this case, a break statement. So when the counter reaches 10, as in once the user has entered 10 valid numbers, we can set a break statement to exit out of the loop. Now, we could also accomplish the same thing without a break statement by checking the counter variable, but it's a good idea to get used to using a break statement. Before the user starts entering numbers, we should print out a message that instructs the user on what to do. First though, I'm going to create an int variable called order and set it equal to counter plus 1. So int order equals counter plus 1. And notice that we've got an error here. We've got this unreachable statement. And the problem here is that IntelliJ is telling us, look, you've written a statement here that never exits. It never finishes, so it's an endless loop. So consequently, the code can never get down to here. But you'll find that that disappears once we've written some code in this while loop that actually allows us to break out of the loop. Alright, so getting back to this order variable on line 15, well, this will impact the message we print to the user. So the idea is to substitute order for x in the message, enter number hash x, so that the user is informed on when to enter the first number, the second, and so on. So let's print out this message. So we'll do a system out. We're going to put enter, number, hash, close double quote, plus, order, plus, then we'll add a colon there, and close off the double quote like so. So that's going to print out that message to the user. Now, since order is equal to count plus 1, the number will increment each time it cycles through the loop. So this means that after the user enters the first number, they'll receive a prompt for the second number and then the third, etc. Now, technically, we could write this all on one line, but it might look a bit complicated and become difficult to read. So we've broken it down into 2 lines here. So the next step then is to add an if statement and use the hasNextLine method. So let's define a Boolean here. So Boolean, and we're going to call this one is an int equals scanner dot hasNextInt. Now, if you recall, this hasNextInt method will check if a valid number has been entered into the console. Now, if the user enters a wrong value, then this hasNextInt method will return false, meaning our isAnInt variable will be set to false. And if that's the case, we don't want to increment the counter. So we need another if here to test for that value. So we're going to put if isAnInt. Now, if parsing does fail, in other words, it's not a number because the user's entered something other than a number, then we should print a message stating that an invalid number was entered. So to do this, we need to add the else and the code block to do that. So I'm going to put that down here. Else, open our code block, and we're going to print out a message there, invalid number. So that handles an invalid number now. And let's also take this opportunity outside of that code block down here, after the else statement's finished, to handle the enter key being pressed and remove any invalid input from the scanner. And this also ensures that we don't accidentally end up in an endless loop due to unforeseen input. So I'm going to type scanner dot next line. We'll put a note here to remind us what it's for, so it's going to be handle end of line enter key. Now, inside of our if statement, we can start generating the code that will read the number and save it as a variable. This is the code here that's currently empty. So we're going to begin by typing int number equals scanner dot next int. Now, you might be wondering at this point why I haven't put the next line method that we've got down on line 27. Why haven't I put that on line 22? In other words, right below the line I've just typed in. Well, if the user was to enter an invalid number, the else statement would run and print invalid number. However, since the user did enter content, it would need to be read and removed from the scanner before additional content is entered. So since the next line call handles that by reading input and not storing it, it needs to be after the else statement, not in the if statement. Otherwise, the invalid content would not be removed and our application wouldn't run as desired. Now, another solution would be to add next line right after the next int method here, and then add another next line inside of the else statement. However, generally speaking, it's not recommended to duplicate code, which would be doing there would be putting 2 lines of code in when 1 would suffice. So let's leave this next line after the else statement where it is now, which again handles invalid input and the enter key by reading the line and not storing the input. Alright, so now that we're retrieving numbers from the user, let's work on the remaining steps, calculating the sum of the numbers, incrementing the count, and then breaking out of the loop once we've got 10 valid numbers. First though, let's increment our variable counter, so counter plus plus. So we've got a valid number, so we're incrementing that count, and then we want to add the current number to our sum variable, which is of course the sum of all the numbers entered, so that's going to be sum plus equals number. So we're incrementing counter and adding sum inside of the if statement, since we've only got a valid number when the if condition is true on line 20. In other words, if parsing succeeds and we have got a valid number, then obviously the number is valid for that reason, and we can add the number to our sum and increment the counter. Alright, so next we now need to break out of the loop once we reach 10 numbers, and this is where the counter variable comes into play. So let's add the following if statement that breaks out of the loop once counter equals 10. So we're going to add a check there. on that next line, we're going to put if counter is equal to 10, and add a code block, and then we're going to type break. And notice when I typed in that break there, that the error immediately disappeared on line 34, and that's because IntelliJ has now determined that there is a way to break out of this loop, and therefore this line of code can be reached. This is pretty cool that IntelliJ is smart enough to figure that out for us. So again, to refresh, our current loop was an endless loop which would never complete, because while true that we've entered on line 14 remained true and therefore kept looping. By adding this break statement, as we've done now on line 25, we can break out of the loop once our counter reaches 10. The last step now we need to add to our program is to print out the sum to the console. Now we've got two options here. We can type it inside of the if statement, where we're checking the counter, or after the while loop. Now I'm going to type it after the while loop, so I think it's more appropriate to put it there. So it's right down literally on the line before the scanner.close. I'm going to print out sum equals, in double quotes, plus sum. Alright, so that's it. One of the possible solutions to this challenge. So keep in mind, in programming, there's almost always multiple ways of doing things. One example of that was I just mentioned that I could print out the sum within the while loop instead of outside of it. Alright, so let's try running it. Alright, we're down here, we've got enter number #1, as you can see on the screen there. So I'm going to press, or enter rather, number 10, press enter. It's asking us for number 2. So let's try to enter some characters to test the number checking capabilities. So I'm just going to type ABC and press enter. You can see it's got an invalid number, then it's re-prompting us again to enter number 2. So that's good. It means that the counter variable only incremented when the number was valid. Now if we enter another invalid number, the same thing will be printed. Fred. Same thing again. So again, we've got enter number 2 and invalid number showing. And again, that was achieved rather with the help of the order variable. If you recall, we set order equal to counter plus 1. You can see that now on line 15. And again, remembering that counter started with 0, which is why we're adding the plus 1 code there on line 15. So changing the number count adds a nice dynamic quality to the messages the user's receiving on the console. Right, so let's go ahead now and finish the program by entering the other numbers. So enter 20, 30, 40, 50, 60, 70, 80, 90, 100. And you can see that the program's nicely exited after I entered 100, and sum equals 550, which is the correct sum for those 10 numbers. So that's my solution to the challenge. Hopefully you got something similar or along those lines, bearing in mind it certainly didn't need to be identical. Now, just before I finish the video, I mentioned that there's a solution that doesn't involve using a break statement. So instead of while true, what we can do is change the condition to something that would eventually become false, such as counter less than 10 for argument's sake. So what we could have done instead, and this is another example of how there's nearly always multiple solutions to a given problem. We can comment this line out. Well, actually what I'll do is I'll duplicate it, and I'll comment that line out. And instead of while true, what we'll do is we'll put while counter is less than 10. And now that I've done that, I could comment out the break statements since we no longer need that. We don't need to put a test here for 10 because we've got a test there now on line 15. So let's test that to make sure that it still works, but that's the only changes we need to make. We'll do the same thing, 20, ABC, ABC, Fred, that's still working. 20, 30, 40, 50, 60, 70, 80, 90, 100. So as you can see, there are different ways to solve a challenge. This challenge and literally any code you write. And it's going to be true of many, perhaps most things that you face in the real world. So the point I'm making here is your code doesn't have to match what mine looks like 100%. It's completely okay as long as the end result is you've managed to meet or exceed the challenge requirements. So that's it. I hope you've enjoyed this challenge and got a lot out of it. Let's now move on to the next video. And in that one, I'm going to set you another challenge. This time it's a minimum and maximum challenge. So I'll see you in the next video. All right, time for the next challenge. This is the minimum and maximum challenge. So you want to read numbers from the console entered by the user and print the minimum and maximum number the user has entered in that session. So before the user enters each number, print the message enter number. Now if the user enters an invalid number, break out of the loop and print the minimum and maximum number that has been entered so far in that session. And you want to use an endless while loop here and create a project with the name min and max input challenge. So that's it. See if you can figure out that challenge. Pause the video now and try it out. And once you're ready to see my version of the code, come back and we'll go through it. So pause the video now. Okay, welcome back. Hopefully you managed to get it working. All right, so let's get started. First thing we need to do is create our scanner as well as the close method call. So let's do that, as we've been doing in recent videos. So scanner is equal to new scanner, parentheses, system.in. We need to make sure here that we choose the right one. Scanner.java.util. And again, you'll know you've got the right one there. If you see import java.util.scanner. Let's add the code to close the scanner. It's a good habit to get into. And the code we're going to be typing will be in the middle. All right, we now need to read the numbers and then from them, figure out the minimum and maximum number. I'm going to start by adding two int variables to track the minimum and maximum numbers. So int min equals 0, int max equals 0. Next, we want to loop through until the user enters an invalid number. So I'm going to do a while true and then let's loop again, as we discussed in the previous challenge. And again, the while true loop, which we're doing there on line 14, creates an endless loop. In other words, a loop that doesn't complete. To stop it, we can use a break statement that will break out of the loop when the user enters an invalid value. Now to test whether it's a valid number, we'll again use the hasNextInt method and break out of the loop when it returns false. Before the user starts entering numbers, we need to print out that message that we had in the challenge. So let's go ahead and do that first. Enter number. All right, so the next step now is to get the input from the user. So let's create, as we've done previously, Boolean variable here for Boolean is an int equals scanner dot hasNextInt. Now I'll space this out so we can read it a bit better. And again, we've got this warning here talking about unreachable code because we haven't yet coded a way to exit out of the while loop. So what we're going to do there is put a test as we did also in the last challenge, if is an int. Else what we're going to do is out of the code block, if it's not an int, we'll add that as well. We'll also go down outside of that if code block and put scanner dot next line. And again, we've talked about the reasons why we need to use that. We'll just put handle input because we know now what that's all about. All right, so in this case, the else block will execute if the Boolean variable is an int is false, meaning that the user has entered an invalid number. So if that is the case, the code will move to the else statement. So therefore, our break statement should be in the else component of our if loop, since our goal, of course, was to break out of the loop when invalid input was entered. So we simply need to add a break in the else. And again, the error disappears on line 28. Now I've done that. All right, so let's add some more code now in the true component of the if statement. So down here, we're going to type in here int number equals scanner dot nextInt. All right, now we need to do some tests here. Firstly, we want to test if the number is greater than the current value of max. Then we want to assign that number to max, since it would then presently be the largest value. So to check that, we can use an if statement that tests if the number is greater than max. So let's do that test. We'll type it in. We're going to put if number is greater than max, and open up a code block, and I'm going to type max equals number. Okay, we'll just space this out so it's a bit more readable. Right, so in summary, once the user's entered a valid number, meaning is an int is equal to true, we're then testing if the number is greater than the current max. We're doing that test on line 23. If it is, we assign that number to max, meaning that, or ensuring rather, that max always has the maximum number assigned to it. Now to get the minimum number, we can do something very similar, but the test will go doing a less than test instead of a greater than test. So it'll be if number is less than min, then we're going to put min equals number. So again, you saw the logic was very similar to max. The difference being here that we're now looking for the minimum value from the user's input. So if the number entered by the user is less than the current minimum, the condition will test as true, and the newest input that has been entered will be replaced as the current value for min. Alright, so we've got most of the code done. What we now need to do is print out the minimum and maximum values after the while loop. So let's go ahead and do that. Get into the bottom of the while loop after the loop has ended, before the close, the scanner.close. We're going to put min equals plus min plus, comma, max equals plus max. Alright, now before we finish this challenge, there is a small bug that we have in this code. Firstly, I'm going to demonstrate the bug, and then we can implement a solution. So let's run the application first. Alright, so I'm going to begin by entering a few numbers. So I'm going to start with 1, 1, 2, 3. And I'm going to break out of the loop by typing the letter A. You can see once I've done that, the output is now min equals 0, max equals 3. But technically, that's incorrect. And the reason is we've never entered the number 0. The minimum number we entered was 1. So consequently, there's a small bug that we've associated with our logic, but there are multiple ways to fix it. Now, one way would be to use a Boolean flag that checks if the user is entering the first number and then sets min and max to that value. Another way is to set min and max to extremely high and low int values respectively. Let's first see the solution with a flag, with the Boolean flag. So right after the max, we'll close this window down so we get a bit more space. So right after our max declarations up here at the top, I'm going to type in Boolean first equals true. So I've added the flag Boolean first equals true. Now you might be wondering what I mean when I say flag. Well, basically it's a Boolean value, meaning that the value can be true or false. In other words, on or off. So that's why Boolean is often referred to as a flag. It can only have two states, true or false. So we've set this Boolean to true while we wait for the user to enter an initial number. When the user enters the first number, what we can do is use an if statement to set the Boolean, the flag here, to false, as well as setting both min and max to the first number's value. By setting the flag to false after the first number, the next numbers will not meet the conditions of the first, and therefore will not be replaced. So let's put the code in and you'll see what I mean here. So I'm going to come down and put the if after the scan next line. So I'm going to put if parentheses first, like so. Now, as previously stated, after the user enters the first number, we want to set the Boolean flag to false, since the user can obviously only enter one first number. And the next we'll set the minimum and max to the value of that first number. So for that code, we're going to start by typing first in the code block in the if we've added here. We're going to type first equals false, min equals number, and max equals number as well. So let's review this if statement one last time. First, we're checking if the first number flag is set to true. We're testing that on line 24, which it should be since we set it to true before the while loop. You can see the code there on line 13 on screen. When the user enters their first number, the if statement will execute. In other words, the code from line 25 through 27 will execute, and that line 25 will be first set the first flag to false. Now when the user enters a second number, the if statement won't execute, and that's because first is now set to false. So in other words, this if statement will truly only execute once when the user enters the first number, and then never again. At least that's the theory, but let's actually check it out to make sure that it works. Alright, so we're going to run it again as you saw. We're going to enter the same three numbers again. 1, 2, 3, then an A to exit. This time we get the output min equals 1 and max equals 3, indicating that our solution worked this time, because of course previously the min value was set to 0. We never saw the minimum value get set to 1. Alright, so let's run the application again. This time we're going to enter the values in reverse. 3, 2, 1, and then an A again, so that the parsing fails. And we still got min equals 1, max equals 3. Alright, so that's worked. So that's one solution. Using a simple flag here with Boolean, we've easily managed to overcome that bug. So that's it, the challenge is now complete. I'm just going to close down this window. But before we finish the video, I'm going to show you one more solution that doesn't require a flag. Now, the idea with this solution is to set max to the minimum value that an int can hold. Now, we can do this because the user will only be able to enter a number that is greater or equal to the minimum int value. Now, the maximum int value is approximately positive 2 billion, while the minimum is approximately negative 2 billion. So with that in mind, if we set max to negative 2 billion, any number the user enters will always be greater than negative 2 billion. So this means that we don't need a flag to ensure that the values of max and min are set to numbers that the user enters, as long as they enter at least one number. Now this might sound confusing, but it should hopefully become clearer in your mind once you see the code. So first things I'm going to do is comment out the code that's using the flag. So I need to comment out the line here where we declared the first flag, and also the code that did the test there with the if. I'm going to comment that out. Then this time, instead of setting min to 0 and max to 0, we're going to set min to the maximum value an int can hold. I'm going to come up here to min on line 11. So I'm going to set that to 2,147, 483, 647. So that's the minimum value, and then for the maximum, I'm going to set that to minus 2,147, 483, 648. So in review, our min value is set to the highest number an int can hold, and our max variable to the lowest. Any number that the user enters will always be either equal or within the range of those two numbers. So let's test this out to see if it works. So we're going to enter a number 1, 2, 3, or a number range 1, 2, 3, and A to exit. And you can see we've correctly got the output min equals 1, max equals 3. And just to be 100% sure, let's run it again. 3, 2, 1, A. We've still got the same result, min equals 1, max equals 3. So that's another solution to solve that particular problem. And again, as mentioned in previous challenges, it's possible to generate correct solutions with code that's different. So if your code doesn't match mine, that's completely okay. The main goal is to get the application working while meeting the challenge requirements. And you can even expand on the challenge and add more features and so forth. Alright, so just before I end this video, I want to show you the same solution but using constants. So every primitive number type has constants that represent the minimum and the maximum value that primitives can hold. Now, you may have noticed how cumbersome it was typing up the minimum and maximum int values. I typed on lines 11 and 12. Since we know that we need the maximum and minimum values an int can hold here, what we can do is we can come back up here, say to minimum for example, and type integer, the capital I, dot max value, instead of actually typing up the numbers. And you may recall that in a previous video we used the integer class with methods like parseInt, but this class also contains these two constants, min value and max value. So I'm going to add max value on the next line then. Integer dot min value, I should say. I think I said max value. So we've got assigning minimum to the integer dot max value and max to the integer dot min value. So basically we've got now these two things set up, and these are the constant. So for example, with max value, that's the maximum number an int can have, and for min value, that's the minimum value an int can have. And that's exactly what we need in this case. So keep in mind that every primitive numeric type has these max value and min value constants in their respective wrapper class. And again, we'll talk more about wrapper classes later in the course. So instead of typing those large numbers, we can just use these constants, which were easy to type, but also easy to understand what we're trying to achieve. All right, so the code's pretty much the same as what it was before. Let's test it to make sure that it still works. So I'm going to enter a value 1, 2, 3, and A to exit. We get the same results. All right, let's do one final test now. I'm going to run it one more time. I'm going to enter the values. I'll enter some really big numbers this time. So we'll do 2, 1, 4, 7, 4, 8, 3, 6, 4, 5, which is very close to the maximum number. And I'll enter a number that's very close to the minimum, negative 2, 1, 4, 7, 483. We'll do 633. And A to exit. And you can see now that we've got the minimum correctly set to the negative 2147483633, and the maximum now set to 2147483645. All right, so that's it. I hope you enjoyed this challenge and learned a lot from it. I'll see you in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
Welcome to section 7 of this course. Tim Bachalka here, and this is part 1 of a 2-section part detailing or dealing with object-oriented programming. So part 1. So you're going to learn about the fundamentals of object-oriented programming, specifically classes, objects, constructors, and also the first of 4 major components of object-oriented programming, which is inheritance. So let's make a start on that and get you up to speed with object-oriented programming. In this video, we're going to start talking about object-oriented programming, and in particular about classes, which is a fundamental component of object-oriented programming in Java and actually other languages for that matter. So firstly, we need to understand what objects are. They really are the key to understanding this object-oriented terminology and technology as such. So what I'd like you to do is just have a look around in the room or the area that you're sitting at right now. And if you do that, you'll find that there's many examples of real-world objects. For example, I'm sitting here and I can see a computer, I can see a keyboard, I can see a microphone, I can see shelves on the wall, I can see a door. All of these are examples of real-world objects. And I'm sure if you look around wherever you are, you can see a number of those as well. Now, real-world objects have 2 major characteristics: the state and behavior. So state in terms of a computer might be the amount of RAM it has, the operating system it's running, the hard drive size, the size of the monitor, those types of things. An ant, for that matter, has got state as well. For an ant, the state might be the age, the number of legs, the conscious state, whether the ant is sleeping or is awake. But looking at behavior for a computer might be booting up, shutting down, beeping or outputting some form of sound, printing something, drawing something on the screen, and so on. All of those are behaviors for a computer. For an ant, behavior might be eating, drinking, fighting, carrying food, those types of things. Now, software objects, which are a fundamental part of object-oriented programming, they're very similar to real-world objects because they also consist of state and behaviors. Now, a software object stores its state in fields, and we know fields as variables, and they expose their behavior with methods, which we've talked about before. So that's what an object is in object-oriented programming terms. So where does a class fit in? Well, think of a class as a template or a blueprint for creating objects. So as it turns out, you've been using classes all along, and I'm sure that you've seen the keywords public and class in the code we've completed to date, and you can actually see that on the screen right now, public class main. So what that is, that's actually a statement which creates a new class in Java. So a question that might come up at this point is, why do we need to bother about classes? What benefit do classes give us in our everyday programming? Well, think back to the basic data types we've worked on, the primitive data types that we've explored so far, int, shorts and those types of things. They're all basic data types, but they are fairly limiting. There's only so much you can do with them. So a case could be made here that a class can be thought of as a powerful user-defined data type, sort of an extra data type. That's not really correct in the true meaning, but it gives you an idea of what classes are. They really enable you to have sort of a very powerful user-defined type where you can create something way more powerful than a regular primitive type like you've been dealing with in the past. A regular data type on steroids, if you will. So to take this a little bit further, let's create our first real class. As you can see on the screen, every time we create a new project, it actually creates a new class for us, and it calls the class main with a capital M, and it also creates that method, the lowercase m for the method name. That's created automatically by IntelliJ when we create a new project, but let's actually go ahead and create a brand new class ourselves. So to do that, we need to make sure the project area is open. We click on here to open that up, Click on down where it's got src for source. We want to select where it's got our package name. Click on that, right click, select new, select Java class, and we're going to create a class with the name of car, C-A-R, making sure the first letter is capitalized. As is recommended when you're creating classes in Java, the first letter should be an uppercase letter. But I will be talking more about naming conventions for classes and variables actually in a later video in this course. So firstly, what I want you to notice is the package. You've seen that before at the top, but also check out this line, this public class car. So that's actually the statement to create a new class with the name car. Now, incidentally, if you want to see what's happening behind the scenes, you can come over here and you can right click car. And on my Mac, I can click on reveal in Finder. If you're on a Windows machine, I think the equivalent command is show in Explorer. When you click on and do that, what it does, it shows you the directory and also shows you the files that are in that directory. And as you can see here, IntelliJ has automatically created a file called car.java, and it's in the folder Timberchowka. Now, if I actually open that out, the top there you can see classes is the name of the project that I assigned. Then there's an src folder, which stands for source. And looking on the left-hand side, you can see in the project view, you can see that that's showing you that's src as well. Then it's created another folder called com, and then another subfolder of com called Timberchowka. And that's how packages work in Java. So you can see that we've got a folder. Whatever you type with a dot, that's a subfolder of that name is automatically created by IntelliJ. So what's happened here is that IntelliJ has created this file, car.java, and that is a Java source code file. And every time you create a new class, this is what's happening behind the scenes. It's creating that class in a particular folder. Now we could open that up and have a look at it. And if I go into the Mac text editor, we could see it mirrors exactly what we've got in IntelliJ. So it's always a good idea to know what's happening behind the scenes when something is created in IntelliJ. And invariably, when we're dealing with a file, it's creating a file in that particular folder. All right, so moving on. So public and class, as well as package for that matter, are all Java keywords. Now the public keyword is an access modifier that we use here to determine, what access we want to allow others to have to this new class that we're creating. So the word public means unrestricted access to the class. Now usually, and at least initially anyway, you're going to be using public for pretty well all your classes, but other access modifiers we can use include private, and that's where no other class can access that class. Protected, which allows classes in this package to access your class, and you can also remove the access modifier completely if you prefer, but we'll be talking more about what these access modifiers are in future videos. For now, generally speaking, just go with the word public, knowing that that means that other classes that we create have got access to this class without being restricted. So that's our class defined, but at the moment it's not very useful because it doesn't actually do anything. Literally, we've created a shell. It's like creating a new blueprint. So remembering that a class is a blueprint for an object that we're going to be creating. And in this case, it's like virtually, starting out on a brand new blueprint and we haven't done anything yet. We've just, we literally, if we were creating a blueprint for a house, this is page 1. We've called the blueprint the name car and we haven't done anything else at this stage. So what we need to do is create some variables that are part of this class. Now to date, you've seen variables used inside a method. And they were called local variables because they're local to or actually belong to that method. And you cannot access those local variables outside of that method. And you saw that also with code blocks that we created in past videos. Once you access that, you cannot access those variables outside of that block. Now classes allow us to create variables that can be seen and are accessible from anywhere within the class that we're creating. Now these are known as class or member variables, but most commonly you refer to them as fields. Now when you're creating a field for a class, you need to also specify an access modifier that works the same way as the access modifier for a class definition did. Now, as a general rule, when you're defining fields in Java in a class, you go with the access modifier of private, unlike the class where we've gone with public. So what private means when talking about fields is it's or what we're really doing with it, is we're adhering to encapsulation, which is a key fundamental rule of object-oriented programming. So encapsulation in Java is used to hide the fields and methods, which we'll see later, from access publicly. So it really means that the internal representation of an object is going to be hidden from view outside of the object's definition. So in other words, the internal workings of the particular object, and again, an object is going to be created from our template, from our class. So what we're doing is we're only allowing the internals to be accessed by this class or by this object. We're not allowing outside access to that. Now this will make more sense as the video progresses. So what we're going to do first is we're going to create some fields for our class. So let's get started and do that. So what we need to do is so I've just gone into the curly braces within the car class. So we need to type private int doors. So notice how I've typed the word private. In the past, when we've created variables, we haven't needed to do that. We've just actually typed the data type and the name of the variable. In this case, we also need to add that access modifier. So generally, you will always go with private, and I'll explain more as we go through. So these variables are actually the state component for a car. So these are characteristics of a car, if you will. So we're going to have doors, how many doors it's got. And let's go with, say, the number of wheels. It'll be an int as well. And let's go with the model. And we're going to go with the string there, so we can just type freeform text for what the model is. And let's say we do the same with engine. And let's finish off with color. So what we're trying to create here is a template of the variables that would be part and parcel of a car. Now obviously if we're creating a real application, there'd be a lot more fields. There could literally be hundreds of different fields that we could add for a car. We're just keeping it simplistic to start with. So this is the state component when we talked about state and behaviors. This is the state of the car, if you will, which we're defining as fields. So what we've done there is we created a very basic class and we've defined 5 fields. So the next thing we need to do is we need to create an object from this class, because if you recall, the class is just the template. We need to create an object which will sort of take that blueprint, that definition that we've defined in the class, and create an object that we can start using. So to do that, what we need to do is we need to go back to the main class, and of course the main class was created automatically by IntelliJ when we created a new project. I'm going to double click into that over here on the left. Now what we can do in here is we can actually build an object and base it on that car. So what we now need to do is create that object. So how do we do that? Well, what we do is, I'll delete this code for starters. We're in a method now, so we're going to type a local variable that's local to the main method, as you can see in here. And we type car. Now notice when I type car, it's come up with com.timberchalker.car, so it knows that this car has been defined over here. So as far as Java is concerned, that is now a data type. It's actually a class, but we can treat it as a data type. So we can type car, and let's create our first object, and let's create a car that I've always loved, which is a Porsche. Porsche. So this is the keyword. This is how we define an object of type car, and we call it Porsche. Now the other thing you need to do is when you're creating a new class, you need to initialize it. So to do that, instead of just leaving it like that, we need to type equals new and car. And I'll press enter there. And notice how the 2 brackets were automatically added by IntelliJ and put a semicolon there. So what we've done there is we've created a new data type called Porsche, which is of type car. So in other words, we've created an object called Porsche based on the template car. So that's one individual object that we can work on. We can also create another one. We could do car Holden. Holden is an Australian brand car, so we can do the same, equals new car. So we've now got 2 separate objects that we've created from the template from the main class called car. Now the thing is, we can't do much with those as yet. So for example, how do we go about accessing the state variables, the fields in other words? Now just by that definition, what's happened behind the scenes is the object has been created, but there's also extra functionality that Java has added to these objects for us automatically. And to see that in action, we can type Porsche. If we type dot, now all these things here are actually variables or methods that are accessible from the class put from this object. Now you might be thinking, well, what's this equals, hash code to string, etc.? These are added automatically by Java whenever we create a new object. So you could say that they're inherited from the Java functionality when we created the car. So to be correct, what's happened is the car class has inherited these from a base Java class, but we'll talk about subclassing and those types of things later. It's probably not the time to do that now because we're starting with the basics. The bottom line here is Java has added all this code and this functionality automatically, and you're also free to add extra things, which we'll be doing shortly as we move forward anyway. My point is, at the moment though, if we look at the list of things that are available, you can see that these equals class and so forth. But as we scroll down and have a look, there's different keywords and so forth, but we don't see anywhere our model, the number of wheels and so forth. It's not showing up there. So how do we access those? Well, if we go back and check out the car class again, remember we defined these all as type private. And what private means is don't allow a class outside of the car class to access these variables. If you wanted those to be accessible outside of the car Java class, we could do that by changing this access modifier to say public. So I'll just change the one, I'll just change the model. And if we go back and check this out now, and now if we go back and put a dot in there, you can suddenly see that the first thing that appears now is model. So suddenly model has actually appeared. So at that point we could type Porsche.model equals the Carrera. Hope I've spelled that right. So what we've defined is for our object Porsche, we've told it that the model, remember the model is the field, which is the state, if you like, for the car. Porsche.model equals Carrera. So we've defined the type. Now that's one way of accessing the data, but it's not actually a good way because it really more or less violates the rules of encapsulation. Because what we should be doing is making sure that that functionality is restricted and placed in the car Java class. What do I mean by that? Well, let's go back and I'll just show you what I mean. So we'll go back to car.java. We'll change that back to a private again. But what we'll do is we'll create a method now. So we're going to create a method, and when you're in a class, when you create a method, that is then attached to all the objects that you create for that particular class. Now in the past, the only methods that we've created are static classes, and static classes aren't really the same thing, but we'll be talking more about those later. For now, let's create a public method. Okay, so this video is getting a bit long, so I'm going to pause here and we'll come back in part 2 and continue with our discussion of classes. In the last video, we started talking about object-oriented programming and classes. Let's continue with that in this video. Okay, moving forward, let's create our method. And what we want to do is allow the method to update the model. So how do we do that? Well, we start by typing public. And again, that's the access modifier. So what we're doing is we're saying we want to make this method that I'm about to create publicly accessible, much as we've done the same with the class. So we're going to put public void because it's not going to return any data. We're going to call it set model. Now notice when I started typing, IntelliJ came up automatically and said, oh, do you mean set? And it's got automatically created a start of a method for all 5 of our variables, our fields in this class. I can come down here and just press model and press enter over set model to say that's the one I want. Then we're going to introduce a parameter, and the parameter we want is going to be a string because we want the other class to send the string that they want to be created and for it to be updated in here. So we're going to call that string model. Now that introduces another problem. Now the problem here is we've got 2 different types of variables. If you think about it, we've got the field that we've defined up here called model, but we've also got another one in here called model. Now obviously this one here is a parameter that's been passed to this method, and this first one up here is a field. So how do we distinguish between the two? Because as far as IntelliJ or Java is concerned, we need to be specific to say which one we want to update. What we want to do here is we want to actually update this field with the contents of the parameter that was passed to us and update it in here. So how do we do that? Well, it turns out there's a way to do that, And the way to do it is you type the word this when you're referring to the field for the class. So in other words, if we want to update or access this particular field, we put this, the keyword this, before the definition. So we type this dot, and notice when I type model, it automatically comes up for us from IntelliJ. Press enter, equals, and then if you type model, you notice here to the left, IntelliJ is showing you the little p, which stands for parameter. So it's saying now this is going to be the model. Because we haven't specified this dot for the second component, IntelliJ is going to default to that for us automatically, like so. So what that's done now, it's said update this variable here with the contents of the parameter model that was passed to us. So that's a way of updating the model using a method instead of trying to access it directly. So just to show you how that would work, if we go back to our main class again, you notice we're getting an error here now, and that's because I changed the definition, which was the access modifier, which was public, back to private again. So it's saying it can't access it. So if we actually want to update that model, the better way of doing it, we put Porsche dot, and notice how set models come up. Set model. And what we do, we pass a parameter. Is seen parameters passed with methods before, like so. And that is a way of then calling the set model method for our object and updating it with the value Carrera. Now if we run that, it'll seem to work, but we won't get any output. And of course the reason we won't get any output is because we haven't anywhere outputted anything. So we just got a message to say that it completed with execode 0. The other thing I want to show is what happens if we don't do this, cut this first line here, the new car. So if I comment that first bit out there, so we've just got a variable like so, comment that out. So we've just defined the variable. We haven't initialized that. We haven't put equals new car. Already this is IntelliJ saying variable Porsche may not have been initialized. So it's sort of saying there could be a problem there. Because unlike data types, there isn't default values with classes. You have to initialize them using the new keyword. Now if I don't do that, this is what happens. We get an error to say that it may not have been initialized properly. So that's a compile error, but also if we don't initialize it, we can actually get it to crash. So for example, if I undo that change, this is like more or less forcing it to crash. I sort of trick IntelliJ now and run it. We actually get an exception, which you can't see too much there, but it's basically get an error, null pointer exception. And what that essentially means is you've defined a type called Porsche, but it hasn't been initialized. In other words, we haven't created an object from the template, which of course is the class. So that's where you need to make sure the new is always executed. And again, I sort of more or less just fudged this to actually cause that error to come up anyway. The bottom line is I'm trying to say here is that make sure when you're creating classes, you always have to use this new, the keyword new, and then pass the name of the class, and then the brackets. You need to initialize it with the new keyword as I've shown there. So run that again to see what it does. It now works, but of course it's still not doing anything. So let's go back and add the ability for us to print something out. So I can go back to our car class. Let's create a getter. So we've created what's called a setter. And again, these are standard methods, but it's just the word set, and you see they're about to use the word get. These are known as setters and getters in Java. So I'm going to create a getter now called public string. We want to return the type. I want to return the type get model this time. Then we return this dot model, like so. And just to be clear there, when I type that, this dot model, you notice the little F by IntelliJ is saying this is a field, just so you know. So if ever you're unsure of the type of variable or the type of anything you see on the screen here, IntelliJ is really quite smart at showing you. So F in that case for field, M for method, so on and so forth. And there's also other things here. The little padlock is telling you that is a private method because the padlock is on. But in the case of method, the padlock is open, which is saying this is a public method which is accessible to other classes. So you'll get to know these various graphics in IntelliJ, which are really there to help you at a glance see what a particular variable or method is set as. So in this case, we want to return model. So I'm going to do like so. And we've now got a method that can be called elsewhere to return what the current model is. So I'll go back to our main Java. And if we now do a system output, and we'll put model is plus, and we can type Porsche dot. Notice how there's two now. There's get and there's also set. So we go up to get now. Get model is the method we just created. So now if we run that, model is Carrera. And just to show you what happens there, let's try also putting a print before we've actually set the model. So obviously this line here, this first line, is executed before we've actually set the model to Carrera. So let's see what happens when we do that. You can see it says model is null. Now null is the internal default state for a class and also for a string. And if you recall, if we go back to our car.java, string is actually a class. So string is a class. It's actually a special class, and we'll be talking more about string and how it sort of bends the rules, and it doesn't need to be created in the same way that we're creating this car. So it's early days yet, but you can see the functionality of Java is allowing us effectively, because string is a class, we can have a class within a class, if that makes sense. So the model, engine, and color are all classes in their own right because they're of type string, and they're stored in a class of the name car. So you can see that how this concept of a user-defined data type is coming back, because we've introduced really a super data type of type car that has got 5 fields: doors, wheels, model, engine, and color, but we've also assigned some methods to it as well. So both the state and the behavior are part of the class. Very, very powerful, as you can see. So let's talk about the concept of why would we want to use getters and setters. So we'll get rid of that first line because we don't need it anymore. But why are we doing the set model? What is the advantage to that? Well, what that means, by using the .set model, what we could do is, for example, we could go back to our car.java and we could have a look in this set model method, our setter, and we could do some validation. So what we could do is we could put string valid model equals model dot to lowercase. So we're going to convert whatever was passed to us to lowercase for starters. Then let's introduce a test to make sure that the only values we're going to accept from this class, for this method, are going to be a type Porsche and Holden. So what we could do in here, we could put if valid model dot equals. Now dot equals like this is a way to test that a particular value of string is equal to another type. So we can, by typing the valid model, which is again of type string, dot equals, and typing in what we want to search it against in brackets, we can actually test that, and that will return true or false if they're equal. So what we're saying is if the model equals a Porsche, and then we can put the or operator, or valid model dot equals Holden. If that's the case, then what we can do is we can assign that value. So only if what was passed to us equals a Porsche or a Holden will we allow our internal state, our internal model field, to be assigned the value that's been passed to us. And that might be because we've actually got a rule when we're creating our class to only define those two types. So we can maybe want to put something like else this dot model equals unknown. So note also that I'm putting this dot model equals model, so I'm still saving what was passed to us, but I'm actually testing it. When I'm testing it in lowercase, so we're testing for all scenarios, but we're actually testing the lowercase version. So we've now got that set up. So if we go back here to our main Java again and have a look, and actually I think I got that wrong. I'll change that to, it'll be Porsche because it's the type. We'll say it's a Carrera instead of Porsche because that was the name of the car, and we'll put Commodore, which is a type of Holden car. So we're now actually testing the model to see whether it's Carrera or Commodore. Sorry about that. So we go back here now and do a test. Now at the moment we're passing Carrera, which should be a valid one. So if we run that, model is Carrera. So that accepted it. The fact that we're actually displaying that the model is Carrera, if you have a look at our code again, we're only saving it to this dot model if it's a valid Carrera or Commodore. Otherwise, we're setting it to unknown, and then this is then printing that out with the get model getter. So if we actually change that, say to a 911, which is another type of Porsche, we run that, we get model is unknown, and that's because in our validation, in our set model method, which is our setter, we're actually explicitly only allowing Carreras and Commodores to be valid models that are created for this object. So you can see how it's very useful to have this type of functionality, the validation, not done at this point, but done within the car object itself via the methods that we're setting up in our class. So it means when you're creating a class, what you're doing is you can set up all the rules relating to that class, what is valid, what is not valid, and have it all set up, all that functionality set up within the car class itself, so that is inherited when we create the object. What that means is the code that is creating objects can't make invalid objects, so to speak. In other words, it can't create, in this case, for example, it can't assign a model number that we haven't defined as being valid in our car class. So that's the reason. So that's really the whole concept of encapsulation, is that by not allowing people to access the field directly, and by forcing them in this case to assign the model using a method, we can really make sure that the data within our objects are more valid and have been validated and are correct. So that's enough now about the basics of classes. In the next video, what we're going to do is we're going to start talking about constructors, which is this component here. So when we actually issued that command new car, it actually used a constructor to create the car object. So we're going to talk about constructors, what they are, and how to create our own constructors in the next video. So in the previous two videos, we've been talking about classes. It's now time to continue and talk about constructors, which are an important part of using classes. But before we do that, it's challenge time. I'm going to challenge your understanding of the previous two videos. So here's what I want you to do. Okay, so the challenge is to create a new class which is going to be used for a bank account. So the fields for the class will be the account number, the balance, in other words, how much money is in the account, the customer name, the email address, and the phone number. So you want to also create getters and setters for each field, and in addition, create two additional methods for this class. The first method should allow the customer to deposit funds. So that method should then increment the balance field with the amount, but also should allow the customer to withdraw funds with another method, and that method should deduct from the balance field, but also not allow the withdrawal to complete if there are insufficient funds. And I think I spelled there wrong there. And what you want to do is also create various code in the main class. I'm talking about the one created initially by IntelliJ, just to confirm that your code is working. And you may also want to add some system.out.print lines to the two methods above as well to confirm how much was deposited or withdrawn. So pause the video and try that out, and when you're ready to see my solution, come back and we'll go through it. Okay, how did you get on? Did you figure it out? Let me show you my solution. So what we're going to do is create firstly a new class. I'm going to go into my package as before and select new, and I'm just going to call this Java class account. Now we also need some fields. So we need the account number. That's going to be, I'm going to call that user string, but you could use a number if you wanted to. And we also need the balance. So I'm going to use a double for the balance. And we'll put account balance. And the customer's name. Email address. And their phone number are all going to be strings. And probably there, I'll get the name right, I'm just going to actually put balance and number. You could use either, but because we're already using, because the class name is called account, we can assume that we know that it's based on an account. So therefore, when we're creating a field called number, it's for the account class. So we don't really need to put the word account there in twice. Okay, so next, create getters and setters. Now I'm going to show you a trick to quickly create getters and setters using IntelliJ. Because it's such a common thing that you do regularly, there's a way to automate that, and that's to go into the code menu and click on generate, or you can see on my computer Command N does the same thing. So click on generate, and you can click on either getter or setter, or getter and setter. So I'm going to click on both. Then you need to select which fields you want. So you can select one or more, and you can see the F indicates that these are private fields, and the F of course is fields. Click on OK. Once I do that, IntelliJ creates all the code for us. How nice is that? Saves you a lot of typing. A heck of a lot of typing. So that's a pretty cool way to very quickly get getters and setters created. So make sure you check that out. We'll be referring to that for other types of code generation later. So that's all our getters and setters created. Next, we need to create two methods, a deposit and a withdrawal. So we're going to start off by creating the one for the deposit. So it's going to be a void method. So it's public void deposit. And I'm going to pass the parameter of the deposit amount. And then to add to the balance, we wouldn't want to do balance equals deposit amount. That's going to replace the amount that's currently set for the balance. What we want to do is add to the balance by using the plus equal operator. So that will then add to that balance. And for clarification, we could use this to make sure that this is the field that we're updating. So that's the deposit function. And for the withdrawal one, we'll do public void withdrawal. And we're also going to find the amount, and we're going to pass the amount that we want to withdraw. So we'll put withdrawal. So what we can do now is test to see whether there is sufficient funds available to process the withdrawal. So the easiest way to do that would be to put if balance, the current balance in the bank account minus the amount that we want to withdraw. If the balance of those two is less than or equal to 0, that means they haven't got enough money. So we're going to print out a message. We'll put only balance available, withdrawal not processed. Now I'm adding this bit of video after this original video was recorded, and that's to let you know that there's a slight bug with the withdrawal method. Now you can see that I've actually got balance take withdrawal amount less than or equal to 0. And in fact what it should be is balance take withdrawal amount less than 0. And you can see the equivalent or the correct code on the screen now. Now the reasons for that is going to be explained fully in the next video when we actually go through the code to change it. But I'm bringing it up here now just in case you're looking at that and wondering what's going on. Now the reason that we want to do a less than instead of less than equal is because we only want to check to see if we're going into the red. In other words, if we're going into the minus. It's quite possible if you had $10 in a bank account to withdraw $10, leaving a balance of 0. So that's quite possible, and you would do that any time you close the bank account. So consequently, the less than or equal to is actually wrong here because we're actually showing an error. We're going to print out an error if the withdrawal is unable to be processed if the balance is less than 0, not if it's equal to 0. But again, this will be fully explained in the next video. I'm just bringing it to your attention here. Else, so what's happened in this case is we were able to process it. We're going to put balance minus equals withdrawal amount. So we're going to deduct the withdrawal amount from the balance, and we're going to put withdrawal amount processed, remaining balance equals balance. So that's it, that's the withdrawal method. And here we might just put deposit amount made, new balance is plus balance. To be consistent, I should really be putting this dot. Obviously it hasn't got a problem because the parameter that we're passing isn't the same name, but one thing I'd like to tell you to do is to try and be consistent with your naming and your code. So it's good to, if you're going to do it sometimes, you should be actually doing it all the time. So in this case, I'm going to use this dot when referring to fields in our classes. Okay, so that's our functionality for our account class. We've now written everything and we've got our deposit and withdrawal functions working. So what we now need to do is go back to our main class and test that this is working. So what we're going to do is go there and we're going to create a new one first. We're going to call it account, Bob's account equals new account. And we're going to do a test first. I'm going to put Bob's account dot withdraw 100. Let's try running that and see what happens. Only 0.0 available. Withdrawal not processed. So that's good. It's doing what it should be doing. So that's good. Next we'll do a Bob's account dot deposit. Let's deposit $50. And then we'll try and do the same withdrawal again, and that should still fail, but it should give us a different balance. Let's try running that. Only 50.0 available, withdrawal not processed. That's good. So now we type Bob's account. Let's do another deposit of $51, and we'll do a Bob's account dot withdrawal from 100, which should now succeed because we've got $101 at this point, so we should have a remaining balance of $1. Let's run that. Deposit of $51 made, new balance is 101. Withdrawal of $100 processed, remaining balance is $1, 1.0. So that's it, that's the challenge. Hopefully you got something along those lines. And you've now really created your own class for the first time, which is fantastic. Now, of course, we didn't actually set any other values there. What we could have, if we wanted to set the other values, what we would have had to done is something like Bob's account dot set number 1, 2, 3, 4, 5 for argument's sake for the account number. Now, Bob's account dot set initial balance of 0. Bob's account dot set customer name Bob Brown. Bob's account dot set customer email address, my email at bob.com, and Bob's account dot set phone number 087 123 4567. So you can see there's lots of typing there if we wanted to set all those variables to set the field values for the first time. And you imagine if you had 10 or 20 or 30 fields, it could be quite a bit of code to actually do that. But there is another way of doing this when you're creating an object for the first time using a class, and that's using constructors. So what you can do with a constructor is you can essentially do all these commands here to set the initial parameters or the initial values of the fields and any other initialization you want to perform in the one hit using a constructor. So let's see whether we can replace this by editing our account.java and adding a constructor. Well, firstly, it turns out that a constructor is actually created for you automatically by Java. And when you actually type new and then the name of the class and in brackets, this is actually calling the constructor. So this is actually calling that special method that creates the class. So its purpose is to physically create the object from the class for us. So I'm going to go into our account class and we're going to create our own constructor. So what we're going to do is do a public, and you have to type the actual name, the exact name of the class. Notice how I didn't put a void or a type there, a return type. A constructor is something special. It has only the access modifier and the name of the class, and then also the number of parameters like so. So what I'm going to do just to show that this is working, I'm going to put empty constructor called. So I've done nothing else there. I've created the constructor. This is normally created for you automatically, but what I've done is I've physically typed it in. So what will happen is when we go to compile this Java, we'll look at that and go, oh, okay, you're creating your own constructor. I won't try and overwrite it. So if we run this now, what we should see at the top is that message that I've just added. You can see here at the top now, empty constructor called. So when we type a new account with brackets with no parameters, that actually executed this constructor for us automatically. So that's what the purpose of the constructor is for you to essentially initialize the object that you're creating and do whatever else you want to do at the time that object is being created. So it's only ever called once at the start when we're creating the object. So let's let's add another constructor and set some parameters up so we can set these values in the constructor instead of using the setters. So to do that, you come back here and we can create another constructor. Because like methods, constructors can be overloaded. We can have more than one constructor provided we change the number of parameters. So I'm going to change the number of parameters. I'm going to go with public account. Now what we're going to do here is we're going to initialize the number. So I'm going to put string number double balance string customer. You notice IntelliJ is trying to help us now. It's going, okay, clearly you're creating a constructor. Which fields do you want to be included as parameters in this constructor? So it's quite handy. So we're going to specify all of them. So string customer email address and string, we're going to the next line, customer phone number. Then what we do is we just do this. You've seen this before, the setter. This dot number equals number. This dot balance equals balance. This dot customer name equals customer name. This dot customer email address equals customer email address. And this dot customer phone number equals customer phone number. So that's now setting the field values in the constructor. But what we now need to do is call that constructor when we're creating the object. So to call the constructor, what we do is instead of having no parameters, we pass parameters like 1, 2, 3, 4, 5, 0.00, Bob Brown, my email at bob.com, and 087 1, 2, 3, 4, 5, 6, 7. Then we close off the bracket and we fix the typo I've made there. I forgot a quote by the looks of it. Okay, so that's the line now. Now that we've done that, these are now redundant. We don't need to do that because the constructor has done that for us. And just to confirm that that works, we can go back here and we can put count constructor with parameters called. If we try and run that now, account constructor with parameters called, because we've specified new account and then the parameters, and the values have been automatically updated in the constructor. And we can confirm that by just typing a few out. We can do Bob's account dot get number, Bob's account get balance. Let's just do those two and run that. And we can see 1, 2, 3, 4, 5 and 0.00. So they were actually updated by the constructor. Now I mentioned before that constructors can be overloaded, so we can have more than one. But the other thing, so in line with that, what we can do is we can call one constructor from another constructor. Now that sounds a little bit confusing, but the idea of that would be, if let's say that if an empty constructor is called, in other words, one without any parameters, perhaps we want to create the object with some default values. So what do I mean by that? So in this scenario, what we could do is we could say, okay, if the empty constructor is called, we want to actually call the constructor with all these parameters, and we want to issue some default values for the 5 fields. So to do that, we type this. This is a special case of the word this, and we type brackets, and we pass our parameters. So we might put 5, 6, 7, 8, 9, and the balance, $2.50. Customer name, default name, default address, default phone. So what we're doing there with this is a special use of this which you won't see anywhere else. This is calling another constructor within a constructor. So what we're saying here is, look, if you try and create an object from this class and you don't give me any parameters, these are the parameters that I'm going to use when creating this object. This is optional. It's not something you have to do, but there can be situations where you want to do that, when you want to make sure that the class is created with all the fields set, and you could issue some default constructors to do that. And one other thing to keep in mind is with using this to call another constructor is what you need to do is make sure that's the very first line that's executed. So in other words, we couldn't paste in the system.out.println line there as the first line in the constructor, because it's going to actually come up and say the call to this must be the first statement in constructor body. So this is just constructors we're talking about. It has to be the very first line that's called. I'm going to set that back. So we'll go back to our main class and run it again. Now it's doing exactly the same as you can see, but let's change that now. And we'll set it to new account, and I'll just comment out the rest. So empty again, like so, and we'll just comment out the next line as well. Now if we run it using the empty constructor, we should actually get the right values from our default constructor. And you can see what's happened here. The account constructor with parameters was called, and the empty constructor was called. So they were actually both called, as you can see there. The reason for that, the reason why you see it in that order, of course, makes sense. If you come back here to the account.java, the very first line of the account constructor called the other constructor. It was only after that was finished that we actually printed this out. So you can see that what happened was the default constructor, the empty constructor, was called first. Its first line called the other one, which then printed out that message. So if you're looking at that and thinking, well, why is the account constructor with parameters called first? It wasn't actually called first. It's just displayed that way with our messages. So as you can see, 5, 6, 7, 8, 9, and 2.5 was actually passed. So it's obviously working. The default constructor was working. All right, I'm going to pause the video here and let's come back in the next video and finish off our discussion about constructors. In the previous video, we talked about constructors. So let's now finish off our discussion about constructors and come up with a constructor challenge. So the other thing you may have noticed looking at this code is that I've actually updated the fields directly. I haven't used the setters. So there is an alternative. What we could have done is we actually could have done something like set number. And the advantage of that would be, of course, if we had some validation in here that was testing for valid numbers and those types of things, we could actually execute that code as well. Now in Java, there is conflicting opinions as to which is the best approach, because you'll find out in the next video when we start talking about subclassing, in other words, talking about inheritance, that this won't always work. So the general rule of thumb is it's actually better to save the values from the constructor directly to the field rather than calling the setter, because as you'll see in the next video, there can be scenarios where this code that's in the setter isn't executed. So by going back and actually doing the code directly, in other words, going back and setting it to this dot and whatever the field name is, you're guaranteed that the field values will be initialized. So that's my general rule of thumb is with constructors is don't call setters or any other method other than another constructor within those constructors. And the other reason for that is this is the point in the constructor where the object is being created. So consequently, some aspects of the initialization may not have been finished while you're in the constructor. And that's the other reason that there's an opinion out there that suggests that you shouldn't be calling other methods or even the setters within a constructor code. But we can talk more about that later if needed. For now, again, go with what I've suggested, which is just saving the field values directly rather than calling setters or any other method. Now, the other thing I want to show you is another shortcut that IntelliJ's got. Let's just assume that we wanted to create another constructor that we only passed the customer name, email address, and constructor phone number, and we want the other two parameters to be created automatically by the computer. So we could do that by creating another constructor, but we could also come up here and do that with IntelliJ because it's got the capability for adding constructors as well in that generate option. I click on generate. I'm going to select the first option, which is constructor. And it asks which fields do you want to include in the constructor. So which ones are we going to have passed to us? In other words, which are the parameters to be used? So I'm going to select those three, customer name, email address, and phone number, add those. So there's our third constructor now. And you can see it's only updating the three fields. So that's one way of doing it. But of course, the disadvantage there is that our number and our balance haven't been automatically updated. So what we could do is we could put this, and then we can assume that it's going to be the default account number we might say is 99999. and the default balance is $100.55. Then we'll pass the customer name, the customer email address, and the customer phone number. So you can see what we've done there is we've defaulted 2 parameters. So we've come up with what the default is because they weren't specified, and we've still gone back and called our major constructor. This is the one that actually updates all the fields. So you will find as you start creating and writing more complex code, it's not unusual to see multiple constructors like this. And in that situation, often you do all your initialization in the one constructor, like you can see here, and the other constructor should just call that major constructor. That's a good way of doing things, and it often leads to really good coding because you're not having to duplicate code or duplicating initialization in more than one place, so on and so forth. So how would we call that? Well, we'd call that very much the same as we've been doing before. We could do create a new class here, account, Tim's account equals new account, Now you can see what's happened there is we've got 3 options now. IntelliJ is saying, okay, there's 3 constructors that have been created for this class. So I'm going to start typing. You can type, put Tim at email.com, and 12345 for the phone number. I've got a 1950s phone number. Okay, so you can see how that constructor was created, and of course we can confirm that's working. Tim's account dot get number to make sure it's a number, and we'll just Tim's account dot get and just make sure the name is actually set. Let's just run that to make sure that it's working. 99999, which was the default account number here, as you can see, and the name was Tim, which of course is what we passed here. So that's constructors. You'll see those used extensively in Java, and of course we'll be using that a lot in this course as we move forward because they are a very important part of creating objects from classes. Okay, so it's time for a challenge. I'm going to comment that code out. Okay, so the challenge is to create a new class called VIP Customer. So it should have 3 fields, the name, the credit limit, and the email address. So what you want to do is create 3 constructors. The first constructor should be empty, and that should call the constructor with 3 parameters that we're going to create, passing on any default values. The second constructor should pass on the 2 values it receives as parameters and then default the third value. And the third constructor should just save all the fields that it receives because it's going to have the 3 parameters, one for each field. Create getters only. You don't need setters because we're saving the field values using the constructor. And see if you can figure out how to create getters only using the code generation feature of IntelliJ. And of course then test and confirm it works by writing code in the main class, which was generated by IntelliJ. So pause the video now, go away and give that a go, and when you're ready to see what my solution is, come back and we'll take it from there. Okay, how did you get on? Did you figure it out? So let's get started. I need to bring up my project window. Now it's Command 1 on a Mac. If you want to know what it is on your system, go to Tools, Windows, and look at the shortcut. So I'm going to create a new class called VIP Person. You need to have 3 fields. Okay, like so. And the first constructor should be empty. The second one should pass on the 2 values. Third constructor should save all the fields. So what we can do is we can use the generation features of IntelliJ. Create a constructor. So the first one we're going to do is create the constructor with the 3 values. And this is when you want to start getting used to IntelliJ code generation features because it's really a much quicker way of creating stuff than typing it. Really handy for this sort of stuff. So the second constructor needed only 2 parameters. So let's default the email address and just save the first 2, like so. And we'll come back to that in a second. And the third constructor, of course, is just going to be VIP person without any parameters. And that's going to call this. So we'll set that one up first. It's going to be default to default name 50,000 and email address default@email.com. This one here, we don't want to save the fields. We want to call the other constructor. So what we want to do there is we've got the name of the credit limit. So we're going to put this name credit limit, and we're going to default, and we'll call it unknown, just so we know that it's different. So that's our 3 constructors now that are created. You can see the first 2 constructors call the third constructor, and the third constructor is the only one that actually does save the values into our fields. And using our code generation, I'm using the shortcut, but if you don't know what that is, go into the code menu, generate, and look at the shortcut for your platform. Now this is the one I wanted to show you, getter only. You don't have to do getters and setters. You can just type getter, type the 3 or select the 3 you want to create getters for, press enter, and there's our 3 getters created. Very nice. Okay, so what we now need to do is confirm that this works. So we just go back to our main class. We're going to do VIP person. We'll put person 1 equals new VIP person. And we should be able to do person1 dot get name, just to confirm that something's worked there. We assume that 1's okay, that all of them are. So VIP person 2 equals new VIP person. And of course we've got one there with 2 parameters, which were the name. So we'll put Bob and 25,000. And the third parameter should be created for us automatically. And we'll do similar thing. person2.getName, which should be Bob because we've passed that. And VIP person 3 equals new VIP person Tim, $100, and tim@email.com. And print out person3.getName. So that should be our code now to test that this is working. Let's run that. Default name was the first one with no parameters. So we just go back and check our code. We can see the default code was default name 50,000 and default@email. So that's working. And for the second one, I'll run that again. Bob was the second one, so that's confirmed that that's worked. And the third one was Tim, which we've confirmed is also working. And what we could do there, if we really wanted to be sure, we could actually just do a printout also of the person3.get email address, just to make sure that it is set to tim@email.com. We'll run that. tim@email.com, which of course hasn't been used anywhere else here as the other constructor. So that's it. That's constructors. Hopefully you've got a lot out of that. We actually had a student who actually looked at this particular lecture after it went live and noticed a small problem. So I just want to go over and show you the discussion in the course first. So this is from Brian N, and he actually said that when creating the withdrawal method's if statement, the operator, which is less than equal, should be a strict inequality less than, and that's because if you deduct the withdrawal amount from the balance, a valid amount is still having a 0 balance. And the way I've coded it in the example is that it's either less than equal rather than less than. So what I'm going to do is show you what I mean and make the change just so you can see how the code was meant to look. So if we go back to the code and have a look, so the problem is if we go into account, and specifically the withdrawal method, at the moment you can see the withdrawal method, the test is if the current balance, this dot balance take, the withdrawal amount is less than or equal to 0, then we're coming up with an error that the withdrawal won't be processed. When in actual fact, It's quite valid, say if you've got $100 in your bank account, to withdraw 100 and to leave a balance of 0. That's quite valid, but this code as it's written, because we're using less than or equal to 0, won't actually work. It won't actually process it if you're entering a withdrawal amount that's once deducted of the balance leaves you at exactly 0 money in your account. So to get this to work, what we need to do is uncomment some of this code because the problem is in the account class. So I'm going to actually briefly comment this out because we're not using that for this part of the video. Comment that out and actually uncomment this component here. And if we go back and just have a look at our constructor again, just to familiarize ourselves with it again, we've actually got a balance of $100.55, which is given to us by default if we're actually using this particular constructor. So just to confirm that, if we go back and go into the main class again, and we'll put current balance is Tim's account.getBalance. And if we run that, just to verify that's the amount of money that's in there, current balance is $100.55. Okay, so far so good. So now if we try and actually withdraw that exact amount, so we put Tim's account dot withdraw, and the exact amount, which was $100.55. So we try and do that and process it. Current balance is 155, only 155 available, withdrawal not processed. Well, that's clearly an error. And we should be able to withdraw $100.55 because that's what the amount is in the bank. So we go back to our account class. And the problem is in this withdrawal method, where it's got less than equal, less than is the appropriate operator we should add here. We only want to actually cause this to come up with an error if deducting an amount of the balance leaves us with an amount that is less than 0 instead of less than or equal to 0. So now if we go back and run this again, we actually get withdrawal of $100.55 processed, remaining balance is 0.0, which of course is quite valid. So that's it. I just wanted to add this little part in here just to be correct with the code. Thanks again to Brian for pointing that out, I should say. And just to let you know, I've also updated the source code. So if you do download the source code, you'll actually see that fix in the code as well. So in the next video, what we're going to do is we're going to talk about inheritance, because each time you create a class, what's happening is Java is actually giving you those extra fields and methods that we talked about previously. So we're going to talk about inheritance and how that works in the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
In the previous video, we started working with objects and classes and got up to speed with that. It's now time to talk about inheritance, what that is and how that applies to objects. So to do that, the best way to get started is to go back and talk about physical objects again. Because the thing is that different kinds of objects have a certain amount in common with each other. Using an example of computers, you could say that an iMac computer, an Android Nexus 9 tablet, and a Dell PC all share the characteristics of computers, in that they've got RAM, random access memory, ROM, read-only memory, they've got the current state as to whether it's like the device is on or off, and so on. So they share common characteristics, but yet each of these devices add additional features that collectively make them different to each other. For example, an iMac runs the OS X operating system. It's got an Intel CPU. It's got a hard drive, USB ports. An Android Nexus 9 tablet, for example, runs on Android, the Android operating system, and it's got a touch screen for input. A Dell PC runs Windows. It's also got an Intel, but maybe an AMD CPU. It's got a hard drive, a mouse, and so on. So you can see that while objects can share similar characteristics, they can also be different as well. So what object-oriented programming really allows us to do is to create classes to inherit commonly used state and behavior from other classes. And one of the best ways to actually show inheritance, rather than giving you a heap of slides discussing it, is to actually immediately go into some code and actually start working through some scenarios and showing you what inheritance looks like in Java code. So what I'm going to do is I'm going to start with the analogy of an animal. So if you think of any animal, they have certain behaviors that are shared across all types of animals. For example, animals all eat. They all are able to move in some way. They've all got a body. So that's some of the basic things. But what about things like, for example, legs? Well, no, not all animals have legs, because snakes and worms are an example of an animal without legs. Eyes? Well, no, not all animals have eyes, because there's varieties of spiders, for example, that have no eyes. Do they all have a brain? Well, yes, actually they do, although it does depend on the definition of a brain. But essentially, yes, they've all got that basic mechanism. And they've also got size, and also have got a weight as well. So what we could say was we could create a very basic class that we could actually apply to each and every animal out there, and that we know that any animal would have these traits. So we're going to create a new class now and call it animal, and we're going to add some state and behavior, in other words, fields and methods, to model that. So let's do that now. And I've created a new class. I've created a new project here called inheritance. So I'm going to create a new Java class. I'm going to call it animal. And we talked about those states. So we've got brain, we've got a body, a size, and a weight. They're going to be our 4 fields that we're going to apply. So I'm going to create a private field for each of those. And we're just going to have an integer, private integer brain, private integer body, private integer size, private integer weight. And we'll also add another one and a name, because of course every animal has got a name. So we're going to create a string for that. So we're not going to be too worried at this stage as to what the contents of these fields are. I've defined, as you can see, an integer data type for the brain, body, size, and weight, and likewise a string for the name. It doesn't really matter too much at the moment as to what type of data we're going to put in there. The main thing is what we're trying to do is just come up with characteristics, state in this case, of things that all animals have got. We're also going to create a constructor so that we can construct an animal class easily. So I'm going to just use my command to create a constructor, and I'm going to specify all 5 as parameters, like so. Then the other thing we'll do is we'll create a getter for each of those classes, for each of those fields as well, in case we need to access that later. So that's the basic definition of an animal. That would be the base class, if you will, that all our other classes that we're going to create, sort of subtypes of animals, will base themselves off. So another example of an animal is going to be a dog. So what we're going to do is create a class called dog, but we're going to inherit from this animal class. So I'm going to go and create a new class, call it dog. In Java terminology, if you want to inherit from another class, in other words, you want to be able to access in some fashion the state and behavior that's in that other class, you use the extends keyword. So we type extends, and we type animal. You can see that IntelliJ has come up and given us a choice of animal. So by doing that, we're able to use the state and behavior that's been defined in the animal class in this new dog class we're creating. Now you notice straight away that I've got an error. So the error that on the screen is saying there's no default constructor available in the animal class. So what that's saying is, look, I'm trying to use the animal class, and to do that I need to be able to call the constructor for that class. That's what we need to do when we're creating a new class that extends from another one. We need to be able to call that other constructor class to initialize it. And if you recall, if we go back to the animal class, we've got a constructor there so we can initialize those 5 parameters. So what we really need to do is make sure that we've got a constructor for the dog class that calls that other class. In other words, calls the constructor for that other class. So to do that, generate, and just in case you're not sure how I'm generating that again, click on code and generate. You can see to the right, in my case on a Mac, it's Command N. You'll go to your operating system and there'll be a shortcut for your environment, for your platform. So choose that to generate. And constructor, and you can see that I just literally just select the constructor, and IntelliJ actually filled in the rest. So what's happened here is you can see that automatically there's those 5 parameters that actually are dealing with the animal class, name, brain, body, size, and weight, have been created as parameters to the dog class, to the dog constructor, in other words, and then this keyword super has come up. So what super means is to call the constructor that is for the class that we're extending from. So in this case, the super class, or sort of the big class that this class is extending from, using the extends keyword, or inheriting from, to be more precise. So what this allows us to do is to initialize the animal class, and if you recall, the dog is actually part of an animal class. So we've defined it as an animal class. We're saying it's based on the animal class, but what we can also do is we can add more features to this dog class, things that are unique to a dog and not just a very generic animal, if that makes sense. So that first line there, what that's done, that's initialized the basic characteristics of an animal, namely the name, the brain, the body, the size, and the weight in a constructor. But what we can also do at this point, because we're now working in the dog class, is we can assign extra state, extra fields in other words, and extra behavior, that is methods, that are unique for a dog and aren't necessarily applicable for an animal. So for example, we could create some fields, private int eyes, because remembering that not all animals have eyes, but all dogs do have eyes. Private int legs, not all animals have legs, but dogs do have legs. All dogs have legs. Private int tail, all dogs have a tail. Private int teeth, dogs have teeth. And maybe another one would be private string coat would be the type of coat, whether they've got a sort of a long silky coat or a short coat, fur, those types of things. So they are unique characteristics relating to a dog that we're adding in addition to the animal state. So you can see what we're doing here is really what we're saying is the dog has got these fields here, these characteristics, but in addition they've also got these base characteristics, but we've defined those in the base animal class because they aren't specific to a dog, and that's why we're extending from that class. So this is what Java and other object-oriented programming languages allow you to do, is to create a base class that's got the basic information to work on, and then you can extend from that class, which indeed is very powerful. Because what that also means is not only with the fields, we can also add specific methods. Like for example, going back to our animal class now, we could introduce some behaviors and we could add some methods for those. For example, all animals have to eat. So we could create a method called eat. And we won't worry about the functionality for now, but it's there anyway. Another one might be move. That's 2 methods that are unique to all animals. All animals have some mechanism, some way to move, and all animals eat in some way, shape, or form. So by doing that and making it public, if we go back to the dog class, what that means straight away is that function, that method is now available to the dog class. So the base class we've defined, we've said all animals have to eat, are able to eat. Because we've specified that method in the animal class, this method is inherited from dog automatically, and we'll be able to use that, and I'm going to show you how to do that shortly. So let's look now at this constructor, because there's 2 components that we need to do now if you think about it. When we're creating a dog and we're modeling a dog in computer terms, we've got those parameters that have been defined there, namely the name, whether it's got a brain, the body, the size and the weight. But we also need to initialize those other characteristics as well, namely the eyes, legs, tail, teeth and coat. So really what we'd need to do is we would need to initialize that in our constructor and not just the fields that we've defined that initialize just the animal class. Because we're now in the dog class, we're creating a constructor for the dog, we need to work with these extra parameters. So one of the things we can do is we can be a little bit smart with our definition here and the parameters that need to be passed. For argument's sake, we can say, we're going to say that all dogs have got brains. So instead of having to use it as a parameter, I'm going to remove that parameter there. And I'm just going to put past the number 1, which really is just our way of saying is all dogs have got a brain. Likewise for the body, we're going to do the same thing. We're not going to put it there as a parameter because we're going to say all dogs have got a body. So you can see what I've done. I've still initialized the animal class, It's still got the 5 parameters it needs, but what we've said is we know that all dogs have got a brain and a body, so we're not going to force the programmer who's creating the dog class to have to define those. But what we will do is we will add these as extra parameters. So we'll actually add a parameter for the eyes, for the legs, for the tail, for the teeth, and for the coat. So you can see we've used some of those parameters already, and those parameters that are in the animal class have been sent on, and we've executed this constructor, and those fields have been initialized. What we now need to do is initialize the other ones. So to do that, and you've seen this before, we just do this.eyes equals eyes, this.legs equals legs, this.tail equals tail, this.teeth equals teeth, and this.coat equals coat. So effectively now we've initialized all of the fields relating to this dog. And of course, some of those fields were the basic fields that were part of the animal class, and the rest were part of the dog class because they were unique characteristics related to a dog and not necessarily an animal, which may, as we've talked about before, may not have some of these features. Okay, so let's try starting some of this code now and start using some of this code, creating a new class to see how this works. So what we're going to do first is we're going to define an animal class. We're going to create an animal, a basic animal class. As you've seen us create new classes before, we're just going to create that just to confirm that it does work. So we'll be creating a new animal class. We've just got the one constructor, and you can see we need to do a name, so we'll just call it animal. Then we need a body, so we'll say that we need a brain, so we'll put 1, comma. We need a size, so we'll just say it's a default 5, weight 5. So you've seen that before. There's nothing particularly new there, but that's just a definition for a base animal. It doesn't really make a lot of sense because we want to be specific. We want to work in this case with a dog. So to do that, to create a dog class, we're going to type dog equals new dog. And remember, the parameters will change a little bit here. So we might call this dog a Yorkie. And we might say the size is 8. The weight might be 20. 2 eyes, 4 legs, 1 tail, 20 teeth for argument's sake. And we might say it's a long, silky would be the type of coat. So that's now initializing a dog. Nothing particularly new there. You've seen that before. I'll just fix that typo. But one of the things we can do, this is where inheritance really starts making sense, is we can use some of these functions, because remember we defined these 2 public functions, eat and move. So what we could do, we could type dog dot, and notice the eats come up. So we're able to use the method eat, even though if we look at our dog class, you can see there's no method definition for eat. So where's the eat defined? Well, remember the eat was defined in this class, in the animal class. So this is one of the features of inheriting from another class. Because we've defined the method eat as public, we've said this method is publicly accessible. The dog class can see that, and it's extending animals. In other words, it's inheriting from the animal class, and as a result, we're able to use the eat method, even though it's not actually part of the dog class. And just to confirm that, what we'll do is we'll go to the animal class, and we'll add a system output, and we'll put animal.eat called, just so we know that where it's actually come from and which part of the code is being executed. If we run that, and you can see animal.eat called. So just by that process, even though we're accessing the dog class, it knows that the dog is a type of an animal because we've inherited from the class animal. And as a result of doing that, we're able to access the functionality that's part and parcel of the animal class, and we're able to use the eat method. But it does get better than that, because what we can also do, going back to the dog class, we can override this eat method. So what we can say is, well, like a dog eats in a particular fashion. For example, the dog chews its food. other animals don't necessarily chew food, but the dog does chew its food. So what we might want to do here is we might want to create a private method called chew. And this is something unique to a dog. And we'll put something like dog.chew called. But then also what we can do is we can use my generate command again. And I can come over here and I can put in override methods. Now what override does, and I'm going to select that you can see straight away it's given us a list of methods, including the constructor, that are available in the animal class. So in other words, it's worked out and says, okay, I know that you're extending from the animal class. These are the methods that can be overridden. In other words, we can create a version of that same method that exists in the animal class, but make it unique for the dog class. And that's something that is inherently very powerful. And the other thing I just want you to point out here is, you notice this java.lang.object. I'm going to talk about that in the next video. But what that is that every single class you create, even though it doesn't come up and show you via the use of the extends keyword, does actually get extended. You are extending this object class, which is a special class created by Java. But more on that in the next video. For now, let's override the eat method, which is part of the animal class. We're going to create a special method for the dog for eating. So I'm going to click on that. And Java will come up automatically and give you this @override symbol. And that's to remind you that we're overriding a method that is in the super class. In this case, it's in the animal class. So now both the dog class has got its own eat method, and also the animal class has got its eat method. So what we can then do here is we can just put something to indicate that we're calling it here. We'll put dog.eat called. And let's also put chew, and we'll say the process of a dog eating food is that it's chewing. So we're going to call our method that is unique to the dog class. And then we're going to use super.eat. And what super means is call the super equivalent of that class. So super dot and the name of the function. Java will automatically come up here and go, okay, the super class for this current class is animal. So it's going to go back to here and look at the eat method and call that. So let's run that and see what happens. So what's happened is the dog.eat method was called. So if you recall previously when we called dog.eat, it went automatically into the animal method and it called this method here in the animal class because, of course, we didn't have an eat method in our dog class. But now we've added an eat method to the dog class. Dog.eat method has been called first. We then use chew, which called the private method chew in the dog class. But then we use super.eat, which called the animal.eat class. So that's using inheritance. So this video is getting quite long. So let's continue this in the next video. In the previous video, we got introduced to what inheritance is in Java, so let's continue on with that discussion now. That's how we would override a method in a superclass. But let's go back and look at this animal class again. We notice that we've got this other public method called move, which is a very generic term because all animals can move in some way, shape or form. So let's go back to the dog class and think, how would a dog move? The first one would be walk. So public void walk. But we would also have run as well. So what we might actually have, if we go back to our animal class, what might be smart is to accept a parameter, and the parameter might be the speed perhaps that this animal is moving. So we could accept a parameter called int speed, which relates to how fast it is, and we can put animal is moving at speed. So we've now got a parameter. So we go back to the dog class, where we might say for the dog class move. And notice when I type move, it's automatically found the method called move, which is in the animal class. So I can either just call that method directly like this, or I can put super.move. But generally speaking, it's better to use move, because that then means if you override the move function that allows time for a dog, it's going to correctly call that move method. So let me show you what I mean. So first I'm going to call it like this. So let's just say a walk. And again, the number doesn't necessarily mean anything. Let's just assume that it's just a unit of speed. So I'm going to say it's a 5 when they're walking, like so. Then down for running, we'll say running is maybe at 2 times the speed. We'll make it 10. So if I go back and run this, and we put dog.walk, run that. Dog.walk has been called, animal is moving at 5. And likewise, if we did a dog.run, dog.run called, animal is moving at 10. And just to be clear, what we could probably have done is we could put animal.move called, just to be clear which method is being called. And you can't quite see that, but basically animal is moving at 5 and 10. You can see animal.move, and animal.move has been called. So the reason, getting back to the dog class, if I leave this at move instead of putting super.move, the reason I want to do that would be at some point in the future I might decide I need to create something, some characteristics, something unique for this dog class for moving. So for example, if we go to override, we want to override the move method this time. You notice I've got the option to override that. So I'm going to select that one. What we might decide to do there is, personally we'll indicate, we'll say dog.move called. We might decide to do something like move legs, because obviously a dog moves its legs to move. And maybe that would be the speed as well. So we would create a method called move legs. Something like that. So now if we run the move, so what you can see what I've done there, I've created now the method move in the dog class itself. So what should happen is this will now be executed first, the move method, because we've actually created that now in this class. And in the case of walk, I've got super.move, and in the case of run, I've got move. So let's go back and look at our code. So if I change this first, so it's just dog.run. Dog.run called, then dog.move was called, dog.move legs was called, and animal.move was called. So you can see, getting back to our code, so back in the run method, you can see we've just called the method move. So what happened was move, because we didn't have the super keyword, it knew that, okay, I'm going to take this, whichever move I can find. If there's a move method in here, I'm going to execute that. Otherwise, I'm going to execute the super one automatically. Or in other words, the move method that's in the animal class. And that's what happened in this case. And just to confirm that, we could also comment that code out. Oops, not that last line. And go back and run that again. Oops, I should have commented that out as well. Try again. You can see what's happened here. Dog.run was called, but now animal.move was called. So because it couldn't find the method move, because it wasn't there, it didn't exist in this dog class, it automatically went and searched and found one in the animal class and executed that. And again, if I just uncomment that and run that again, we have to see that in operation. Now it's calling dog.move, dog.move legs were called, and animal.move. So you can starting to get the idea now how methods can be called depending how you set this up, either in the class you're working in or in the super class. It really does depend how that's been set up. So we go back to our dog class again. You remember that in this case, super.move is called. So even though we've got a move method set up, we're actually telling it not to look in the current class. We're saying super.move, which says only execute the move method in the super class. So if I go now and actually run that and use the .walk, so I'll comment that out and uncomment that. So now we've just got the dog.walk, and I'll stop the dog eating just to save a bit of output. So if we run that now, so you can see dog.walk was called, animal.move was called. So even though we've defined a method here called move in the dog class, what's happened is we use the super keyword, super.move, move. So in that case, what we're saying to Java is don't try and execute the move method if there is one in this class. Automatically go to the superclass, in other words, the class we're extending from, inheriting from, which in this case is animal. So you can see here now that what we've done with the dog class is we've created a class that is still based on the animal class, in that it's got these base characteristics of a name, the brain, the body, the size, and the weight. But in addition, we've defined some extra fields, eyes, legs, tail, teeth, coat, that are applicable only to a dog. And we've also defined some behavior like chew, walk and run, which is specific to dogs, move legs, which was specific to dogs. But we've also overridden some functionality. In other words, what we've done here is we've created a method of the same name as a method from the animal class, but we've overridden that with our own unique implementation, which has, in this case, added a call to the chew method, so that for the dog chewing mechanism, but then it's also calling the super functionality, in other words, the eat method from the super class as well. So that's certainly optional. You don't have to call the code in the super class, but often you want to do that to initialize that or to perform that basic functionality in that basic class. And that's how you do it. You can separate the functionality that's unique to a dog in the dog class, but anything that's generic and specific to an animal, in this case, we've shifted that off to the animal class. So let's now just do one more example of a class that inherits from animal. Let's create a class called fish. So fish is an animal. So we're going to extend from animal. We call it fish. So what are some unique characteristics of a fish? Well, let's go with a couple. Int, private int gills. Fish have got gills. They've got eyes, so we need to define those. Private int fins. Fin or fins. So what we'll do now is we'll type extends animal. And we're getting that error again now because it wants that constructor to be fixed up. No default constructor, so we need to create our constructor. I'm going to specify those three. Now, once you see what happened when I did that, automatically it's initialized our three parameters, but it's also initialized the other three parameters, the other 5 parameters from our superclass as well. And if you recall, we decided previously that we weren't going to define brain and body. We're going to do the same. One, maybe one. So we'll define that again, and we'll take those out of the constructor. I'll delete that so we've got a bit more space. So very similar to the dog class, but in this case, we've created a new fish class that inherits from the animal class, and we've defined some unique characteristics for the fish, namely gills, eyes, and fins. And we could do something similar with methods. We could create some, for example, there's a rest method, because fish rest, they don't necessarily sleep. So let's try rest. Create another one, swim. Rather, their movement is swimming instead of walking or running. And so for swimming, we might have something like private void move muscles, because that's how a fish moves, a combination of moving its muscles, and it also needs to use its back fin, so void move back fin. So therefore our swim method, to swim is a concept of moving the muscles, so we're going to call move muscles, and then we're going to move back fin. And we want to put the speed, how fast are they swimming. So after we're doing that, the net result is the movement, and we're going to call super, to make it clear, super.move speed. So that would be one way to model the swimming event. So a fish is, the concept of moving for a fish is to swim, so it moves its muscles and it moves the back fin, which the net result of that is it actually propels itself. In other words, it's got some velocity, and we're calling the super method from the animal class to move, to be able to move that and to move this fish to propel it in a certain direction. And rest is a similar thing. I guess we could have defined sleep in the animal class. The reason I didn't do that is fish generally don't sleep, they actually rest. So it's actually not probably appropriate to put a sleep method or a state in the animal class, because not all animals, as we've defined, necessarily sleep, at least in that same fashion. that we're used to when we use the term sleep. A dog, it would be appropriate to put a sleep in here because, of course, dogs do sleep. So you can see that you could take this, you can actually extend this out. We can even have specific types of dogs that extended on from the dog class. We could have like a Yorkie dog, for argument's sake, or an Alsatian or a Labrador that has the unique characteristics of a dog. So you can keep extending on and on and on if you want to. As you'll see when we start getting to the stage of this course, start creating some real apps. You'll see that you do still want to take care to make sure you're still using this the same way and you're not making things overly complicated unnecessarily. But that comes with experience, and we'll certainly be talking about that more in future videos. The main thing is to get a good handle on the concept of inheritance and how we're taking the base characteristics defined, in this case in the animal class, then we're extending from or inheriting from that class to create a new class that inherits those states. In other words, the fields and also the behaviors, which is the methods, which we can use in our new class. And then we can, of course, then add new methods and new fields to that new class as well. So very, very powerful, and you'll see that in operation in future videos, in future apps that we're going to create in this course. So I'm going to end this video here now. In the next video, it's challenge time. I'm going to challenge you now to create some classes similar to what we've done today. Create a base class and extend from that. In other words, inherit from that class, but to do something completely different to our example that we've been using, which of course is animals. So I'll see you in that next video. In this video, I wanted to go over and talk about references versus objects versus instances versus classes. Now, by now you've probably noticed that these words have been used in this section: reference, object, instance, and class. Now, these new concepts may well be confusing at first. So this video, I'm going to try and go through the process and show you exactly what each of these words actually mean in the context of Java programming. All right, so let's start by using the analogy of building a house to understand classes. Now, a class is basically a blueprint for a house. So thinking back to the physical world, so you use the blueprint or the plans for a house. Using that, we can build as many houses as we like based on those plans. Now, each house you build, in other words, back in programming terms, each house you instantiate using the new operator is an object, which can also be known as an instance, or is known as an instance. Getting back to the physical world, each house you build has an address. It's built at a physical location. In other words, if you want to tell someone where you live, you give them your address, perhaps written on a piece of paper. So that piece of paper with the address on it is known as a reference. Now, you can copy that reference as many times as you like, but there is still just one house that you're referring to. In other words, we're copying the paper that has the address on it, not the house itself, or we're writing that address on another piece of paper. Now, back to programming terms, we can pass references as parameters to constructors and methods. But let's now just go a little bit deeper to make this a little bit more clearer. All right, so we've got some code on the screen now. Now, on the left-hand side, we've got the class house with an instance variable, also known as a field, called color. Now, on the right-hand side, we have the main class with the main method. Now, this code in the main method is creating instances of the house class, changing the color, and printing out the result. So let's actually go through line by line and see what happens when this code is executed. All right, so looking at this first line that I've got highlighted in red and to the right-hand side, the house blueprint equals new house, blue in parentheses and double quotes. Well, that creates a new instance of the house class. So remember, house is a blueprint, and we're assigning it to the blue house variable. So in other words, it's a reference to the object in memory. And you can see that hopefully on the left-hand side that it makes a bit more sense there. Blue house is the variable. We're creating a new instance of the house class and assigning it the color blue. All right, so this next line that I've got highlighted, house, another house equals blue house. Well, that creates another reference to the same object in memory. So what we've got now is two references pointing to the same object in memory. So there's still one house, but two references to that one object. So in other words, we've got two pieces of paper with the physical address of where the house is built written down, if we're going back to a real world example to make that clearer. So next on the right hand side, I've got two println statements highlighted. So they print the value of the color variable for blue house and another house. Now in this scenario, both will actually print blue, and that's because again we've got two references to the same object. And again, you can see on the left hand side there, hopefully that image makes that clear as to how this is actually working. Alright, so this next line, another house dot set color, parentheses and double quotes yellow, well that's calling the method set color and setting the color to yellow. Now to the left you can see that both blue house and another house now have the same color. Now why is that? Well, remember that we've got two references that point to the same object in memory. Now once we change the color of one, both references still point to the same object. So consequently they've both got the same value of yellow in this example. Now in our real world example, there's still just one physical house at that one address, even though we've written the same address on two pieces of paper. So we could go ahead and we could paint the house yellow, and obviously both references to the physical house still point to a house that is yellow. Alright, so we've got a couple more println statements here. So these two println statements are printing the same color. Both are printing yellow because again we've got two references that point to the same object in memory. And again you can see that defined with the arrows on the left hand side of the image, one instance pointed to by two objects. Okay, so moving on. What we're doing now is with that next line, house greenhouse equals new house, parentheses, double quotes, green. Well, we're creating another new instance of the house class, this time with the color set to green. So now we've got two objects in memory, but we've got three references. And those references are blue house, another house, and greenhouse. Now the variable or reference, greenhouse, points now to a different object in memory, but blue house and another house point to the same object in memory at this point. Alright, so this statement, another house equals greenhouse. So what we're doing here is we're assigning greenhouse to another house. So in other words, we are dereferencing another house, and it will now point to a different object in memory. Now previously it was pointing to a house that had the yellow color, but now it's pointing to a house that's got the green color. So in this scenario, we still have three references and two objects in memory, but blue house points to one object, while another house and greenhouse now point to the same object in memory. Alright, and finally, we've got those last three println statements. The first will print yellow, since the blue house variable or reference points to the object in memory that has the yellow color, while the next two lines will print green, and that's because another house and greenhouse point to the same object in memory. So keep in mind that in Java, you always have references to an object in memory. So there's no way to access an object directly. Everything is done using that reference. Alright, so hopefully that's now made it a little bit clearer. Let's move on to the next video. So let's now discuss the difference between the this and the super keywords. And we'll also find out about the differences between the this and super method calls, as you can see by adding parentheses on the end. Alright, so let's start with the super and the this keywords first. Now the keyword super is used to access or call the parent class members, variables and methods. Now the keyword this, on the other hand, is used to call the current class members, variables and methods. So this is required when we have a parameter with the same name as an instance variable or field. Now note that we can use both of them anywhere in a class except in static areas, which is the static block or a static method. Any attempt to do so there will lead to compile time errors. But don't worry too much about static, we'll be talking more about that later in the course. So the keyword this is commonly used with constructors and setters and optionally used in getters. It's particularly useful for beginners using it in getters. Now in the example below, we're using the this keyword in the constructor and setter, and that's because there's a parameter with the same name as the instance or field. Now in the getter, we don't have any parameters, so there's no conflict, so therefore the this keyword is optional there. Now the keyword super is commonly used with method overriding when we call a method with the same name from the parent class. Now in the example below, we have a method called printMethod that calls super.printMethod. Now in other words, it's calling the method with the same name from the parent class. Now without adding the keyword super in this case, it would end up being a recursive call. What that means is that the method would call itself forever, or actually until memory is fully used on your computer. So that's why we need the super keyword, so that we can call a method with the same name from a parent class. Alright, so in Java we've got this call and the super call. So notice the braces, but it's known as a call since it looks like a regular method call. So you'd use this parentheses to call a constructor from another overloaded constructor in the same class. Now the call to this parentheses can only be used in a constructor, and it must be the first statement in a constructor. Now it's used with constructor chaining. In other words, when one constructor calls another constructor, and it helps to reduce duplicated code. Now the only way to call a parent constructor is by calling super parentheses. So that actually calls the parent constructor. So the Java compiler puts a default call to super parentheses if we don't add it, and it's always a call to the no argument super which is inserted by the compiler. In other words, a call to the constructor that hasn't got any arguments. And keep in mind that the call to super parentheses must be the first statement in each constructor. Now even abstract classes have constructors, although you can never instantiate an abstract class using the new keyword. An abstract class, by the way, is still a superclass, so its constructors run when someone makes an instance of a concrete class. We will be talking a lot more about abstract classes later in the course as well, but I'm just mentioning it here now to be complete. And importantly, a constructor can have a call to super parentheses or this parentheses, but it can't have both. Right, so let's look at an example, what I would consider a bad constructor example. So here you can see we've got three constructors. Now all three constructors initialize variables, but there's repeated code in each constructor as you can see there. So we're initializing variables in each of the constructors with some default values. Now you should never write constructors like this. Instead, you should look at doing it another way. So let's have a look at how to do that by using the this parentheses call. So this example is very similar to the example on the previous page, but the difference is that the first constructor calls the second constructor calls the third constructor, and then the third constructor actually does the initialization of the instance variables. So in other words, the third constructor is doing all the work here. So now that we've done this, no matter what constructor we call, the variables will always be initialized in the third constructor and only there. So this is known as constructor chaining, and what we're doing is we're giving the last constructor the responsibility to do the actual initialization of the instance variables. Alright, so looking at both examples on screen now. So on the left hand side, again this is the bad example of constructors. On the right hand side we've got a good example. So again, the problem with the left-hand side is the duplicated code. So as you can see, all three constructors on the left-hand side are initializing the variables. Contrast that to the solution on the right-hand side. So there we've got one constructor that initializes variables, and the other constructors are just calling each other so that ultimately we end up in the third constructor. And that's again constructor chaining. So with that constructor chaining, we can and do avoid code duplication. And by the way, duplicated code can lead to many bugs and a lot more work on your behalf, and it's also bad practice as a rule to write duplicate code, which of course we did in the bad example. Alright, let's have a quick look at the super parentheses call example. So in this example, we've got a class shape with XY variables, instance variables, and the class rectangle that extends shape with variables width and height. So in the rectangle class, the first constructor is calling the second constructor. Now the second constructor is calling the parent constructor with parameters x and y. Now the parent constructor will initialize the xy variables, while the second rectangle constructor will initialize the width and height variables. So as you can see in this code, we've got both the super parentheses and this parentheses calls. Now, you may want to watch this video a few times, or you may also want to then continue through to the rest of this section and then come back to this one to see if that actually makes more sense. Because it's very important as a Java developer to understand the differences with these calls to be able to use them properly. Alright, so let's move on now to the next video. This video is about method overriding versus overloading. Specifically, let's talk about the main differences between method overriding and method overloading. So method overloading means providing two or more separate methods in a class with the same name but with different parameters. Now the method return type may or may not be different, and that allows us to reuse the same method name. Overloading is very handy because it reduces duplicated code and we don't have to remember multiple method names. Now overloading doesn't have anything to do with polymorphism, but Java developers often refer to overloading as compile time polymorphism. So in other words, the compiler decided which method is going to be called based on the method name, return type, and argument list. Now we can override static and instant methods, and more about the differences between static and instant methods later in the course. Now usually overloading happens inside a single class, but a method can also be treated as overloaded in the subclass of that class. And that's because a subclass inherits one version of the method from the parent class, and then the subclass can have another overloaded version of that method. So some rules about method overloading. Methods will be considered overloaded if both follow the following rules. The methods must have the same method name, and methods must have different parameters. Now if methods follow the rules above, then they may or may not have different return types, they may or may not have different access modifiers, and they may or may not throw different checked or unchecked exceptions. And more on exceptions and what they are and how to use them later in the course. So that was method overloading. Let's discuss a little bit more now about method overriding. So method overriding, well, that means defining a method in the child class or in a child class that already exists in the parent class with the same signature. In other words, the same name and same arguments. So by extending the parent class, the child class gets all the methods defined in the parent class, and those methods are known as derived methods. Method overriding is also known as runtime, polymorphism, and dynamic method dispatch because the method that is going to be called is decided at runtime by the Java virtual machine. When we override a method, it's recommended to put @override immediately above the method definition. And @override is an annotation, and the compiler will read an annotation, and in this case, the @override tells the compiler to show us an error if we aren't following the overriding rules correctly for that method. Now we can't override static methods, only instance methods can be overridden. So some rules about method overriding. A method will be considered overridden if we follow these rules. Firstly, it must have the same name and same arguments. The return type can be a subclass of the return type in the parent class. It can't have a low access modifier. So for example, if the parent method is protected, then using private in the child is not allowed. However, using public in the child would be allowed in this example. Now there's also some important points about method overriding to keep in mind. Firstly, only inherited methods can be overridden. In other words, methods can be overridden only in child classes. Constructors and other private methods cannot be overridden, and methods that are final also cannot be overridden. Now a subclass can use super.methodName parentheses to call the subclass version of an overridden method. So let's see an example now of method overloading and method overriding. So on the left we've got a simple overriding example. As you can see, we've got two classes, dog and German Shepherd. Now the class German Shepherd extends dog and overrides method bark. So as you can see with overriding, we've got the same name and same parameters for the method, and in this case specifically we don't have any parameters, but they would need to be the same in the case of overriding. Now on the right hand side you can see a simple example with method overloading. So here we've got class dog with two methods that have the same name bark, but in this case they've got different parameters. The second method bark has an int parameter, while the first method for bark doesn't have any parameters. So hopefully now you can easily see the difference between overriding and overloading when comparing these two examples side by side. So let's recap now the most important rules about overloading and overriding methods. So in the following table you can see the main differences between overloading and overriding. Now some parts like exceptions are probably still unknown. Now you may be wondering what exceptions are. You may not know those at this point, but we'll cover exceptions later in the course. But on the left hand side we've got overloading, and on the right hand side we've got method overriding. Now with method overloading we've got functionality to reuse the method name with different parameters. Overloading usually happens in a single class, however it can be used in a child class because the child class inherits methods from the parent class. Now with overloading methods, they must have different parameters, but they might have different return types, access modifiers, and or different exceptions. Now with overriding, we're reusing behavior which the class has inherited from the parent class. So overriding can be in the child class or grandchild class. It's always in two classes that have a is-a relationship. So methods that are overridden must have the same parameters and they must have the same return type or covariant return type. Now, covariant return type is just a return type that is in the parent-child relationship. So in other words, that has a is-a relationship. Overridden methods can't have a lower access modifier. So in other words, if the parent method is protected, then the child method can't be private, but it could have a higher modifier. In other words, in this scenario, the parent method being protected, the child method could be public. Now, covariant type, you might be a bit confused by that term. So let's see a quick example of a covariant return type with method overriding. So on the left-hand side, we've got two classes, burger and healthy burger. The fields and methods have just been admitted for simplicity so they don't create any additional confusion. Now on the right-hand side, we can see the class is burger factory, and it's got one method, create burger. Now that method just returns a new burger instance. There's also a healthy burger factory class that extends the burger factory and overrides the create burger method. So notice here how the return types are different, and that's known as a covariant return type. So in other words, the burger class is the parent class and healthy burger is a child class. So the method create burger in the class healthy burger factory can return any child type of burger. In this case, we've just got one child class, healthy burger. Right, so hopefully we've now that now makes sense about covariant return types, and that's given you a good recap of method overloading versus method overriding. I'll see you in the next video. Let's discuss the differences between static methods and instance methods. So firstly, static methods. So static methods are declared using a static modifier. Now static methods can't access instant methods and instant variables directly. They're usually used for operations that don't require any data from an instance of the class, from this in other words. And if you remember that this keyword is the current instance of a class. So inside a static method, we can't or don't have access to the this keyword. We can't use that. Whenever you see a method that doesn't use instant variables, that method should probably be declared as a static method. For example, main is a static method and it's called by the Java virtual machine when it starts the Java application. In this example on screen, we've got a class called calculator with a static method called printSum. And it just prints the sum of two integer numbers. Then we've got the main class with two static methods, main and printHello. Now inside main, we're calling the method printSum from the calculator class. So as you can see, to call the printSum method, we just need to type the class name, in this case calculator, and then the method name, in this case printSum. Or in the second example, in the case of printHello, we can just type the method name with parentheses, which will automatically call the printHello static method because it's being invoked from a static method itself. So static methods don't require an instance to be created. We just type the class name dot method name to access them. So let's move on now to instance methods. Instance methods belong to an instance, a specific instance of a class. Now to use an instance method, we have to instantiate the class first, usually by using the new keyword. Instant methods can access instance methods and instance variables directly. Instance methods can also access static methods and static variables directly. So in this example, we've got a class called dog with a method bark. So notice here how the method bark is not using the static keyword this time. So in other words, that method is just a standard instance method. Then we've got our main class with a method main. Now inside main, the main method, we first need to create an instance of the dog class, and that's done with the line dog rex equals new dog. As you can see, we're using the new keyword to create an instance of that class. And after we've got the instance, we can call the instance method bark in this case by typing rex.bark. So the hard part here could be deciding when to create an instance and when to create a static method. So let's see some basic rules that should help you decide. So here we've got a small diagram that should help you with deciding whether you need an instance or a static method. Now instance methods are created more often than static methods, but let's see how you'd follow this diagram. So the question that you would ask yourself would be, should a method be static? So for that question, the next question would be, does it use any fields, instance variables in other words, or instance methods of this object? This is the proposed method you're looking to write. So if that's true, in other words, it does use some fields and or instance methods, then you'd make it an instance method. In the other scenario, if the method doesn't use or is not proposed to use any instance variables or instance methods, in that case, then you should probably consider writing it as a static method. So generally speaking, if you're not using any fields or instance methods with the new proposed method, consider making that method static instead of a regular instance method. So that's the main differences between static and instance methods. Let's now move on to the next video. We're going to talk a bit more about static, this time static and instance variables. See you in the next video. Let's discuss the differences now between static variables and instance variables. So firstly, static variables, by using the keyword static. Now static variables are also known as static member variables. Every instance of the class shares the same static variable. So if a change is made to that variable, all other instances of that class will see the effect of that change. Static variables aren't used very often, but can sometimes be very useful. For example, when reading user input, using the scanner class, we can declare scanner as a static variable. And that way all static methods can access that scanner directly. Now in the following example, we've got a class called dog, and it's got a static variable called name. Now there's a constructor that sets the static variable to the parameter value passed to the constructor, and we've got a method there called printName, which isn't static. So that's a pretty simple class. And inside main, we're creating two instances of the dog class. With the line dog rex equals new dog, in parentheses double quotes rex, we're creating an instance of the dog class, and then we're passing the string rex as a parameter, and that will be the name of the dog. In the next line, we've got a similar situation, just passing the parameter which will be used as the name as Fluffy. So then we're calling the printName method on both instances. So they're just regular instance methods, because they aren't defined using static. So both method calls will print Fluffy. So you might be wondering, why is that the case? Why would both methods here print Fluffy? Well, remember that static variables are shared between instances. So in other words, once we change a static variable, all instances will see that change we made. So when we call the constructor with parameter Fluffy, it modified the static variable name, and because both instances are sharing that variable, that's why it prints Fluffy twice. So you could also say that all dogs have the same name, but that's logically incorrect. In real life, of course, every dog has a different name, it's got a breed and so on. So hopefully now you can see how static variables can be used inappropriately sometimes, as in this example when perhaps you were assuming that the dog's name would change with each instance of the class. So that would be a scenario where using a static variable probably wouldn't be a good idea. Not using a regular instance variable would make a lot more sense in this particular example. Alright, so let's move on now to instance variables. So firstly, they don't use the static keyword when you're defining them. Now, they're also known as fields or member variables. Unlike a static variable, instance variables belong to a specific instance of a class. Each instance has its own copy of an instance variable. So every instance can have a different value or state, and instance variables represent the state of a specific instance of a class. So let's see an example using instance variables. So in this example, we've got a very similar code to what we looked at earlier in the video, but this time the variable name in the dog class isn't static, so it's just a regular instance variable. So once again, the constructor is setting the value from the parameter passed to that constructor. So now the code will print Rex and on the next line Fluffy, and that's because we're using instance variables, and each instance of the class has its own state or own values for any variables that have been defined. So in other words, now every dog's got its own copy of the name variable. We can also say that it's basically not shared like it was before in the earlier example using a static variable. So in most cases, you'd probably want to use instance variables, but there will be scenarios when it can be useful to use a static variable. And in the earlier example, and previously we talked about using a scanner as a static variable so that it could be shared across any static methods when you're reading user input. So that's instance and static variables. Let's move on now to the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
In the previous video, we finished off our discussions about inheritance. So now it's time for the challenge to solidify your understanding of what inheritance is. But before I do that, I just want to talk about that all classes in Java inherit from automatically. I briefly alluded to that in the previous videos. But what actually happens though, even if you're not typing the keyword to extend a class, which we've shown in the previous video, the use of the extends keyword, the class is automatically inheriting from a Java supplied class called the object class. And you can see that by opening up your generate command. If you go to override methods, you can see when I've done that, select methods to override or to implement. You can see here, these are all methods. The M stands for method, and these are all methods that are inherited from java.lang.object, which is a class that classes that you create are automatically extend. So it's equivalent essentially to typing extends object. Java.lang.objects, you can see there, and we can go and have a look at that, and you can see class object is the root of the class hierarchy. Every class has object as a superclass. All objects, including arrays, implement the methods of this class. That's really important to know that this happens automatically. And this is the actual source code for the object class, which is inherited automatically from when you create other classes. So you can see that we'll go through some of these methods. We get a hash code, an equal, so it's a comparison determining one type of object against another. There's also a toString, which we'll be using to later, which is a string. It's just a way to return a string representation of a specific object. So I won't go into any more now, but the main point I want to really pass on at the moment is, even though your classes, when you're creating new ones, you aren't actually typing an extends object, they are automatically extended by Java. And that's it's an interesting thing to realize, and that's just the way that Java do implement. Okay, so I'll just undo those changes. Okay, so let's talk a bit now about the challenge for inheritance. Okay, so here is your challenge. You want to start with a base class, which is a vehicle. Then you want to create a car class that inherits from that base vehicle class. Then finally, you want to create a third class, which is for a specific type of car that actually inherits from the car class. Now, you'll be wanting to, in these classes, you should be able to handle steering, changing gears, and moving, speed in other words. And you need to decide where to put the appropriate state and behaviors. Of course, that is the fields and methods that are appropriate for each class. And you'll want to create some unique behavior that is specific to that final class that inherits from the car class as well. So have a go at doing that challenge. This will really help your understanding of what inheritance is. And pause the video now, go away and do that. And once you've had enough, or once you've got a solution and you want to compare the solution to what I've come up with, come back and we'll go through that. Okay, how did you get on? Did you figure it out? And bearing in mind there isn't only one answer to this, there's quite a few different ways to implement this. But the answer I'm going to come up with is to start with the vehicle class. So I'm going to create a new class and call it vehicle. And with that vehicle class, I'm going to have two fields. I'm going to have private and string name, the name of the vehicle, because of course all vehicles have got a name. And I'm also going to go with the size. You could have some other generic characteristics here, so long as it's specific to a generic vehicle, and that would be fine, there'd be no problems there. We also want to have a constructor for both those fields, so we can initialize our object. The other thing that we're going to have here is also two other fields which deal with the current velocity, the current speed in other words, and also the current direction. And we want the velocity so that we can determine the speed, figure out how fast the vehicle is going, and also the direction where it's pointed to at the moment. So I'm going to do private int current velocity and private int current direction. Now, unlike the first two fields that I've defined, what we're going to do here is when we're creating a new instance of the vehicle class, in other words creating a new object, we're just going to initialize velocity and current direction to 0. So this dot current velocity is equal to 0. This dot current direction, current direction equals 0. So next we talked about, going back to our description, we're able to handle steering, changing gears and moving. Well, of course, in our vehicle class, we haven't got a concept of gears. And the reason for that is not all vehicles have gears. So it wouldn't be appropriate to put gears in here. But the other thing was moving. And moving is, of course, something that all vehicles do. They do move and they can be pointed in a certain direction. So we need to handle that in this class. So I'm going to first create a public method called steer. It's going to take a parameter for the direction. And what I'm going to do is actually add to whatever's been sent to that method to the current direction. So in other words, it's a mechanism for steering. So I'm going to call that public void steer int direction. And I'm going to put current, this dot current direction plus equals direction. And then I'm going to do some system output to put vehicle dot steer. And I'm going to put steering at, put the current direction. And we'll call it degrees, but it might just be an angle or whatever it is, but we're just going to call it degrees. So that's our steering method, which again applies to all vehicles. We're also going to create another method. I'm going to call that move, and I'm going to accept two parameters, the velocity and the direction. So I'm going to put public void move int velocity and int direction. I'm going to put current velocity equals velocity, current direction equals direction. Put an output message, vehicle.move, moving at plus current velocity in direction, current direction. And unlike the steer method, what we're doing here is we're actually setting the velocity and direction to the specific number. With the steer, the way we've set that up is we're allowing you to change relative to the current position. So we're storing the current position of the current direction, enabling you to move relative to that. Whereas the move method, we're actually allowing you just to effectively change the velocity and the direction. No right or wrong here, it's just my implementation for that. And we also want to do a getter and setter for a few of these fields. So I'm going to just, probably for speed wise, I'm just going to select that and choose a getter for all the fields. So that's our vehicle class. So next we want to create the car class. And we want to obviously extend or inherit from that vehicle class. So I'm going to create a new class, call it car. And of course we're going to extend or inherit from vehicle. And obviously it'll want us to create a constructor. But before we do that, we want to create the unique fields for a car. Firstly, we're going to define the number of wheels, because not all vehicles have wheels. For example, some boats are vehicles and they don't have wheels. And we're going to define doors, which are unique to a car, the number of doors. Into gears, as to the number of gears that are present in a car, because all cars do have gears. It's a different number, of course. We're also going to use a variable is manual, and that's a true or false as to whether it's got a manual or an automatic gearbox. And we're going to store another variable called current gear. And if you recall, we talked about that in the vehicle class. Because not all vehicles have gears, we've decided to create a field called current gear and put that in the car class. That's going to be our current gear. So that's the current gear that the car is in at this point, at any point in time. So let's create the constructor, and the constructor is going to initialize all of these. But you notice it also put some extra code in for us, which was the two parameters, the string for the name and the string for the size, which are going to initialize our vehicle class as well. And that's IntelliJ doing that work for us, which is very nice. Now what I'm going to do though is change the last parameter for the gear, the current gear. We don't actually want that as a constructor parameter. And the reason is we're going to assume that when we create a new object, we're going to set that to 1 to be in first gear. So now we need a few other methods here. What we need is the ability to change the gear. We need the ability to change velocity of the vehicle. We're going to add a method to stop, and we also need to be able to steer as well. So let's start by creating a setter. We're going to create a setter for the current gear. So I'm going to select current gear, and I'm going to put car.set current gear. Changed to this current gear plus gear. So that's just a standard setter to change to the current gear whenever we need to do that. And what we could do, because that's a setter, probably, now normally the convention is to use the word set, but in this case it might be better to actually rename that and to call that change gear. We don't have to use set current gear. In this case we're going to just call it change gear, which probably reads a little bit better and makes more sense as to what we're trying to do there, because this is going to be a function that we're going to be able to call. So next we want the ability to change the velocity of the vehicle. So we could just leave it, so we could just have no function here and just call the basic function that we've set for move here, in which case that would work and work fine without any problem. And when you're extending and implementing classes, you have got a choice as to whether you want to use that low-level function or override it. In this case, what I'm going to do, I'm going to create another method, call it change velocity, which takes two parameters, which is the velocity, or we're going to call it speed here, and the direction. And that's going to call the move method, move, speed, direction. Like so. So that's change velocity. And the reason I'm doing that is at some future point we might want to have some other mechanisms in here with the velocity. For example, to test the maximum speed of the vehicle or some other conditions that are unique to a car as opposed to a vehicle. But at this stage we're just going to be calling the vehicle move method. The next method I'm going to have is the stop method. This is the ability to stop. So you could argue that all vehicles need to have a mechanism to stop. And to that end, we should probably create a public method for stop. So public void stop, and I'm creating that in the vehicle class. So stop. And all it's going to do is put the current velocity, set that to 0. And that's all the stop does. It basically stops it. It doesn't try and reposition the direction or anything of that nature. It just purely stops the vehicle. But in terms of stopping for a car, what we want to do is we want to implement the method, but we want to override it. So I'm going to override the stop method for the vehicle. I'm going to select stop, So what I'm going to do, I'm not going to call the super method yet. So actually what I'll do for now is I'll delete this method because we don't really need to override it for now. For this basic car class, it's enough for us to know that we've got a stop which will set the velocity to 0. When we get to using the next class, which will be the class that inherits from car class, that's when we'll add some more functionality to the stop. And with steering, the same applies. We don't need to change anything in the car class because we're going to just pass that on to the vehicle class. Okay, so you can see now we've implemented the car class. So let's now move on to the next class, which is going to be a specific type of car that extends from the car class. So I'm going to create a new class. I'm going to call it Outlander, which is a Mitsubishi four-wheel drive. So I'm going to create that, and I'm going to do extends car. Now what I'm going to do is assume, so obviously we're extending from car, so it's got all now the unique characteristics from the car and the vehicle. I'm going to add one private field, which I'm going to put road service. The number of months of road service that are available for this type of vehicle. Next, I'm going to create a public constructor. I'm going to initialize the road service, and you'll find it automatically initializes all these other fields for us as well. But what we can do with some of these parameters is we can change them. For example, for the Outlander, we don't need to have that as a parameter because we're going to presume, because this is an Outlander class, we know that it's the Outlander. So we're going to use that in our constructor. We're going to just pass Outlander. And for the size, we're going to go with four-wheel drive. So we also don't need that as a parameter. So I'm going to actually change those from the Outlander parameters. And we're left only with the wheels, the doors, the gears, whether it's manual, and the road service. And actually, as it turns out, all of those parameters there, the wheels, the doors, the gears, and the manual, because we're defining now the actual type of car, we shouldn't really have those as parameters. What we want to do is just hard code those, for want of a better term, in the constructor setting. Now, of course, you could still make it optional if there were multiple types of Outlanders, which there are in real terms, but to keep things simple, we're going to presume there's only one type of Outlander, and we know ahead of time the number of wheels and doors and gears and so forth. So what I'm going to do there is put the number of wheels to be 5, including the spare, 5 doors, including the rear door, the 6 speed, and we're going to put is manual, we're going to set that to false because it's actually an automatic. So consequently, now that I've done that, I can actually delete those from the constructor, as you can see there. So we're left now to create a new Outlander, which of course is extending from the car class. We really only need to pass one parameter, which is the road service, the number of months that this vehicle has got for road service. The new cars, with Mitsubishi cars, they give you so many months of free roadside service if you ever break down. So what we're defining is how many months this vehicle has got. All right, I'm going to pause the video here. We'll come back in the next one and continue on with the solution to the challenge, with the solution to the inheritance challenge. In the last video, we started on the inheritance challenge. In this video, we're going to go ahead and we're going to complete my version of the challenge solution. So moving on now from the Outlander class that we've created. Now what we're going to do is we're going to change a few things here. Because we've passed false as the type of gearbox, what that means is we've decided on an automatic transmission. And we're going to create a new method, which we call accelerate, which we pass a parameter of the speed, and based on that, depending on the speed that the car is traveling at, we're automatically going to change the gear because, of course, it is an automatic gearbox. And then we're obviously going to set the velocity and the direction as well. So to do that, we're going to create a new method, call it public void accelerate. I'm going to pass something called the rate. Now, the rate is the difference in speed from the current speed. So what we're going to determine then is we're going to look at the new velocity of the vehicle, or the car in this case, which will be the new velocity equals, we're going to get the current velocity of the vehicle, which is the field essentially that comes right back from the vehicle class. Then we're going to add to that the current rate, bearing in mind that the rate can be a positive number or a negative number. So a positive number would be you've put your foot down on the accelerator, you've increased the speed, and a minus number would mean that you're de-accelerating, for want of a better term. But we're handling all of this in the one method. So the new velocity is going to be the new velocity of the car, taking into account the change that has happened or has been passed to this method. And so if new velocity is equal to 0, we're going to call the stop method. Otherwise, we're going to put else if new velocity is greater than 0 and new velocity is less than or equal to 10, then we're going to change the gear, because bearing in mind this is an automatic transmission. And we'll just do a few more. We won't go through and do all 6 gears, but we'll put if new velocity is greater than 10 and new velocity is, say it's less than or equal to 20, this could be miles or kilometers per hour, change gear 2. So we're getting the car to automatically change based on the velocity. If new velocity is less than or equal to 30, you can see what we're doing here, change gear 3. And for simplicity, even though I said there's a 6-speed, I'm going to put else change gear 4. So normally you would go through and you'd actually do the other parameters for the speeds. So what we're doing here is we've created a new method called accelerate, and depending on what the new speed is going to be, we're automatically changing to the relevant gear, which of course is what a car does automatically. It knows to change gear based on a certain amount of speed or revs. Then the last thing we need to do is we need to just do a final test. If new velocity is greater than 0, we want to change velocity, we want to call the change velocity to what the new velocity is going to be, and we also want to use the get the current direction. So we're still going to go in the same direction. All we're doing is we're increasing or decreasing the speed. So that's now a method, as you can see, that's specific to the Outlander, but then it's changing gears. And of course the changing gear is based now on the method that we've defined in the car. And of course, some of the other features we're using, the stop method at the moment, we haven't implemented the stop method in here. We've only implemented the stop method down here. So what we really should do is with the stop method, so we could create a stop method and put it in here under the car to set the gearbox to the first gear, in other words, if the car is stopped. But that wouldn't be appropriate because we've decided that we've got a Boolean here for is it manual. So if it's manual, that's a manual operation to change the gear. But in the case of the Outlander, we defined that as to be using an automatic gearbox. So therefore we need to add the functionality to change the gear if it's stopped here in the Outlander and not in the car class. So we're going to put change gear 1. So in other words, if the car's stopped, it's going to automatically change the gear for us to first gear. So that's a very basic solution, as you can see that we've come up with now. We've now got 3 classes. We've got the vehicle class, which is the base class, the base vehicle class. We used the car class to extend from that, and we added these parameters that are unique for a vehicle: wheels, doors, gears, and as to whether the gearbox was manual or automatic, and also the current gear. We're keeping track of what the current gear is for the car. And for the Outlander, of course, we're using that. We've extended from the car. The only real difference is we've added one field here, which is the number of road service months that come with the new car. And we've also added our own accelerate method, which is unique to the Outlander because it's an automatic car, or because it has an automatic gearbox. Depending on the gear and the speed that we're going to be going, we change the gearbox automatically. So let's try running this now and see what it looks like. So I'm going to create Outlander. Outlander equals new Outlander. And of course the parameters were just the number of roadside service months. So we'll say 36 for 3 years. And now what we can do is we can type Outlander dot accelerate. So let's accelerate, say, to 30 and see what happens. So let's run that. Let's make a bit of space here so we can see what we're doing. I'll just run it again. So you can see what's happened is we've defined a new object for the Outlander class, from the Outlander class, and we've decided to accelerate to 30. So the first thing that happened was we set the current gear. The gear changed to 3. Vehicle.move was called to be moving at 30 in the direction, and direction is 0 because we haven't defined a direction. Car change velocity was also executed. This is where the outputs can be a little bit confusing, because if we have a look at the code that was executed, we can look at our Outlander. it actually met this condition here because the speed that we've selected is greater than 20 and less than or equal to 30. We change gear to 3, but then we change velocity. And of course, change velocity is in our car class. We use the method called change velocity. I guess what we probably should have done there to make it a little bit better to read is we should have outputted that line first, like so, and then it'll actually appear in the right order. So we'll do that. So now it's actually set in the right order. So it shows the first thing that happened was the gear change was changed to third gear. The car changed velocity to 30, and then it called the actual move method itself was called from the base class, base vehicle, based on this change velocity method, which called the base method from the vehicle. And we could change this a little bit. We could go back to our main class and we could maybe Outlander.accelerate just to see that it's working. We add another 20. So that should accumulate to be a total of 50 that we're going at. So if we run that, you can see now that what happened the second time after the second call changed to fourth gear, because that was our, if you recall, that was our else. We're only handling 4 gears in this scenario. The velocity was actually changed to 50 because we added 20 with the second call, added another 20. It's maintaining the current velocity so it knows that the current speed now is 50. So what we could probably have done also is just to make things a little bit clearer, is we perhaps could have started here and we could have put Outlander.steer and we could say we're going to go at 45 degrees. And remember, the steer method is coming all the way, not from here, but coming all the way from vehicle, because we haven't overridden this method in the car class or the Outlander class. So if we run that now, vehicle.steer, you notice now that the vehicle.steer is now steering at 45 degrees. Car changed to third gear and everything else is as it was before. The only thing different now is the direction. And the other thing, as I mentioned with the accelerate, I can also pass a negative number. So we're currently doing 50, Outlander.accelerate. Let's put minus 42 and see what happens. That should take us to 8, which should probably be first gear. Let's try that. So again, you can see what's happened was we changed down to first gear because the speed is now 8 and we're still moving in the same direction. So you can see how useful inheritance is, and it really gives you lots of flexibility to model real life objects in software. And as you can see, it's also very powerful and actually saves you a lot of coding. You're not having to create the code. So you can create the code for vehicle, in this case, and car once, and then for other types of cars, for example, a Porsche, it's very simple to create a new class and extend the car class. You've got all this base functionality built in. Now what you could have done, because what we've done with this accelerate here, we've effectively implemented a method to change gears automatically based on the speed. So we could even have created another class or added that elsewhere so that that functionality was available for all cars that were automatic. So there's lots of flexibility, as you can see there. So I hope that's helped a lot. That's inheritance, and you'll understand more of this the more you use it, and it'll become a lot more familiar. So in the next video, we're going to start work on composition. Composition is something that can be used in place or with inheritance, and you'll see that there's many benefits to be using composition, but we'll start that in the next video.
Welcome to Section 8 of the course. Tim Pachaka here again, and as promised, this is part 2 of the object-oriented programming sections of the course. We've now done the basics of object-oriented programming in the previous section, but it's now time to look at the remaining 3 major components of object-oriented programming, which is composition, polymorphism, and also encapsulation. So by the end of this section, you should have a solid overview of what they are and also how to use those in your programs. So let's make a start on that right now.
So in the previous set of videos, we had a discussion about and learned about inheritance. It's time now to talk about composition. Composition is another component of object-oriented programming and is very useful in day-to-day programming. But just as a refresher, I'm going to start off and just go over inheritance very briefly before we move into composition. Best way to do that would be an example. So let's create 2 quick classes. First one's going to be vehicle. The vehicle is going to be very simple. It's going to have one field, private string name, and it's going to have a constructor. Very simple concept of the vehicle. let's also create another class, call it car. We're going to extend from vehicle and add a couple of fields, so number of doors, private int, engine capacity. Set up a constructor, and there we go. Very simple little example. So the car extends from vehicle. Now it's got a relationship with vehicle. Is a meaning that a car is a vehicle. So that's the relationship between the two. So you can quite correctly say car is a vehicle. And that's essentially what inheritance is. But composition deals with something different, and that deals with a has a relationship. And the best way to do this is to go through an example. So let's look at the scenario of a computer. So a computer has a motherboard, a case, and a monitor. 3 example things that it's got with it. So the motherboard, the case, and the monitor are not computers in the same sense that a car is a vehicle, but a computer has a motherboard, a computer has a case, and a computer has a monitor. So that's what composition is. It's actually modeling parts, if you will, parts of the greater whole. So in this case, we're going to model the computer, and we're going to model the has a relationship. So the motherboard, the case, and the monitor. So let's start off by actually creating those 3 classes, the motherboard, the case, and the monitor. So I'm going to start with the motherboard, new Java class, motherboard. We're going to create some fields, string model, private string manufacturer. That's the manufacturer of the motherboard. Private int, the number of RAM slots that the motherboard's got. And the number of card slots for video cards and so on. And lastly, just the name of the BIOS. Just some typical things that you would find in a motherboard. So we're going to create our public constructor, which will just be all the fields. We're going to create getters for all our fields because we don't need setters. But what we're going to do is add one public method, which we're going to call load program. We're going to pass a parameter, which will be the program name. And we're just going to print out that the program name is now loading. So that's our motherboard class. Pretty straightforward, as you can see, nothing particularly complicated there. So let's now move on to our monitor class. We create another new class. Monitor is the name. It's also got some fields. We're going to start with the private string for the model. Private string manufacturer. Private int size. That'll be the size of the screen. And let's go with another one, which is going to be the native resolution. We're going to call that resolution. Native resolution. And resolution is going to be a class. And I'm going to create a constructor. Like so. And we're going to fix up that resolution class in a minute. We're going to create that class. And what we're going to do here is we're going to create a public method. Draw pixel at. And it's going to have an X, Y location. And let's just say a color. And we'll just do a simple message that says drawing pixel at X, the XY position in color. Very simple method, and then we'll just create some getters as well. Just the getters for this class. So next we need to create the resolution class. And with the resolution class, that's going to be the native resolution. So what is the width and height, the maximum width and height of the monitor? How many pixels wide and how many pixels down, so to speak. So we can go for width and height. Let's just keep it simple there. So that will be the resolution, constructors, and some getters. So that's our resolution. So going back now to the monitor, we find that error's now gone away. So this is an early example. We're going to talk more about this shortly, but this is composition. So the resolution class is part of a monitor. So the monitor isn't a resolution, but it has a resolution. So this is what composition is. So we're saying that the resolution is a component of a monitor. The monitor has a resolution, which is the native resolution. But more on that shortly. So next we need to create our class for case. A new class, case. And we're going to have model, private string, manufacturer, private string, power supply. And let's also have a dimensions. Dimensions. It's a new class we're going to create. Which is going to be the dimensions, width, height, and depth of the actual case itself. This is the case that contains all the components. And so the constructor is going to have to accept those parameters, like so. We're going to create a function called press power button. And we're just going to have a simple print line that says power button pressed. Like so. And we'll just do our getters as we normally do. Okay, so we're making good progress now. So the last thing we now need to implement before we can start seeing how some of this works is, of course, the dimensions class. And that's going to have a width, a height, and a depth. So let's create that. So dimensions. And it'll be width, height, depth. Create a constructor for the three of them, and let's create a getter as well. Oops. Like so. So there's that dimension. So now if I go back to case, the error goes away. So the case has got a model, a manufacturer, and a power supply. A case has got dimensions. The dimensions which are so the width, the height, and the depth. That is what our dimensions is. So, of course, the case has got all these things. It has got a model, has got a manufacturer, has got a power supply, and, of course, it does have dimensions. And that's what we're doing here again with our composition, is we're actually creating something, in this case another object, that is part of the case. So now we get to the fun part where we actually create a class that is comprised of the case, the monitor, and the motherboard. So let's create yet another new class. We're going to call that PC. So it'll be our personal computer. And instead of using extend, we're going to type private case, the case. I have to use the word the case there, by the way, because if I just type case, as you know by now, case is actually a reserved keyword, so we'll actually get an error. So we need to put the case. We could have called it something else, but that'll do. So private case, so a PC has got a case, it has got a monitor. We'll just call these monitors. And of course, motherboard. And we'll create our constructor like we normally do. This time we're creating a constructor that's going to accept three different objects. And let's create our getters as well. So this is composition again. So we've created a new class called PC. It has a case, so that's the case variable, which is the field that we've defined. It has a monitor, a field monitor, and a field called monitor, and of course it has a motherboard, which is in this case is a field called motherboard. And you can see the obvious advantage here, because if you're using the extends option to inherit, you can only in Java inherit from one class at a time. So you can see that we run into difficulties and run into limitations quite quickly if we're using standard Java inheritance like we used in the last few videos, where we can only extend from one class. In this case, what we've said is the PC comprises of these three other classes, namely the case, the monitor, and the motherboard. So the PC has, in this case, is going to have the objects that we create based off this class will have an object case, monitor, and motherboard in each instance that we create. So let's actually run some code now and see how we would use this in reality. So what we want to do first is create a case. So we can put case the case equals new case. So that actually needs the model number. So let's start with 220B. Manufacturer, well, let's use Dell for want of a better name. Power supply, we'll say 240. And lastly, it wants the dimensions. So it actually wants to know what the dimensions are. So we're going to just type dimensions in there. And of course, what we'll need to do is create a new dimensions class. So we could put so the dimensions, let's go with a width of 20, a height of 20, and a depth of 5. That would be our case. Weird size case, but for this example, it'll be fine. So that's our definition for a case now, remembering that when we create the PC, which we're going to be doing shortly, it needs this reference, it needs to know what the case is, and think of that as putting a PC together. A PC generally can't be put together without a case, so that what we're doing here is creating, or we have done is created the case. So next we need to create a monitor, so monitor, we'll call it the monitor, equals new monitor, and the parameters for this one needs a model, so we'll call it the 27-inch beast. Manufacturer, let's try Acer. Size, we'll go 27 for a 27-inch, and it also needs a native resolution. So we're going to create that, so we'll need to create that class. And let's do that a different way. I want to show you another way of creating a class on the fly. If you don't need to create a variable, you're not going to use it for anything else, you only want to pass it to a method, you can just type new resolution, and let's go for 2540 by 1440, which is the size of my monitor. So that's created an instance of a class without using a variable, which we don't need in this case. And I'll just fix that typo. That's monitor. So we've now got a case and a monitor that ultimately are going to be used to create our PC. Of course, we now need a motherboard. So let's create a motherboard. So motherboard equals new motherboard. And we need a model. BJ200, and let's go with ASUS. Number of RAM slots, well, there's 4 RAM slots on this one. Number of card slots, let's just say there's 6. And BIOS, let's say it's version 2.44. So there's our motherboard. So now we're at the stage where we can create our PC. Let's put our PC together. How do we do that? Well, we type PC, the PC equals new PC. And of course, it then needs the case, the monitor, and the motherboard. They're the 3 parameters that will collectively make up our PC. So we've now created the PC class by passing those 3 other objects to it. Now, of course, you've seen in previous videos with inheritance where we're able to use a method name that is part of the basic class, the superclass in other words, but how do we get access to it? So for example, if I want to draw something using the monitor, how do I access this method? So of course, we've got the method drawPixelAt, but how do we access that? How do we access that from our PC? Because of course the PC has got getters, but it hasn't got any way to access that. We're not overriding a method or anything like that. So how do we access it? Well, what we do, or one way of using it, we could type the PC dot get monitor dot drawPixelAt. So we could do it that way. We could do drawPixelAt 1500, 1200 in red. That's one way of accessing it. So what that is just using the getter function from here, which is returning the monitor, which is the class that has already been initialized, the object which has been created in this class. It's returning that to the calling process. And from there, what we're then calling the method drawPixelAt, which is from that object that's stored within in the PC class itself, in the PC object, the instance that we've actually created, and that's invoking that method for us. So likewise, we could put the PC get motherboard dot load program. How would we load the program? Windows 1.0. We're doing the same thing there. We're getting the class, the object that's been created when we created the PC class. So we're accessing it within the PC object, and we're getting it to load, to call the method load program, which is in that object, which of course is in the PC object that we've created. And of course, likewise for the case, the PC dot get the case dot press power button. We could do the same thing there. So they're accessing ultimately these functions that are in these base classes, the case, the motherboard, and the monitor, but accessing them via the PC object. So this is what composition is. This is the difference than inheritance. The PC object that we've created here. So what we did to call the PC object was we created our case, our monitor, and our motherboard. And in reality, when you're putting a computer together, that's what you'd be doing. You'd go away and you'd actually buy the case, you'd buy the monitor, and you'd buy the motherboard, and you're then putting it together to build the PC. So in this case, what we're doing is we're passing these to the constructor, which essentially is getting those items and putting them together, which forms our PC. So the PC has a case, has a motherboard, and has a monitor. So this is the way when you're thinking of whether to use inheritance or composition, think about what you're trying to do here. In this case, we're trying to build a computer, and we need to access the case, the monitor, and the motherboard. We know that these things, the computer has got a case, it has got a monitor, it has a motherboard, and so therefore composition is probably a great way to go. But of course, a case by itself isn't a computer. A case isn't a monitor, a monitor isn't a computer, and of course the motherboard isn't a computer. They're part of a computer, but not actually the whole computer, which is why we're using composition here instead of inheritance. So I'm going to end this video here. We'll continue on talking about composition in the next video. In the previous video, we started talking about composition. Let's continue on now and look at another scenario whereby we can actually hide the functionality further so that we don't allow the calling program to access those objects directly. So let's go and have a look at the example. So what we'll do first is we're going to go to our PC class. So what I'm going to do first is I'm going to change these and make these private. So in other words, the functions, these getters, won't be accessible by our main class anymore. And just to go back and show you what happened, we're now getting an error and it's saying it's got private access. So in other words, they won't be able to access them any further, but we'll still be able to access those internally. So let's create a function, public void power up. And I'm going to use get case, or get the case, dot press power button. Then I'm going to type draw logo. So if you think about it, a computer when it starts up, you press the power button and then you see a logo come up on the screen, which is usually the logo of the motherboard manufacturer. So we're going to implement that little private method. And it might do some fancy, graphics here. I'm not going to obviously write that code yet, but it'll be doing that there. And let's just say to call this method. So we could either use the get monitor dot draw pixel at 1250 yellow, whatever we wanted to do, using the getter, or we could access it directly by accessing the variable group directly. It really depends the way you're setting yourself up. Probably the better way of doing it would be the way that I'm showing you there with the monitor on the screen, because we don't really need those getters. They're not actually adding anything to us. They're really just making the code a little bit more complex than what we need. If we needed to do something else, in other words, if we needed to check whether the case had been, if we needed to check whether the objects had been initialized, or we're looking for something else, some other sort of form of validation, verification, we might want to leave those getters in there. But what we could actually do is actually get rid of those altogether to make our code look a bit more streamlined, and then just change it and just access those variables directly. Of course, that's the case. So we've now got a public function called powerup and a private function called draw logo, and of course the power up function of the PC will draw that logo on the screen as I mentioned before. We go back to our main class. Obviously these methods won't work anymore because now we've actually deleted them, so I'm going to delete those. But what we could do is put the PC dot power up. If we run that, you can see that the power button was pressed, drawing pixels at 1250 in color yellow. So obviously to access that, we access the PC.powerup method. So I went to our PC powerup method, which called the case.press power button, which then references the case object that's been created for this class. If you have a look at our case code, it's calling the press power button method to show that message on the screen. Then of course the second thing it did was it actually drew the logo, and it used the monitor.drawPixelAt method, and of course the monitor method does the system output there. So that in essence is what composition is. It's actually creating objects within objects. So you're having like a master object, in this case the PC is managing and looking after, and this is using composition to achieve that, as opposed to inheritance that we looked at in the previous video. So in a future video, what I'm going to do is explain where you should be using inheritance and where you should be using composition. As a general rule, when you're designing your programs in Java, you probably want to look at composition first. So if you do any sort of research on the internet, most of the experts will tell you that, as a rule, to look at using composition before inheritance, and it does give you added advantages and more flexibility. But with that said, it does depend on the solution and what you're trying to achieve. Okay, so it's challenge time. So the challenge is to create a single room of a house using composition. So think about the things that should be included in this room. Maybe some physical parts of the house, maybe some physical parts of the room, but also furniture as well if you like. Anything you think should be included in the room. You can create as many objects as you want to compose this out into whatever level of detail you want to get into. But make sure you add at least one method to access an object that is composed, which is part of that main class, to be accessing that via a getter, and then to access via a public method that object that was returned from the getter. And you saw me do that in the previous video. And also then add at least one method to hide the object completely, in other words, not using the getter, basically access that object from another public class. And you saw me do that in this video. So go ahead and do that and see what you can come back with. And when you're ready, come back and check out my solution. So pause the video now and I'll see you back shortly. Okay, hopefully you managed to figure it out and you had some fun along the way. Let's go ahead and now implement one possible scenario. So what I'm going to do is implement a bedroom. So I'm going to create first the main class and call it bedroom. And I'm going to have a bedroom, and it's going to be first have a name. Even though we know it's a bedroom, I'm just going to have a name anyway, like Tim's bedroom or something like that. And I'm going to create an object called wall. I'm going to have wall 1 through 4. Because obviously there's 4 walls. I'm going to have a ceiling. I'm going to have a bed, because it's a bedroom. And just for an accessory, let's go for the lamp. So I'm now going to create a constructor, which is going to be everything, and quite a few things there. And just to keep things simple, I'm going to create a getter for lamp. I'll just create it manually. And let's create a public method for making the bed. We're going to put a note there to indicate what we're doing. We're in the bedroom class, making bed. Then we're going to do bed.make. Okay, so I'm just going to breeze through these other classes because they're going to be pretty basic. Let's create the wall class first. I'm going to call it wall, and we're just going to have one field. We'll call it direction, where it's facing. And let's just create a constructor. And let's create a getter. Very simple wall. And for ceiling, let's do something similar. So we're going to do create ceiling, class ceiling. For this one, I'm going to have a height where the ceiling starts. And let's just go with, say, painted color. What the current color of the ceiling is. Constructor. And we'll also the getters as well. And you can see now as I'm creating that, some of these errors are going away because I'm creating the classes. Next, I'm going to create the bed class. So with the bed, let's start with the style. Let's style a bed. How many pillows. What the height is of the bed from the ground. Maybe the number of sheets. And whether it has a quilt. Or how many quilts. Create a constructor. Then we'll create our getters. But then we also need to create our make method, because if you recall, we're using bed.make over here. So let's create that as well, and we'll call that, it's a void method, and we'll call it make. And we'll just have a simple message that outputs, this time we're in the bed class, making. Okay, so we now created that as well, and our bedroom class is looking good now. We've just got the lamp to implement now. I'm going to create that now. Lamp. And let's try private string style. Private Boolean battery. Is it a battery powered lamp? Yes or no? And globe rating perhaps. Create the constructor. And let's create the getters. And let's create a method here to turn on the lamp. So public void turn on. Turning on. So we should now have got rid of all those errors. So we've now got a valid class there, which is good. So let's go back to our main method now and implement this. So what I'm going to do is start by creating our walls. I'm going to put wall 1 equals new wall, start west, create 4 walls, south and then north. Make them all unique. We need a ceiling. And if you recall, we'll say it's a 12-foot ceiling, painted color, just an integer, 55. We need to create a bed. So we're going to put bed equals new bed. Modern. 4 pillows, 3 foot perhaps, 2 sheets, 1 quilt. So there's our bed. And lastly, we need to create a lamp. So lamp equals new lamp. We'll say it's classic, false, no battery, and we'll say it's 75 is the globe rating. So we've now got the base objects that we can now pass to our bedroom to create this new bedroom. So to do that, we can do bedroom equals new bedroom. And of course, the parameters it needs is the bedroom name. We'll call it Tim's room. Or just Tim's will be enough because we know it's Tim's bedroom. Wall 1, wall 2, wall 3, wall 4. Ceiling, bed, and of course lamp. So we've now got our valid object bedroom created. So how do we make the bed? Well, if you recall from our bedroom object, we created a method called makeBed, which then itself called the method bed from the bed object. So all we have to do there is put bedroom dot make bed. That's how we make the bed. And the other way of accessing it, which was via the getter, bedroom dot get lamp dot turn on. Let's try running that. So you can see the bedroom class was called first, making the bed, which it and then in turn called the method make from the bed object that's part and parcel of this class. And then of course the other way of accessing it, which is via the getter, use that to access the lamp object, which again is part of our bedroom object, and turned on the light. So you can see that composition is very, very powerful. And as we progress through this course, you'll see examples of composition. And as I mentioned earlier, you'll understand more where to use inheritance and where to use composition. But as a general rule, you would aim for composition. That's what generally a lot of object-oriented programming experts suggest you do, is at least look at that first. So hopefully you did well in your challenge. In the next video, we're going to talk about encapsulation, which is another component of object-oriented programming. And it's something that you've actually been using for some time now, but probably weren't aware that you were using it. So I'm going to explain that in more detail in the next video. In this video, we're going to talk about a fundamental object-oriented programming concept, which is encapsulation. Now, encapsulation is the mechanism that allows you to restrict access to certain components in the objects that you're creating. So you're able to protect the members of a class from external access in order to, really guard against unauthorized access. Now, we're not talking security here, but we're stopping outsiders, in other words, classes or code outside of the class that you're working on, from accessing the inner workings of a class. So it can be very useful to hide that inner working from another class to sort of give you more control and to be able to enable you to change things without breaking code elsewhere. So let's go through an example of encapsulation. So what we're going to do first is we're going to create a class that doesn't use encapsulation to show you why encapsulation is a good thing. So we're going to start off with the class that doesn't use it, and then we're going to create an enhanced class that does use it. So let's go and create our class, and we're going to create a class called player, and we're going to model a player class as in a player in a computer game. So we're going to call this class player. It's a standard public class. And let's create a couple of variables. Public string name, public string health. So these three fields, public string weapon. We'll just say that in this game, these are the three fields that relate to the player's name, the player's health, how many hit points, in other words, and the player weapon. Now, you may have noticed, you may not have realized, I've actually used a public scope there. And we haven't gone into great detail about scope, but we have discussed it before. But we normally use private, but we're using public for a reason there, and that'll all become clear shortly. Now, we're not going to create a constructor, but what we are going to do is we're going to create two other methods. The first one is called lose health. And this would be called if the player lost some health for some reason. They fell off a cliff or they got damaged in some way. So we're going to pass a parameter called damage. And we're going to very simply put this.health equals this.health minus damage. And then we'll just do a simple bit of output, and I accidentally made that a string. That should have been an integer, so I'll just fix that. Actually, what I'll do there is I'll put if this.health is less than or equal to 0, then we'll put something like, player knocked out. And then here, which we're not going to do now, we'd put, reduce number of lives remaining for the player. So that's what we would normally do. So that's one method. And we're going to create another one, which is just going to return the amount of health that is available or that is remaining. We'll call that a public int health remaining. And that's purely going to return our variable this.health, which is our field in this class. Pretty simple class, as you can see there. There's a name, there's the health, and then there's a weapon that we can assign. We've got a simple method there, lose health, which would pass the amount of damage to it. Then if the total amount of health falls below or equal to or below 0, we were just going to print out a message to say the player's knocked out. And that's where we would normally put the code to reduce the number of lives and to check whether the game's over. So let's go back to our main class, and we'll create a new class. So we're going to start off by putting, and you've seen this before, player equals new player. We haven't created a constructor in here, and because we haven't created a constructor, if you recall, a default constructor with no parameters has been created for us. So we now need to manually set those fields, set the values for those fields. So let's try player.name equals Tim, player.health, let's say it's 20, player.weapon, let's say it's a sword. So that's our way to initialize those fields. And of course, as you can see, even though we're not in that class, we're able to access those fields directly. That's because we've set the scope here under public, or as public, for those fields. If we had to set those to private, we wouldn't be able to do that. And just to test it's working, let's put something like int damage equals 10, player.lose health damage. And if we print that out, we'll put remaining health equals, and it should be player.health remaining. So looking at that code, if we've started off with a player health of 20, we've got 10 damage, we've called the player.lose health method, which actually reduces the damage, we should get some output here to say the remaining health is 10. So let's run that. And you can see remaining health is 10. So let's just make a bit more space here. And if we do another call, we'll put damage equals 11. And if we just copy these here, paste those in, and if we run this, remaining health was 10, then that was for the first call. The second call, the player got knocked out, and that was the code that was called from within the player class, and remaining health is now equal to -1, because 20 take 21 is -1. So that's obviously working, but I'm wondering whether you can see a possible problem here. We've created a method in here, lose health, which is our code that is going to manage the whole process of the player losing health. So this is where we put all our formulas for making sure that we're calculating damage correctly. And then if you can see here, there's a special message that comes out if the player's knocked out. You know, we might update something on the screen in a complex application. We'd want all our functionality to lose health to be called from that component in there. But the problem then becomes, first of all, we've got the ability to change the player health, but we can actually change the rules here. So we can put, just before the call to lose damage, we can put something like player.health equals 100, or say 200 there. So we're overriding that. So we're taking the control out of the player class. You can see there that it was meant to have got to -1, but we've changed it, and consequently the player has got 189 health. So by being able to access those fields directly, you're really potentially opening up your application to be accessed in ways that you didn't want it to do, because you may not ever want the player to be able to change the health like that. You might want to control that process, and a good way of controlling the amount of health that we assign is with a constructor, for example. That's something that we've seen in the past. So that's one potential problem. It's the class that's calling this, the player class, is able to change those fields directly. But there's also another issue. So if we go back to our player class again, now let's just say that we've decided that we want to change the name here, the internal name. We think name doesn't make a lot of sense to us. We want to be a bit more clearer. We're going to change the name to full name. That's going to be the name that we're going to use from this point on. So this is an internal change, and in theory it shouldn't really affect any other class, because it's just the internal field name that we've defined that we think is a good name for this field in this class. But if we go back to our other class now, suddenly we've got an error, and it's quite rightly saying that it can't find that field anymore. Because we're trying to access these fields directly, we've got an error here. Now, it's not the end of the world, but what it means is that any time that we change a function or something in here, change a name I should say, field, change the field name or something along those lines, we have to also make the change here. And in a small application like this, of course, it's not going to be a problem. It's quite a quick change. But when you're talking about big applications, it does become a problem, because the first thing here, looking at this player, looking at the main.java, thinking is, okay, this name has changed. You have to figure out what's the new name. So you need to go back into the code and have a look and define and see what the new name is. So it's not really a problem as much when it's your code, but when you start using other commercial code, it's very, very normal for you to get given a library, a set of Java classes, and you're meant to use them. So it becomes a case of you, with this sort of design, having to figure out how that class works, which may not be something you want to do. The third issue with this approach is we might actually have forgotten to do this. Because we've actually put these names in manually, we might actually forget to actually initialize this all together, and consequently when the class is called for the first time, it hasn't got any health. So in other words, we're not guaranteeing and ensuring that to access the player class, you can only access it when the data is valid. Now we can do that with a constructor. We can actually make sure that the data is valid and that you've actually got a valid class. But when you're giving control and getting people to manually get access to fields, there's no real way of us guaranteeing that the player health is set. And the other thing is, of course, we might want to have a method that is in our player class to define the maximum amount of health for a player. So we might want to have some validation. So we might want to go through a method, for example, called add health, to make sure that they haven't selected a health that's greater than 100 or some other form of validation. And by allowing access at this level for people to actually just type in that directly, we can't actually call that validation. So this is what encapsulation actually does for us. This is why we don't want to code like this. We want the ability to be able to override these things so that we can make sure that the class that we're giving for access, that we're using for access, is actually valid, and that we've got more control over these things. So now you've seen some of the bad things, the bad ways of doing it. Let's actually comment this code out. And what we're going to do is we're going to create a class that actually has got proper encapsulation and show you the right way of doing it. So we're going to create a new class. We're going to call it enhanced player. So the difference is here, we're going to create our fields as private, a private string name, private int health, private string weapon. Next, we're going to create our constructor. And we're going to create a constructor with 3 parameters. Click on OK. And what we're going to do is we're going to define a default value of 100 for our health. And what we're going to do in here in our constructor, we're going to put a bit of code in. We're going to put if health, this is the parameter health, is greater than 0 and health is less than or equal to 100, then and only then are we going to actually assign the value to our field. So we've got some basic validation in there to ensure that the value of health cannot, well, should I put 200 there? That should have been 100. So in other words, a value of between 1 and 100 inclusive is the only values that we're accepting for health. So you can see that now we've created just one constructor. So that, in other words, we're guaranteeing now that the name, the health, and the weapon are initialized when the class is created. Now we could put some more validation in there to check the length of the name for argument's sake, to make sure there's some characters in there, that it wasn't null for argument's sake, and likewise for the weapon. So in other words, we could do some other validation to make sure that it's valid. Now we can still create our lose health. That can still be the same method it was before. So public, the actual fact, just to show that, we'll just create, or just copy rather, the exact same method. Exactly the same as it was before. And we can also create a getter. Let's just create a getter for our health. Very similar to before, but we're just using a getter this time. So you can see already we're restricting access, because now if we go back to our, wrong class, we go back to here and we do enhanced player, we'll call it player again. Player equals new enhanced player. Well, now that we've got this, we have to define some parameters. So we're going to put something like Tim 50 sword. And just to make sure that that's working, we're going to do initial health is player dot. And notice we cannot access the field names directly, the fields directly, because we've assigned them as a scope of private. So we need to use the getter. So the getter is the only way that's giving us that mechanism to actually get direct access to the health. So obviously if we run that now, we should get the value of 50. So looking again at the code, we started with a default of 100. So when the field health is created for this class, when an object is created, the default value is 100. And if and only if the health is passed with a value of between 1 and 100 inclusive, will we update that. So first time we run this, we should get the value of 50 because it is a valid value in that range. Initial health is 50, but if we try and make something like 200, we should actually get 100. We're getting 100, and that's because this validation has failed, because health parameter was outside of the values that we've signed there. In other words, it was greater than 0, but it was also greater than 100, so that's why that condition failed. So you can see straight away by doing it this way, we've got more control. We've got some validation which we weren't able to do if we weren't using encapsulation. And just to be clear, this is encapsulation. This is what we're doing, is by making our fields private, we're making sure that our class is not accessible, or the fields within the class aren't accessible to any classes that are outside. So let's just say I wanted to change now the internal name for health. I could do that. I can click on that, and actually what I can do is show you a feature of IntelliJ that is really cool, that enables you to do a quick rename. So you can actually click on what you want to rename, right click, go to refactor, then choose rename. And now if I go back and change this, the part that's in red, if I change that to hit points, notice how everything's changing on the screen as I type. I'm going to press enter. Pretty cool feature. And it's actually saying get a method found for the field hit points, rename the getter as well. I'm going to actually put no there, and I'll explain why shortly. So I'm going to click on no. Then the other thing, it actually comes up and says, oh, I've noticed you're now using the word health. Do you want to change that to hit points? So if I wanted to change it, I could just click on that and click on OK, and that would actually change these references that it's showing on the screen there. But I'm not going to do that, just to keep it consistent and just to explain why shortly. Click on OK. The point is I've now changed the field name, which was originally called health, to hit points. So internally, we're now using the name hit points instead of health. But if we go back to our main class, we notice now we can still run this code and nothing's changed. Still, it comes up with 100. And the reason is we're using the .getHealth method, and we've got no idea what the internal naming was for that particular field. We don't even know that we don't know anything about that, and we don't need to know anything about it. We're just calling this getHealth method, and it's doing the rest for us. So this is another cool feature in encapsulation, is we can make all these changes to this enhanced player class. We can create private fields and private functions that we don't want to be exposed to any other class, and we can change those names at any time in this code without affecting any other code. So that's really one of the huge benefits of encapsulation, is that you're not actually affecting any other code. It's sort of like a black box in many ways. What we're saying here is the only way to create an enhanced player object is to call the constructor with these parameters, and we've also got some validation in there. But the other thing is we can't also fake it now with the lose health, because you've got no mechanism to actually increase the health via any other means. We can pass the initial amount of health in the constructor, but we can't then fudge it like we did in the other class when we called that, when we set the value and then we actually changed the value midpoint when we shouldn't have. So we're giving all the control to the enhanced player class in this case, and in the case of losing health, we've ensured that no matter what, the only way with this class to reduce the amount of health for a player is to use this function. There's no other way for a class that's outside of this enhanced player class to access that. So this is why we want to be dealing with encapsulation. We really want to keep things confined and sort of reduce access, or protect is a better word. We protect the members of the class and some methods from external access. So we're doing that to prevent unauthorized setup or access. In this case, as I said, we're using it to make sure that the enhanced player, when we create a new object from the class, that it is valid, has got the right number of parameters, and they are initialized. But likewise, we're also making sure that there's no unauthorized access to the fields directly. So that's why you want to always use encapsulation. It's something that you should really get used to. You definitely don't want to be creating code like this where you're creating public fields. It's very rare that you'll need to do that. There are situations where you will want to, but generally speaking, you don't want to do that. You don't want to expose that access to other classes, because as you saw, it's more work to make those changes. When you create or when you change a field name or something of that nature, there's just more work for you to go back to all the other places, all the other code that's using it to make sure that's changed as well. So that's encapsulation. In the next video, we'll go ahead and I'll issue with a challenge, and you can have a go at solving the challenge I come up with. So I'll see you in that next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
So this is part 2 of the encapsulation videos. This is the challenge exercise. So let's type up what the challenge is. So this is the encapsulation challenge. To create a class and to demonstrate proper encapsulation techniques that you've learnt in the previous video. The class to create will be called printer, and it's going to simulate a real computer printer, a laser printer. So some of the fields that should exist in the class should be one for the toner level, the percentage of how much toner level is left, number of pages that have been printed, and also whether it's a duplex printer. Now, a duplex printer is capable of printing on both sides of the paper. So you'll want to add methods to fill up the toner, which should fill it up to a maximum of 100% based on the current value. So if it's only 50% full, you have to figure out a way to make sure that it doesn't go up beyond 100%. And you need to add another method to simulate printing a page, which should increase the number of pages printed variable as well. And you also want to take into account the duplex functionality and print out a message if the printer is a duplex printer when it's printing. Finally, decide on the scope whether to use constructors and anything else you think that's needed to demonstrate proper encapsulation techniques. So pause the video now, go away and check that out and try that out. And when you're ready to come back and see my solution, start the video again and I'll go through it with you. Okay, how did you get on? Did you create a solution for the printer class using good sound encapsulation techniques? So let's give it a go. We're going to create a new class called printer. So I'm going to go and do that now. Printer. And we need some fields. We need a field for the toner level. So I'm going to create just an integer, private int toner level. And what I'm going to do there is I'm going to set that to make the only of the allowable values to be between 1 and 100. And each number from 1 to 100 is going to be the percentage full that the toner is. Pages printed is going to be an integer as well. Pages printed. And lastly, whether the printer is a duplex printer, in other words, capable of printing both double-sided, I should say, I'm going to create a variable, Boolean variable. We're going to call it duplex. So if that's set to true, it means that it is a two-sided page printer, and if it's false, it's just a single page. So next we need to create a constructor. So what I'm going to do is to do just that, create a constructor. And what I'm going to do is I'm going to set two fields as the constructor parameters, the toner level, and also whether it's duplex. I'm going to leave pages printed out of the constructor, because that would normally be something that's set in the actual printer itself. It wouldn't be something that you would create or you need to add in the constructor. I'm going to initialize that to 0. So I'm going to click on those two and set those, as you can see there. I'm also going to put this pages printed, we're going to initialize that to 0. We're also going to do a test here. We're going to put if toner level greater than -1, because we can allow the toner to be empty. So we want to make sure the value is that we're going to accept between 0 and 100, and the toner level is less than or equal to 100. Then we're going to put else what we're going to do is we're going to put this dot toner level equals -1. So that's often a way to set a variable and make it just indicate that it hasn't been set correctly by setting it to -1 if it doesn't fulfill some validation. So that's our constructor. So next we need to create a few methods. The first one, we want to create a method to replace the toner, making sure that we can't get it beyond 100%. So I'm going to create a public method. We're going to actually, it's not going to be a void, it's going to actually return, and the integer is going to be how much toner we actually added, making sure that we don't exceed the 100. So we're going to put add toner. We're going to accept a parameter which is the toner amount. So the first thing we need to do is make sure that the amount of toner that's been passed to this method is valid. So we can do that by putting if toner level is greater than 0. Now we're doing a greater than in this case because the very fact of adding toner to a printer is you need to actually add something. Unlike the constructor, which we set up, which actually created the printer object, that could have a value of 0 to set the initial level, we're actually now creating a method called add toner, where we're actually adding some toner to the printer. So therefore we want to make sure that the toner level is actually greater than 0. So it's greater than 0 and toner level, so toner amount that should be, is less than or equal to 100. This one there should be toner amount. So that's the amount that we're actually trying to add to it. And we'll come back and add that code shortly, but we're going to put an else return -1. So again, that's another way of returning some sort of validation, some sort of status. In this case, we're saying if it falls outside of the toner amount being greater than 0 and less than or equal to 100, we're going to return -1, which is our way of saying you attempted to add some toner to the printer, but it was outside our valid ranges. So therefore, what we need to do now is we need to actually test the amount of toner that's already on hand. Then we need to add to that the toner amount that was passed to this method, and if it actually exceeds the total amount of 100%, we need to return an error. So to do that, we're going to put if this dot toner level plus toner amount is greater than 100, return -1. So there's our test to say that if, for example, there was 50%, the toner was half full, so the value of toner level was set to 50. If we get past an amount of 60, that if we added the 60% to the 50, that would be actually 110% full, which is not possible. So we're not going to allow that. So we're doing a test to add those two together. And if they're greater than 100, it means we're trying to overfill it, which isn't possible. So we're just going to return an invalid number. Otherwise, at this point, we're now able to add the values because we know that we've validated it correctly. So I'm going to put this dot toner level plus equals toner amount, like so. And then we can put return dot toner level. So we're going to actually return the amount that it's now set to. So we're adding the toner and it's returning how much toner is now in the toner cartridge, and we're returning a -1 if there was an error. And if that's the case, we're not actually setting anything. We're not changing the value of our toner level. So that's how to go about adding the toner in a method. So the next thing to do is now to actually implement the printing. So I'm going to add the printing method. So we're going to click on public int print pages. We're going to call it print pages even though it's possible to print just the one page. We're going to put int pages, the number of pages to print. And what we're going to do is we're going to assume that the page count is actually the number of physical pieces of paper that are going through the printer. So therefore, if we are in duplex mode, if we're printing on both sides, what we need to do is divide the total number of pages by 2, because that's the net number of pages that were printed. So what we're going to do is we're going to put int pages to print equals pages. And we're going to put if this.duplex. We're going to put pages to print divided equals 2. So we're going to divide the total number of pages by 2 if we're printing in duplex mode, then we also have to print out a message to put printing in duplex mode, just so it's clear that we're actually printing in the duplex mode. So that's our print pages method. And the other thing we need to do is return the number of pages that were printed. So we're going to type return pages to print. But of course, there's also one other thing we need to do. We need to update the pages printed. We'll put this dot pages printed equals plus equals pages to print, like so. All right, so inside the print pages method, there's a logical error. Now, when printing the odd number of pages, the result is in fact not correct. For example, printing 5 pages in duplex prints 2 pages instead of 3. So to fix that, the code inside the if statement should be, and I'm showing that on the screen now, pages to print equals, parentheses, pages divided by 2, plus parentheses, pages modulus 2. The modulus operator, in other words. And the modulus, by the way, or remainder operator, it requires 2 operands, and it's a division operation. The remainder is returned by using that operator. So basically, in this scenario, in case the result is an odd number of pages, the remainder will be 1, and therefore the pages to print number will in fact be correct. And just a thanks to quite a few students who pointed this out, I've now updated this video to reflect that. All right, so moving on. So that's that. And the last thing we want to do is we want to add a getter so that we can actually retrieve the number of pages printed to check that the value is correct, like so. So that's our basic class now. So let's go and try using this class. So we go to this class here now, the main class, and printer equals new printer. And of course the parameters are toner level. We're going to start with 50% and we're going to say true initially. So let's try doing the page count. So we know that what the page count is, it should be equal to 0. So we'll put initial page count is equals printer.get pages printed. And again, we're using encapsulation here with our constructor and also with our getter here. So we're not accessing the fields directly, which is correct encapsulation techniques, object-oriented programming. So let's now print, say, 4 pages. So we're going to put printer, what we'll do is we'll put int pages printed equals printer dot print pages, and we'll say 4 initially. And we're going to put pages printed was, remember this is how many physical sheets of paper were printed. Pages printed, and then we'll put plus new total print count for printer equals, and that's going to be our printer dot get pages printed, like so. So let's try running that first and see what it does. And I'll just move this over so we can see it a bit better. So the initial page count was 0, which is correct. Printing in duplex mode has been set because we just defined that to true. Pages printed was 2 because that's the total number of pages was actually 4, but because we're printing on both sides, it's only 2. New total print count for printer equals 2 as well. That's correct. And just to make sure, let's do another one. Let's put, we'll put pages printed equals printer dot print pages. Let's say there's another 2 pages. And let's just print it out again. So let's now run that. And you can see that what's happened here is working correctly. It's now the second example. It's printing in duplex mode again. The pages printed was 1 because we passed only 2 pages. We had 2 pages to print and it printed on both sides. New print count for the printer overall is now equal to 3, which of course is 1 more than the previous count. So that's the total number of pages, A4 pages that have gone through the printer. So that's working. And then just to confirm, let's set duplex to false. And what we should do is get some different values here now because we're not printing on both sides of the printer, or of the paper I should say. We'll run that. Initial page count was equal to 0. Pages printed was 4. new total print count for printer equals 4. That's because we're now not printing in duplex mode. We're not printing double-sided. So 4 pages to print used 4 sheets of paper. And in the second example, we used another 2 pieces of paper, and it needed 2 pages, because that's what we actually passed to as a parameter. And the total print count was 6. So that's the printer class using encapsulation. So it's very, very good object-oriented sound programming practice to use encapsulation to hide that functionality from your other classes. In this case, you can see that we're not accessing any fields directly, and we've got proper methods that are actually doing the appropriate calculations or adding and subtracting numbers hidden away from the user. So if you're someone who's using this printer class, you've got no idea of the internal workings of that class, and in fact you don't need to know it, because all you're doing is you're using any of these methods that have been set to public, the scope of public, and you're using those in a correct manner, and everything's working perfectly. So that's it. That's the encapsulation challenge. I hope you got a lot out of that. Let's move on now to the next video, where we're going to be talking about polymorphism and what that is and how to use that in our Java programs. In the previous video, we finished off our encapsulation challenge. Let's make a start now on polymorphism. So I want to go through and give you an overview of what it is and show you how it works. And then in the video following this one, we're going to give you a challenge for it. Now, incidentally, this is take 2 of my polymorphism video. You can see at the top of the screen there, it says polymorphism 2. And that's because I recorded the entire lecture and went to edit the video and found the sound was corrupted. Very frustrating having to do it twice. So anyway, let's get started. So polymorphism is really the method or the mechanism in object-oriented programming that allows actions to act differently based on the actual object that the that the action is being performed on. Now that probably doesn't make a lot of sense. So the easiest way, as is the case with a lot of programming things, is to show you an example. Now, so what I'm going to do to actually demonstrate polymorphism, we need to create a number of classes. And what I'm going to do is I'm going to create the classes all within this main public class, the main.java source file, I should say, which is another way of creating classes that aren't going to be reused. The advantage of doing this is it's really only useful to create classes usually in the same Java source files if they are quite small and compact. If you start creating big classes and you've got multiple classes in the single Java file, you can find it gets quite confusing. And bear in mind also that when you're creating these classes, they usually are actual modified. Depending on the modifiers you're using, they may or may not be accessible outside of the package. So we'll talk more about scope in a future video, but suffice to say now that the reason that I'm doing this is just to save a bit of time in the videos. So what we're going to do is we're going to create a basic class called movie, and then we're going to create a number of classes that relate to a specific movie that's come out of the past. So we're just going to inherit from that, and I'm going to show you how polymorphism works. So firstly, I've got this main.java created, which is our standard template. I'm going to create a new class movie, and it's going to have one field. We're going to have a private string, which is going to be the name of the movie. We're going to have a constructor, and its purpose is just to set the value for our field. And we're also going to have another method, and that method is going to be called plot, and that's going to be the plot for the film itself. In other words, the synopsis or what the movie is about. So public string plot is the method name, as you can see there. And the default the default string I'm going to return is going to be no plot here. And that will make sense shortly when we start creating some of these other classes. So that's our base class, and we're going to create 5 additional classes now, and they're all going to inherit from this base movie class. First one, class Jaws. Extends movie. I'm not sure whether you've seen it, but Jaws is a classic movie. So we need to create a constructor for that, but we're going to do constructors in a slightly different way for these subclasses. We're going to do a public Jaws. I'm going to put super JAWS. So I'm going to initialize that, and you can see that using inheritance, we're actually initializing the name field from the base class, which is the in this case is the movie class. So that's our constructor, pretty straightforward. But we're also going to create a method called plot. It's going to have exactly the same parameters and return type. In other words, no parameters and the same return type, which is string, as the base movie class. We're going to call it plot. We're actually going to now return the plot of JAWS. A shark eats lots of people. I'm sure there's more to it than that, but that's it in a summary. Okay, so that's our JAWS class, and notice how the method is exactly the same as the method that's in movie. So we were overriding that. So probably what I should have done more correctly is use the override. But either way, the same process applies. The method has been overridden. So next one we're going to create is Independence Day, another one of the movies that I like. And that also extends movie. We're going to have a public constructor. Incidentally, if we use the automated constructor creation, it actually gets it a little bit wrong because it assumes that we want to initialize the class using a parameter, but we don't actually want to do that in this case. So I'm going to actually delete that and just type it in there. For our polymorphism example, it makes more sense doing it this way. Independence Day. And what I was saying was we can override it. We could also use override method, which is the same as typing it manually. And you can see there it's got the constructor we can override, but also it's got the method plot we can override. So I'm going to select that, press enter. But I'm not going to use the super. I'm just going to do a return. Aliens attempt to take over planet Earth. And I spelled that wrong. Independence Day. That's right. Okay, so we've got a few more to create. So let's create another one now for Maze Runner, another movie that I liked. Extends movie. And I'll just make a bit of space so we can see this with all these extra messages popping up. Same deal with the constructor. I'll just change that. Like so, and override the method for plot, and we'll put escape a maze. Okay, let's create another one. Another one that's strong in my memory. So when I was a child, Star Wars. Yes, you can tell I'm a bit of a geek. Star Wars extends movie. Same deal there, constructor. Update the constructor. And we'll call it Star Wars. Just capitalize that. And override the method. The plot. And the plot's going to be Imperial forces try to take over the universe. The last one we're going to create is a little bit different. We're going to create a class called Forgettable Movie. So it's not actually a specific movie. It's still going to extend from the movie though. Like so, same constructor. Now, importantly, we're not going to override the plot methods for this one. And this will make sense and actually show you how polymorphism works by not doing that. So you'll see that later on in this video. So okay, we've now got a base class. Just looking back at and reviewing what we've done. We've got our class movie, which has got a field called name. We've got a constructor that initializes that name. We've got a method called plot. Then we've got a total of 5 classes that extend or inherit from that movie class. They all initialize via the constructor, their own constructor, passing the parameter of the name of the particular movie, and that gets obviously saved in the base class. And most of them, 4 of the 5 classes have got their own plot method, which gives them plot what the plot is, a very brief summary of the plot for each of those movies. Then we also created a fifth class called Forgettable, and it hasn't got the plot method, which we'll understand why it hasn't got that shortly. So moving on, what we want to do now is we want to create a method, a static method, because it's part of this main.java and not a separate class. And the purpose of this method will be to return a random movie. So it's going to return one of those 5 classes, one of those 5 movies. And you'll see why we're doing that shortly. So let's create that method. And we're going to do that with public static. Actually, what I'll do is we need to actually put it into the class. So I'm going to actually delete that to make a bit of space. Then make a bit of space up here. So we need to then create this method. This method is going to be part of the main class. And it's going to be public static. We're going to return movie. So our return type is going to be the object movie. And we're going to call this random movie. So its purpose is to return a random movie. In other words, one of those 5 movies. So in order to be able to return a random movie, we need to generate a random number so that each time that this method is called, obviously a random movie is selected. So how do we do that? We use a math function that comes with Java 8, which will generate a random number for us. So we're going to type int random number equals, and we need to cast it to int. You'll see why shortly. Int. Then we need to do math, capital M, math dot random. And you can see there that by default, this method, you can see on the right hand side there, it returns a double. That's why we're doing a cast of int, because we want to convert this to an integer. So by default, which you'll see, I'll take you into that method shortly, this will return a random number, a double between 0 and 1. So what we're then doing is we're converting that to an integer, and then we're multiplying, in this case, by 5. So by doing that, that's going to return a random number in the range 0 to 4. And what we're going to do then is add 1 to that. So in other words, we're going to return a number between 1 and 5. So if we just go into that class to have a look, to that method rather, and have a look, we can click into there, and you can see that this is a method pseudo number generator, and it returns a number greater than or equal to 0 and less than 1. So what we're doing is we're casting that as an integer, as I said, returning whatever the number is, and then multiplying the answer by 5, and that will give us an integer in this case between 0 and 4, and then we're adding 1 to that answer. And that's so it'll make more sense shortly while we're doing that, just so it makes our code a little bit easier to read. Now what we need to do is, well, actually what we'll do first is we'll print out what the number was. What random number generated was plus random number. So we'll know what the number is, so we can actually check that and see that on the screen. So next what we want to do is we need to do using the switch statement, we're going to actually create one of these movie classes. So we're going to do switch random number. We're going to put case 1. So if the random number generated was 1, we want to return a new, and of course the first one was Jaws. So we're going to return Jaws. Case 2, return new. The second one that we created was Independence Day. Now you notice I'm not adding a break there. The reason I don't need to add a break is we've got a return in there as the first line. So it would be redundant to actually go back here and put a break in there. You can put it in there if you wanted to, but we actually are returning from this method anyway, so there's no need to do that. Case 3, return new, and the third movie was Maze Runner. Case 4, return new, Star Wars. And lastly, case 5, we're going to return new Forgettable, our Forgettable movie. And then what we need to do here is we'll put a return null. And the reason we need to do that is technically, as far as the switch statements was concerned, we tested for the numbers 1 through 5, but as far as it was concerned, it could have other values. So we could have actually put a default in here to process based on that. So in other words, we could have put default return null, which then makes this return null down here void, or we can just leave that out. Either way, we need to actually handle the fact that it could be outside of that range. But the way we've defined random number, that shouldn't happen anyway. So what it's doing now, as you can see, depending on the number, whether it's 1, 2, 3, 4, or 5, we're going to return one of those movie classes. So each time we call this random movie method now, we should actually get a random movie return to us. And just take a look at the fact that we're actually returning the movie. So we're returning a base class, the superclass in this case, movie, because of course all these classes actually inherit from movie, and that's why we can use that once to apply to all these classes, because of course the way inheritance works, we can use that is a relationship. So we can say that Jaws is a movie, Independence Day is a movie, Maze Runner is a movie, and so on. That's the basic concepts of inheritance. But let's now have a look at the polymorphism aspect. So what we're going to do now is we're going to go back to our main method up here, and we're going to create a for loop that actually goes through a number of times, retrieving a random movie, and then actually start using that polymorphism to actually call the relevant plot method for that class. So the way we do that is we're going to create a for loop first, where we're going to put for int equals 1, int less than 11, I plus. So we're going to cycle through a total of 10 times. I need to put a variable there. So to call the method, we're going to create a variable, movie equals random movie. So we've now got our movie in our movie object. Now let's print something out. So we're going to do print movie hash I. So that's the movie that we're working on. Next we're going to put a plus, and let's just tab over here and we'll put, let's display what the movie name is. Now notice that there's no get name yet, and of course the reason for that is up here when I created the movie class I didn't create a getter. So I'm going to create a getter now, getter for the name field, and we'll now be able to use that to actually retrieve what the name of the movie is. So looking back down at our code again, we should now have that getter available. As you can see, it's there out of \n, and what that does, it actually generates a new line. So in other words, it starts the output on the next line. So we're adding that plus, and we'll just tab over again, and this time we're going to actually do the interesting thing, which really shows you how the polymorphism works. We're going to put plot plus movie.plot plus, and we'll just create another new line, so we'll move on to the next line. So that's that one little part here. This movie.plot is really the definition and how polymorphism works. This is going to be better explained if I actually show you it running. So what I'm going to do is just close that side view like so, and we'll run it, and then I'll explain what it's done. And drag this over a little bit. So you can see what's happened there. Random number generated was 1. We got movie number 2. So the random number generated was 1. And if we look at our code again, case 1, we should be returning the Jaws movie. Next time, random number generated was 3. Movie number 3 should be Maze Runner, which it is there. We've got lots of 2s and 3s there as well, as you can see, but we've got Independence Day there as well. So can you see what's happening here? This is the beauty about polymorphism. Because if you're looking at that code, movie.plot, that's actually doing quite a bit of work. What it's actually doing, what Java is doing, it's looking at the object called movie, the variable that we created that was returned from the random movie method, and then it's going down and looking into that object and seeing, has it got a plot method? And you can see in this case, if we look at the first example for Jaws, going back up to our Jaws class, yes, we have got a method called plot. So therefore, it's smart enough to go, okay, I'm going to execute this method plot here in the Jaws class, and it automatically returns that a shark eats lots of people. And likewise for Maze Runner, you can see that we got a completely different output from Maze Runner. We actually got kids trying to escape a maze. So you can see what's happening is with that one line of code, this movie.plot, this is what polymorphism is. We're actually assigning different functionality depending on the type of object that we've created. Bearing in mind that all these objects are inherited from the base movie class, but we've assigned a unique bit of functionality in each of those plot methods for each of those classes. Now in this case, it's a very, very simple method. It only outputs the name, or the plot I should say, for the movie. But you can imagine we could have a lot more complex functionality built into that if we wanted to. Now I'm just going to run this again because this random number generator is purely random, even though we've got what seemed to be a pattern there of the same number 3 a number of times. It is a random thing. So let's just run that again and get some different results, because I wanted to come up with number 5. And we can see that we've got different results this time, and we have actually got the results. We've got a 4 this time, which we didn't have last time, which is good. But we also got number 5, and this is the other point about polymorphism that I want to make. The random number generator was 5, and that equates to returning a new class called forgettable. So the movie number 3 in the loop was called forgettable, but plot, no plot here. So if we go back and have a look at our forgettable class, if you recall, we didn't actually create a plot method for that class. So what's happened, again, using polymorphism, is that Java's looked at that and said, okay, there's no plot method here that has been overridden in this forgettable class. So as a result, it then looks and says, okay, I can see that we're extending from the movie class, and it'll go back up to the movie class, and it then finds the method called plot, which exists in the movie class, and that's where this code has been executed as coming from, no plot here, which is pretty cool. So you can see how polymorphism works now. It will automatically, if you're inheriting from another class and you've got a method and you override that method, that's what polymorphism is. It's giving unique functionality for the class that has inherited from a base class. So there you go. So that's the concept of polymorphism. I hope that makes a lot of sense to you. You'll find this is incredibly useful once you start developing more Java applications, because it really enables you to write quite generic code. Again, can you imagine if you didn't have the ability to do polymorphism, looking at something like this one line movie.plot, you would have to figure out a way to decide what the type of class was and then to somehow call the appropriate class. So you'd probably have a large switch statement with the if class equals this name, then actually call this particular method. So it'd be a lot more work, in other words. But Java really makes it easy for you by adding this polymorphism capability automatically. So that's polymorphism. So I'm going to end this video here. In the next video, we'll go ahead and start our polymorphism challenge. So I'll see you in that video. So this is the polymorphism challenge video, and we're continuing on from the previous video. So let's now talk about what we're going to actually have included in this challenge. So I'm going to type out what we're proposing to do. Okay, so here is the challenge. So we're going to go back and use the car analogy. We did that, of course, in previous videos. So create a basic class called car. Now this is a generic class that the other classes are going to subclass. So this base class should have a few fields that would be appropriate for a generic car class. Engine, true or false, cylinders, as in the number of cylinders in the engine, number of wheels, those types of things. And you can certainly come up with some more. That's just 3 examples. The constructor should accept 2 parameters. The parameters would be the number of cylinders for the car and the name of the car. Then you should also initialize the other parameters as well in that constructor. You'll also want to create appropriate getters for those fields so that they can be accessed elsewhere. And you need to create a few methods like start engine, accelerate, and brake. Put in a message, simple message to output to the screen just so you can confirm which class you're in and which method is being invoked. And show a message, as I've said, for each of those in your base class. Now, after that, create 3 subclasses for your favorite vehicles, and they're going to subclass the car class, essentially. So you then want to override the appropriate methods that you created in the car class to demonstrate polymorphism so you understand what that's doing and how it works. And you'll also want to put the same messages that you put in the base class in each of those other classes, but make the message different so that you can see where it's being called. And as I showed you in the last video, also put all classes in this one Java file just for this example. And that Java file will be the one that we're in now, the main package, or the main Java file, I should say. All right, so see if you can figure that out. Go away and do your best to complete the challenge. And when you're ready to come back and see what I've done, resume the video. So pause the video now and I'll see you when you come back. Okay, how did you go? Did you figure out the challenge? Let me show you my solution. So what I'm going to do is start off first with our car class. So we had to create a base car class. I was going to call it class car. Like so, we need to create a few fields. I'm going to do private Boolean engine. So that's whether it actually has got an engine. Private int cylinders. We've got a name, private string name, and lastly we also want to set the number of wheels, so private int wheels. Like so, we need to create a constructor which should initialize the cylinders and the name, which are passed to it as a parameter, and then just to set the other ones to those values that we've got indicated below. Okay, so I'm going to create a constructor, and I'm going to use the two parameters which we talked about were cylinders and also the name. They're the only two parameters. The other two we're going to set the values manually, like so. And so it'll be this dot wheels equals, set that to 4, and this dot engine we're just going to set to true in case it's all the cars that we're using. This car class and all the subclasses will be set to true. We need to create a getter, so let's create a getter for each of those in case we need to access them. Actually, we won't create one for engines, seeing as though it's a little bit meaningless because we've actually got that set to true, and actually the same for wheels because wheels is set to 4 no matter what anyway. So we'll just leave those out and do the other two. Next, we need to create a few extra methods, simple methods that will show some basic features. So we're going to use start, engine, accelerate, and brake. So I'm going to create those methods, public. They're going to return a string for each, start engine, no parameters, and we're just going to put return. And what I'm going to do is just put the word car and a dash and a greater than sign just to signify that we're actually in the car class. And we'll put start engine. Then likewise for the accelerate method, public string accelerate, return car, and it'll be accelerate, accelerate like so. And lastly, we'll do the brake one. I can type public string brake, return car brake. So there's our basic class there now, pretty basic as you can see. Just confirming we've set the fields up, we've initialized the constructor, and we've set the other values with hard-coded wheels and engine as well. And we've created appropriate getters, and we've created our 3 methods. And we're also showing a message for each of those classes, so that's good. So now what we need to do is create 3 subclasses for your favorite vehicles, 1 for each vehicle, then override those other methods and put some prints in there, and then we just want to show them working in the main method. So to do that, let's create one first. I'm going to create a class for Mitsubishi. So class Mitsubishi extends from car, like so. And we're getting the error now, and the error is there's no default constructor available. And the reason for that, of course, is that we've actually created a constructor up here with parameters, and because we're doing that, we now need to specify a parameter. So what we're going to do there is create our constructor, and you can see it's automatically accepting those 2 parameters, cylinders and the name, and it's calling the super, which is going to call, of course, the super classes constructor to initialize it there and save our values. So that's the constructor done. Next, we need to override those 3 methods, so we can just use our override function. Override. So let's go through, and we now need to override 3 of them. Note that you can also override getters. We're not going to do that, but you could actually do that if you wanted to. I'm going to select those 3 methods, start engine, accelerate, and brake, and override those. Now you notice the default option that IntelliJ gives us there is super.startEngine, and that's a way to call the super function. So in some cases, you may want to do that. You might want to call, do some processing in that base class for here for start engine, and then provide your functionality after that, over and above that. So I'm going to leave that out, but that would be how you would call it if you wanted to call that before actually adding your own code. So what we're going to do there though is I'm just going to take a copy of this. I'm going to paste it there, but I'm going to change that. We're going to call that Mitsubishi. And I'll do the same for the other two. I'll just move the screen a little bit so the little messages down the bottom don't impact us. And of course I need to change then the name of the method, so it's going to be accelerate and break. Okay, so if we just do a test run of that now just to make sure that it's working. So firstly we could put car equals new car. And we could just put 8, base car. Then we could put car dot start engine, car dot accelerate, car dot brake, like so. Move it up a little bit. So if we run that now, we should just see the basic messages from the base car class. And we're actually doing a return there. The reason that's not working is we should probably change that. It's got a return. Probably should have changed that to output that in that method just to save us a bit of time, but that's all right. What we'll do, we can fix that. We can go like this. We can put system.out.println and wrap that around the method. And what that will do is actually print whatever was returned from that method. In this case will be our message. So we can do the same for that one. And then the same for this one. Like so. So now we've wrapped the actual method call inside a system.out.println. So we're actually just printing out whatever the result is coming back from that method. So I'm going to click on run again. We should see that now on the screen. We can now see that that's working. Car, start engine, car, accelerate, car, brake. So likewise, for Mitsubishi equals new, Mitsubishi, and we can put the number of cylinders for that one. We might say it's a 6-cylinder, and we'll put it, so we'll say it's an Outlander VRX, 4-wheel drive. And we could do something similar to that. We could call those methods. And we'll just change the Mitsubishi there to, the car to Mitsubishi. So we're actually calling the right method. So let's now run that. And we can see we're now calling the Mitsubishi method, Mitsubishi start engine, Mitsubishi accelerate, Mitsubishi brake. So that's good. So we can now do the same for our 2 other cars. So what we could actually do, we should be able to do this. We can actually click on that and click on refactor, copy. We can actually copy an entire class. So it's asking us what the name of the old class is. Well, we've already selected, I should say, the old class. What is the new name going to be? And it's going to create a copy of that class. And it's also asking where the destination is going to be. So I'm going to click on forward, or type forward, I should say. And OK. Now you see what this has done by default? It's actually pretty well done everything that we wanted it to do. And we can actually add a bit more code here. So it's actually working, but it's created a separate class. By default, it's created a separate class, which I won't go back and change that now. But this is a quick way to copy and create a new class, as you can see, instead of doing all that typing. So just another way of doing it. We can actually then go back to our main class down the bottom here. We should be able to do exactly the same with that. But this time, what we're going to do, we're going to just rename this. Just selecting the variable, clicking on refactor, rename, and if I change that now to forward, whoops, you can see as I'm pressing delete, that's working, which is good. That's a quick way of changing it. Then we'll change this to forward as well, and change the constructor name, the class name I should say. So, and obviously change the actual car name as well. Ford Falcon, that's about the only one I know off the top of my head. Run that. Forward is now working, as you can see. And if we did want to, I think there might be an option to do this. We just click on, right-click, refactor. I think we can click on inline. Inline all references and remove the class. So let's just try that and see what that does, because we can always undo it. Refactor. Interesting, that's done something. You can see what it's done there. It's actually created a class within the constructor. So you can see this part here has been created. That's what's called an inline class. So it looks like it's actually a parameter. You might be wondering, well, why isn't it separate to this one here? Like this class for Mitsubishi is completely separate and we've typed it all in there. That's another way to create a class. It's called creating an inline class, and we're creating it right at the point where we're actually initializing it. So I wouldn't recommend that in many cases, but one place you'll see that quite often is in Android applications for things like click listeners. In other words, when you're wanting to create an event or actually place a listener on a particular button on the screen and for it to actually do some action, perform some action when that button is tapped. That's very common for that. But we'll see that later in the course. We'll talk more about inline. But that's just another thing I wanted to show you, another way of doing it. So I'm going to undo that. And I'll just press, in this case, Command Z and say, do you want to undo that? So I'm going to click on yes. And you can see down the bottom what it's done. And we've probably now, if we have a look at our view, at our classes, we've actually got our classes back there again. So it's undone that change, which is pretty nice. So I'm going to leave that in there anyway. That was just another way I wanted to show you of how to quickly change something. So let's just go back here again to our Mitsubishi class. And this time I'm going to do a copy, refactor. We'll do a copy. And this time we'll create a class called Holden. Like so. And now we're going to do a right click that, click on refactor and try move to package, and it's try this, make in a class of. Let's choose our main class. This is another way to create one, and click on refactor. Now you can see by doing that, it's largely got this right, but it's actually created the class and it's moved it from what was external back into this particular Java file, which is a good step in the right direction. And we could do the same thing with IntelliJ by going back to our forward class. You right click that, refactor, move, make in a class of, and we'll choose main again. And notice that says Holden in main now. So that's telling us it's actually a class within the main class. And click on OK. Click on refactor. We've now got our forward class in there. And what we can do then, just to change this a little bit, we'll go back here, we'll copy them both, take them out of there, and actually I'll make a bit of space here. You can see what we're doing. If we go back up to the top again now, and just below that second definition, I'm going to paste the classes in there now and get rid of the word static, which now are not appropriate because we're not actually in the main class anymore. And I'll take it back out of there again as well. So now we should have our three classes like I originally was going to do: Mitsubishi, Holden, and also Ford. And we could just do last thing we could do there is just copy that and paste that. Do a rename, right clicking on the variable for Ford, refactor, rename. We'll call that Holden. Press enter to accept the change, and then we'll just change this one. Holden. And we'll put Holden Commodore, which is another brand, which is a model within the Holden car class. Run that. Whoops, and what did we do? We made a mistake here. We copied the class and we didn't change the actual messages that are showing on the screen for the last one. So we go back and have a look. We can probably see that we've got Mitsubishi in the Holden class. We didn't actually update that, so I need to click on that and paste that in, because obviously we want the word to appear to tell us which class we're actually in. So I can click on run that. We can now see that that's working as well. So that's our polymorphism challenge. And just one last thing I want to show you is there's actually a way within Java, instead of having to remember the class, if you want to output the class, you can actually retrieve the class name. So we can do something like get class dot get name. Get simple name is the way to do it. And then we can put plus, like so. And that would be another way of actually doing it. So we could then just do the similar thing for the rest of them. We could go just copy up into that part. And we'll just do this just for the Holden class, just to show you. It's just another function within Java to actually get it to do the work for you instead of you having to hard code it. So what that's doing now is getting the class, and that's looking at where the code is executing, which class it's currently executing in. And get simple name is a way just to retrieve the actual class name. So if we do that, we should find that it should still say Holden and the little dash greater than sign and start engine for each of those things. So run that. And you can see that it still says Holden. So that's another feature that's built in. And you might be wondering, where did that get class come from? Because that's obviously a method. And where is that coming from? So we can actually click on that to see. I'm holding down Command on my Mac. And notice it straight away, it's showing you object. Remembering that all classes that you create in Java are actually extended automatically from the object class. So that's one of the purposes of the object class, is to give you functionality like this, among other things, to do some base things like returning the name of the class and so forth. And Java uses that internally to figure things out. So that's another good way of figuring out which class you're in. And in later videos, we'll actually be talking more about that and how you can actually write some code. You can actually check the type of object and do a comparison to say, is this class of type, whatever. So it's just another way of giving you more flexibility in your programming, but we'll be doing that later on in the course. Okay, so that's the polymorphism challenge, and that's actually the end of the object-oriented programming section. But what I've got coming up in the next videos is I'm going to create a big challenge for you, because the last two sections we've learned a lot about object-oriented programming, but it's time to put your skills to use, because what we're going to do is create a much larger application than we've created before. We're going to use all the concepts of object-oriented programming that we've learnt in the last two sections. So we're going to use all those major aspects and create a bigger application to hopefully really solidify your understanding of object-oriented programming. So we'll see you in that next set of videos where we start our big object-oriented challenge. So this is the object-oriented programming sort of master challenge, where we're going to build a complete application using and understanding, hopefully, all the principles of object-oriented programming that we've learnt in the last two sections. Okay, so this is the first part of the challenge. So the purpose of the application is to help a fictitious company called Bill's Burgers to manage their process of selling hamburgers. So the application is going to help Bill to select the type of burgers and some of the additional items or additions that can be added to the burgers, as well as the actual pricing. So we want to create a base hamburger, but we also want to add two other types of hamburgers that are popular ones in Bill's store. We'll be talking about those in the next section. So the basic hamburger should have the following items. Should have the bread roll type, the meat, that's meant to say meat there, and up to 4 additions. So these are additional things like lettuce, tomato and carrot that the customer can select to a particular burger. So each of these items that do get selected and added are actually charged an additional price. So you need to find some way to track how many of these items got added and to calculate the price both for the base hamburger and all those additions. So the burger itself has got a base price, like the base hamburger, but then all the additions that are added are actually each have their own additional price over and above that. So what you want to do is create a hamburger class to deal with all of the above, and the constructor should only include the roll type, the type of roll that's used with the hamburger, the meat and the price. So you'll be needing to create methods to do these other things, like add these additional items. Now, in addition to that, there's also some extra functionality. Okay, so the other functionality that we actually need in this application, we also need to create 2 extra varieties of hamburgers, which are essentially classes. And they're going to cater for, firstly, the first one, A, is the healthy burger. So this is a burger that is actually sold only on a brown rye bread roll. And plus, because it's a healthy burger, there's 2 additional items that can be added to that. So in other words, the healthy burger can have a total of 6 items or additions in total for that class. And that's 4 from the base class and then 2 that can be added to the healthy burger. So you probably want to process the 2 additional items in this new healthy burger class and not the base class, since the 2 additions are only appropriate for the healthy burger. So it wouldn't make sense for you to allow 6 items in the base class, because those types of burgers aren't allowed to have those 6 items. And the second type of burger is the deluxe hamburger. Now that comes with chips and drinks as additions, but no extra additions are allowed. So you need to find a way to automatically add these 2 new additions at the time the deluxe burger object is created, but then also to prevent the other additions being made, because they're sold as a package and that package cannot be modified. Now, all 3 classes should have a method that can be called anytime to show the base price of the hamburger, plus all the additions, and each showing the addition name and the addition price, because you should be tracking both of those, and also having a grand total for the burger. Now, for the 2 additional classes, this may require you to be looking at the base class for pricing and then adding some pricing or adding totals onto that as well. So that's the challenge. I hope that makes sense. And it's a little bit bigger than the ones that we've done before in that there's not necessarily a lot of code, but there's some design decisions in here that you need to think about. So you probably want to spend a bit of time, writing it on a piece of paper, or certainly thinking about it, how this is going to, play out. What should be in that base hamburger class, what fields should be in there, but also what methods. But likewise for the two additional types, the healthy burger and the deluxe hamburger, what methods and fields should be in those as well. Now, just before you start the challenge, I just want to make it clear that it's very important that you've actually gone through the object-oriented programming section of this course and haven't skipped any videos. Because if you don't understand the concepts of object-oriented programming, you will struggle with this challenge. The other thing to keep in mind is there's lots of different ways of solving this challenge. And in fact, students who have been through this course and been through this challenge have actually posted their code. So after you've actually attempted your challenge, it can be good to see what other students have done with this section. But again, bottom line, it's very important that you actually understand the object-oriented programming section and those fundamentals to be able to attempt this challenge. So just as an example, one student used the constructor with 4 or 5 parameters, another one used setters instead. So I've purposely, when designing this challenge, to not tell you every parameter name, method name, etc., because that would ultimately make it too easy for you. Bottom line is, this is a challenge. It's meant to tax you and to really make you think, and even partially completing this challenge will definitely make you a better programmer because you've gone through the process of designing the solution. So go away and see what you can do to figure this out and create your application. And when you're ready to go, come back here and you can actually have a look and come up and see what my solution was. So pause the video now, go away and do that, and I'll see you when you get back. Okay, how did you get on? Did you figure out a solution? So let's go through now and create what my version of this code is, bearing in mind that with programming there's always a number of different ways that you can actually come up with a solution, but this is the solution I'm going to come up with. So the first thing we need to do is we need to create this basic hamburger class, which is dealing with this base information, the base additions and the base price and so forth. So I'm going to create a new class and call it hamburger. Okay, so that's our base class. So we're going to create a number of fields. We're going to start off with the name. We need to create the name, name that's going to be the name of the hamburger, the meat, the type of meat that we're adding to the hamburger. We're going to add a price, and then we're also going to add the roll type because we need to track that as well, the type of bread that's going to be used or the type of roll that's going to be used. So let's add those fields. So private string name, private string meat, private double. We'll use a double for the price. And we're also going to track that the actual type of bread as well. We'll call that bread roll type, like so. And we've also got some additional fields we need to add, but we'll create our constructor first. So our constructor is going to be comprised of 4 fields. Now I think I might have mentioned in our main, constructor should only include the roll type, meat, and price. I didn't actually mention name in there, so if you haven't done that with your challenge, you might want to go back and add the name as well. So we want to also track the name. So that's our basic constructor. Now, the other fields that we actually want, we want to track those additions, because if you remember back here, we talked about having up to 4 additional items, things like lettuce, tomato, and carrot, and so on. So what we need to do is track those. We need to record the actual name and also record the price. So to do that, we're going to actually just create some more fields. So we're just going to call them private. Let's just keep it simple. First one will be addition. We'll call it addition 1 name, then private double addition 1 amount, or price would be better. So that's going to be the additional item that can be put on a hamburger. Number 1, 2, 3, and 4. And I'll just make those unique. Number 2, number 3, and number 4, like so. Next, what we need to do is we need to have a mechanism to add those additions. So we need to create a method for each of the 4 additions, and therefore to enable the calling process to send the name and the price and for us to record that. So that's quite straightforward. We need to create a method, and we'll call it public void add. We'll say add hamburger addition 1. So that's going to send 2 parameters, which will be the name, the edition name, and then also the price, how much we're charging for that additional item. Then all we need to do is put this dot edition 1 name equals name. This dot edition 1 price equals price, like so. And that's literally all we need to do. We're just recording it. We're not doing any validation. You could perhaps in an ideal world actually look at doing that, but we won't do that now. Okay, next we're going to copy and paste the additional methods. And we'll just make them unique for number 2. Make sure that we're actually updating our number 2 methods, number 2 fields I should say. 3, and then 4. So we're now got a mechanism now to add our 4 additions. So it's pretty straightforward, as you can see there. Now, really the only other thing we need to do at this point is we need to create a method that enables us to actually go through and actually add up the price of the hamburger. So what it should do is it should actually record or start with the base price, then go through and check whether we've actually received an additional item for each one of these 1, 2, 3, and 4, and if so, to add the price for that to the total. So what I'm going to do is create a method called itemize hamburger. We'll call it public. Now we're going to actually return double, and the double is going to be the total price of the hamburger, including all the additional items, if any. So we're going to call it itemize hamburger. Now what we need to do is, in order to do that, we're going to create a local variable called hamburger price. We're going to set that initially to this dot price. So that's the basic price for the hamburger that was passed to us in the constructor. So now what we need to do is we need to go through each of the 4 additions and determine whether there was an addition that was passed, and if so, to add that to the price. But what we'll also do is we'll just put a line of output here just to confirm what we're doing. So we're going to put the name. So this dot name of the hamburger plus on a, so there's type of bun, plus this dot bread roll type, and we'll just put the word roll after that, and we'll put plus price is plus this dot price, the price of the hamburger. So what that's showing at the moment is the basic, just really outputting the basic price for the hamburger. Okay, so next what we need to do is go through each of the components as I've mentioned and check to see whether they've been added, have been passed I should say, and if so, to actually add that to the price. So the way we can do that, we can put if this dot addition 1 name, if that's not equal to null, if it's not equal to null, what that means is that we have had something sent to us. So if that's the case, we're going to increment the hamburger price plus equals, and that will be this dot addition 1 price. So we're adding the price of that, the first additional item, because we've determined that there is one. Then what we're also going to do is we're going to actually output that as well. We're going to put added plus this dot addition 1 name plus for an extra this dot addition 1 price. So we're just going to output it to say that we've added the additional item and how much extra it was, and the previous line we've already tallied that up and we've actually added that to the overall price for the hamburger. So we now need to do that for the other 3 items, like so, and then we'll just change those, making sure that we're selecting the right items here. Additional 3. Scroll down a little bit so we can see what we're doing. And then the last one will be addition 4. Like so. So we've now gone through and tested number 1, number 2, number 3, and number 4. So we've started on the base price, or with the base price for the hamburger, and we've actually added each of those additional items, putting some output to the screen to tell us what we've actually added, and we've added that to the overall price. So of course the last thing we really need to do now is just to return that price. We can do that with return hamburger price. So that's it. That's now our base hamburger class. Let's just write some code just to quickly check that it's doing what it should be doing. So we can go back to our main method. All right, I'm just going to make a bit of space here to get rid of all those comments which we don't need anymore. So a basic bit of code to test. We'll start with hamburger. Hamburger equals new hamburger. And let's start with, we'll just call it our basic. That's going to be the name we're assigning the meat. Let's call it sausage. The price, let's start on say $3.56, and the bread roll type, we'll just call it white, a white roll. So that's our base constructor. And what we can also then do, well actually what we'll do first, let's just output that. So what we're going to do is we're going to return the price. So double price equals hamburger dot itemize hamburger. That will return the price firstly, but also it will actually show us those outputs. So let's run that and actually just check that it is working. So we'll run it. And I'll just make a bit of space so we can see what we're doing. You can see basic hamburger on a white roll price is $3.56. So you can see basic on a white roll price is $3.56. So that's good. We didn't actually output the message for the type of meat, but we can do that shortly. And just to confirm that it is working, let's add a few items. So put hamburger dot add hamburger additional item 1, and we'll say that's tomato. And let's just say that was 27 cents, so 0.27. And we'll add another one, hamburger.add additional item 2, lettuce, 75 cents more. And then hamburger.add one more, let's say some cheese, $1.12. So we've added those 3 items. So let's go back here and calculate that again. This time I actually won't try and recreate the variable because we've already created it above. We run it. So we've now got it's outputting it twice, but the first time you can see it's putting the basic hamburger on a white roll, price is $3.56. Added tomato for an extra 27, which you can see there. Added lettuce for 75. Added cheese for an extra 12. And what we should probably do here is then put, let's change this to total burger price is, and we'll get rid of the variable there because we can actually just use that method there to call the method, and actually which it returns the result of the price anyway. So let's try running that. And we should be right. So just to make sure that that's working, let's just change that to $1.13. So it's actually got the right decimal points. Later in this course, I'll show you how you can actually format these numbers so they come out correctly. So we've got $3.56 plus 27 plus 75 plus $1.13, $5.71 altogether. And just the other thing I said I would do, let's also change this. We'll put with this dot meat comma price is that, just so we're actually also recording or showing on the screen the type of meat to make sure that's working. You can see that's now working on the screen there with sausage prices $3.56 and added the tomato, etc. So we've got the basic component working now. We've got our basic hamburger working. I'm going to stop the video now because it's getting a bit long. In the next video, we'll come back and we'll actually look at the healthy burger and the deluxe burger and add those to our application. So I'll see you in that next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a star freelancer.
In the previous video, we started our object-oriented programming master test and we got the basic hamburger class up and going. So let's now finish this off and create the healthy burger class as well as the deluxe burger class. So firstly, let's create the healthy burger. I'm going to create a new class. I'm going to call that healthy burger. Now what we need to do is we need to extend from our basic burger class, which is hamburger, so we need some of that functionality. And if you recall, we need to add 2 additional extras. We've got the ability with the healthy burger to add 2 additions to that burger. Just to go back and confirm that. Our healthy burger, this part here, healthy burger on a brown rye, I should say, bread roll plus 2 additional items can be added. Healthy burger can have a total of 6 items, and there was a hint that I gave you to say you probably want to process the 2 additional items in this new healthy burger class, not in the base class, since the 2 additional items are really only available in this healthy burger. So let's do that. So consequently, we need to add 2 fields, I should say, to this class, and they're going to be private string, and we'll call them healthy extra, and we'll call it healthy extra 1 name. and private double healthy extra 1 price. And we'll do the same for those two for the second edition for the burger. And incidentally, the error on the screen is because we haven't implemented a constructor yet, no default constructor, and that's because the only constructor we created in the hamburger class actually had parameters, which you can see there. We didn't have an empty one. So consequently, we need a way to actually call that method. Now we're going to do things a little bit different here. Whoops, I typed that, made a typo there. Whoops, healthy. And what we're going to do is we actually, with the constructor, we know the type of burger that we're actually working on. We've got a healthy burger. We know the name of it, and we know the type of bread. So consequently, when we're creating constructor, the only two parameters we want in the constructor is the meat and the price, because we're actually going to hard code the values for the name and the type of brown bread, or in this case, the type of roll, because that's what's in this healthy burger. That's what we're selling. So creating the constructor. Now, I'm not actually going to choose any of these extras because none of these extras are actually going into the constructor. But if I click on OK, I actually get the parameters that are built into the base class automatically because they're needed to make this healthy burger class valid. But what I'm going to do, as I mentioned, I'm going to delete some of these. Well, firstly, the healthy one, I should have selected none there. I obviously selected the healthy extra one name by mistake, so I'm going to leave that out. Delete that. And really, the only parameters I actually want, as I mentioned, are the meat and the price, because the other two we're going to add manually. So I'm going to delete those, like so. And our super call is we still need to actually pass those two parameters, but I'm going to actually change that and put the name. We're going to call it our healthy. And the bread roll type, we mentioned before, that was going to be brown rye. So we're going to say brown rye. So that's us creating a valid healthy burger class now based on those parameters because we know the type of burger that we're creating. And for the two additions, we need to do very similar to what we did for the other ones. So we want to put public. We'll put add health addition 1. And that's going to have the name and the double for the price. And it'll be this dot healthy 1 extra name equals name. This dot healthy 1 extra price equals price. And do the same for the second healthy additional item. Like so. Okay, I'll make a bit of space here. So that's our basic setup for the healthy burger. The other thing we want to do now is we need to have a look at that itemized hamburger method. So if we go back to our hamburger class, we had this itemized hamburger method. And that, of course, actually summed up the total for the hamburger. But if you think about it now, we've got two additional items that we can optionally add. So right now, if we run this hamburger, this healthy burger, it'll actually work. So if we change this and we'll put healthy burger and we'll call it healthy burger equals new healthy burger. And remembering that we've only got two items to add here. That's the meat. And we'll say this one's got bacon, and let's just say the price is $5.67. So if we do our healthy burger dot itemize hamburger, if we run this, we can see we've got a healthy hamburger on a brown rye roll with bacon. Price is $5.67. So it's accepted our parameters, obviously the name, then the type of bread roll in our constructor. That's all working fine. And we will be able to add an item to that quite nicely as well. Healthy burger.add additional item 1. And let's just say that was egg. And we're a greedy restaurant, so we'll say it's $5.43. And actually what I'll do is I'll remove that out of there and just paste it into there like so. So that if we run that, we should see that that is still working. And the reason that it's working is our base functionality built into the application is built into the base class, I should say, the hamburger class is working. So those methods that we created in the base hamburger class are still there and works quite nicely. But the issue, of course, now is we haven't got a mechanism to tally up the price. We can actually add an item to the hamburger, to the healthy hamburger. So healthyburger.add additional price, and let's just say it's lentils, why you'd want lentils with a hamburger, but anyway, $3.41 for argument's sake, just add the 1. But there's no mechanism at the moment to add that to the cost, the total price for the hamburger. And the reason is we haven't got an itemized hamburger method for this class yet. So let's go back to the healthy burger class and actually add an itemized hamburger method so that we can actually tally up the price for these additional health items as well. So to do that, what we want to do is we want to override that class, override that method. So we're going to click on override or select override. We're going to go to hamburger and go to the itemized hamburger method, and we're going to override that. Click OK. So by default, that's come back with the super.itemized hamburger and returning that as the price. We want to change that because what we want to do is we want to actually put a double. We'll put hamburger price again. Price equals. So what this is doing now is actually calling the itemized hamburger method that's in our hamburger class. It's calling that, and that's coming back with the price, the itemized price for the basic hamburger and the 4 additions. So that's what we've got to start with. Then now what we need to do is we need to figure out how to add the extra items to that price, which turns out that's quite simple. We can actually just do the similar test that we did in the hamburger class. This dot healthy extra name is not equal to null. Then we do a hamburger price plus equals this dot healthy extra 1 price, and then I think we put added extra 1 name plus for an extra this dot healthy extra price 1, like so, and I'll just cancel that so we've got a bit more space. We can see what we're doing here. So that was number 1. We've added that, and then of course we'll do the same for the second healthy additional option. So if extra 2 is not equal to null, which means there is one that has been one passed to us, we'll actually output the second name, the second price. And then at this point we can do a return hamburger price, which should be the price including the healthy extras. So now if we go back, and what we'll do is we'll actually change this. We'll actually put the itemized hamburger at the end there. So you don't need to display it twice. So we're now actually adding a normal item, an additional normal item. Then we're also adding a healthy addition as well. We're itemizing, and then let's actually just put an output here just to make sure that the price seems to be working. Total healthy burger price is plus healthy burger price, and fix the brackets up. So now if we run that, we can see now we've got healthier hamburger on right, price is $5.67, added an egg for an extra $5.43, added lentils for an extra $3.41, which you can see is now working, and the price is $14.51. And if we just use our calculator to make sure that's working, 567 plus 543 plus 341 equals 14.51. So our pricing is working great. So you can see now that we've actually got our healthy burger working nicely and calling the appropriate functions. Okay, so what we now need to do is implement the deluxe burger. And if you recall the deluxe burger, we'll go back and just have a look at our notes for that again. For the deluxe burger, comes with chips and drinks as additions, but no extra additions are allowed. So you need to find a way to automatically add these 2 new additions at the time the deluxe burger is created, or the object is created, and then to prevent other additions being made. So let's go ahead and do that. What we're going to do is create another class and call that deluxe burger. And we're going to extend from hamburger. Like so. Now we don't actually need any new fields for this because we're not processing any new additions for this like we did for the healthy burger. But what we want to do is create a default constructor with no parameters. We're going to put everything in the one constructor. So we're going to create that. And again, by default, it adds those, but we're going to remove those. And instead, what we're going to do is we're going to do these manually. So we're going to call it the deluxe. For the meat, let's say it's got sausage and bacon, because it is a deluxe. Price, let's just say it's $14.54, and we'll say white for the bread roll type. So that's now created our deluxe burger. And we also mentioned that we needed to add 2 additions, which were the chips and the drink. Now, we don't want to enable those methods later, but what we can do is we can put those in the constructor. And we can do that by putting super.add hamburger edition 1 chips. Let's just say they were $2.75. And super.add additional add hamburger edition 2. And we'll put drink, whatever the drink was, $1.81. So that's our way of creating the deluxe burger with the additions at the time the object is created. Now the other thing we want to do, because by default, if we actually go to run this, we should find that it'll work. And we'll call this the deluxe burger, db equals new deluxe burger. No parameters are needed. And if we then do a db.itemize hamburger, if we run that, we should find that works. The deluxe hamburger on a white roll with sausage and bacon, price is $14.54. Added chips for an extra $2.75. Added drink for an extra $1.81. And notice how they were added in the constructor. But the problem we've got now is, again, going back to the code up above, we needed a way to make sure that, actually I'll delete that so I've got a bit more space, but no extra additions are allowed. So in other words, we can't add anything else other than what's already in there. But at the moment, if we go back here and have a look, we can actually add those. We can put db.add additional item 1 should not do this. So we can actually do that. And of course that violates the rule that we've set for ourselves. Actually what I should have done is made that additional item 3, but then it should also have displayed that in the right place like that. So if you run that, we've got this line here. We shouldn't have been able to do that. So the question is, how do we prevent those methods from being called just for the deluxe burger method? Well, it turns out that's actually quite easy. We can actually override. So what we can do is we can go back here to our deluxe burger class and we can put override, and we can go back to our hamburger class and I can select the add additional item 1, 2, 3, and 4, and I can actually prevent those from being called by overriding those methods. So I can click on OK, and that's added those. And what we're going to do is just change the code. We're not going to call the super. We're actually just going to put a message there. The message is going to be cannot add additional items to a deluxe burger. Like so. So we've now added that one for each of the 4 addition methods that were in the base hamburger class. We've overridden those functions, those methods, just in the deluxe burger class. So consequently now if I go back to our main and run this again, so you can see what's happened there. We've still been able to create the class and to add the chips and the drinks initially. And the reason that that works is if you look back at our deluxe burger code, we're calling the super.add hamburger additional item method. So that's why that's working. So we're actually calling the methods that are in the hamburger class, in the base hamburger class, these here. And it's quite happily adding those because we're calling that from the calling super dot and whatever the name of the method is. But in this case, what we're saying is we're actually overriding the add hamburger edition 1 method for the deluxe burger class, but we're actually not enabling that code to be called. So consequently, when we try to do this, this should not do this. It's calling this code here from our deluxe burger, the add additional item 1, cannot add additional items to a deluxe burger, and that's what's coming up on the screen here. So that's how you go about overriding it and preventing functionality from being processed, as you can see in that example. So that's our application. That's our base hamburger application. I hope you've got a lot out of this, out of these 2 videos, and actually for these last 2 sections of the object-oriented course. All right, so now that you've seen that solution, I just want to make a point that it's certainly not 100% perfect, but I think it's a good solution by using the knowledge that we've learnt in previous sections. Now, in an ideal world, you'd use something like a list or an array, but lists and arrays are explained later in the course. So this was designed for you to take this challenge based on the information already shown in the course. So what you can do though is revisit this challenge later once you've learnt these other things, lists and arrays, armed with that new knowledge, and look at improving your solution. Now, you may also notice that there's some repeated code, but that's actually okay for now. Later you're going to learn more on how to remove repeated code. Also, very importantly, keep in mind that you don't have to match the code 100% as your solution. It's great if it works the same as mine, but your code can and probably will be different and perhaps vastly different than the solution I've shown there. And that's because in programming there's almost always many solutions to a particular challenge. And in this case that's certainly true, and I think that's what makes this a good challenge. And lastly, again, many students have shared their solutions in the Q&A section of the course, so it's a good idea to check the Q&A and see their solutions once you've attempted it yourself. And I hope you did well with your challenge as well. In the next section of the course, we're going to be talking about arrays, which I'm sure you're going to find very useful. So I'll see you in that next section. So far in this course, we've only dealt with data structures that hold a single value. In other words, the standard variable. An integer variable holds only one number, for example, an integer a whole number, and a string, as you've seen, holds only one long sort of sequence of text. But in this video, what we're going to be talking about is a way to store multiple values of the same type. And what we're talking about is using arrays. So an array allows you to do just that. It's really a data structure that enables you to store a sequence of values that are all of the same type. So for example, you could create an array of integers, an array of characters, an array of strings, etc. This actually works for all primitive types and even objects like the string. So declaring an array initially is similar to declaring a regular variable. Let's just have a look at how to do that. So as you no doubt recall by now, you can define a regular integer variable like so. So in this case, we're defining a variable called myVariable of type int and assigning the value 50 to it. Now to go and create an array, or to define an array, just after the type, the primitive type or the object, or the class in other words, we put square brackets like that. And that actually tells the Java compiler that we're not dealing with a regular variable, we're dealing with an array. So number one, we do that. And by doing that, we've actually now invalidated this line of code because we're trying to store a regular value into an array, and that's illegal now in Java syntax. So I'm going to delete that. Now that's the standard definition. And what we can then do is we can put on the next line, if we wanted to, we can put my variable equals new. Then we repeat the type again. So we put int. Then in square brackets, we type in the number of elements we want to assign to this array. So for example, if we wanted to add space for 10 elements, 10 individual integers in this array, we'd use the number 10 there like so. So that's actually assigned 10 elements. And of course, the other thing we can do, much like a regular variable, we can actually combine this all onto one line like so. So in this case, we've defined an array called myVariable. We've told it that it's of type integer, and we've assigned 10 elements to it. So to be more precise, let's put my int array. We'll call it my int array so it actually makes more sense, because that's what it actually is, an array of integers. Now this number here again is the number of elements. So that's the number of slots, or the number in this case of separate integers we want to assign to this array. So accessing those array elements, how do we access them? Well, we do something like this. We can actually, for example, to save a value, we can put something like my int value square bracket then a number, so 5 equals 50. So that's actually saving the value 50 into element. Now you'd look at that and you think, maybe, well, that's obviously saving that into element 5, but it's actually saving it into element 6. And the reason for that is with all arrays in Java, they always start the count at position 0, at number 0. So in other words, if you want to access the very first element of an array, you start from position 0. So in this case, new int 10. So the first element, you'd use number 0, and right up until the last element, you'd actually use number 9 to allocate that. So in other words, instead of starting from 1 and finishing on 10, you start from 0 and finish on 9. It sounds confusing, but you'll soon get used to that. If you just remember that you always start counting from 0 in Java with arrays, it will make a lot of sense. So in this case, what we've done, looking at this code line, my int array, the number 5 in square brackets, and it's 0, 1, 2, 3, 4, 5. So that's actually element 6 equals 50. So that's how we're actually assigning that value. In terms of arrays, again, it's very similar. We syntax for other data types. We could change this to a double, for example, if we wanted to. And come back here and change this also to a double. And change the variable name. And that would actually assign an array called my double array with 10 elements, and each of those elements could be stored, could have stored in them a double. So that's how we go about defining the array, and how we go about defining or storing a value in the array elements. The other thing you might want to do is actually retrieve a value from a particular element, and to do that, we can actually do something very similar. We can just put, and I'll just output this just to show you, my int array, and we'll put 5 there, and that's going to now dump out or print to the screen element 6. If you run that, And we're starting the count from 0 in case you're wondering why that's 6. We're getting the value 50, which we actually stored in this line here. So that's how we go about actually retrieving the values as well. So just remember, if you define, whatever you define the variable to be, that's the type of data that will fit in that array. So you can't, for example, put a double into an integer array in much the same way you can't assign a double value, a variable, into an integer variable. It won't work either. So that was one way to initialize. You could go through, if you wanted to, in this case, if we wanted to initialize every value in the array, we could go right through and we could sort of start from, my int array 0 equals, 45, my int array 1 equals 476, etc. That could become quite tedious. So there isn't actually another shortcut that Java gives us. If we know ahead of time the values we want to actually save in an array, we can do something like this. I can put my int array equals, we can put 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But the reason we're getting an error there is we need to actually copy this into this at this place here, because this is only applicable the first time we define the variable. So if I do something like that and then delete this out. So what we've actually done here is we've actually told Java, these are the numbers we want you to assign into the array, but we've also indirectly told Java how many elements are in that array by the actual number of values that are in this curly brace initializer block here, separated by commas. So the fact is there's actually 10 elements in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Java looks at that and automatically assigns 10 elements to this integer array, and then it also goes through and actually adds the values for each of those into each array element. And just to confirm that, we can actually print a couple of these out. Get rid of this double now because we're not using that. And we'll just do a couple, say position 6 and position 8, if we run that. And you can see we've got element 0 is the value number 1. Position 6 or element 6 is 1, 2, 3, 4, 5, 6, as you can see there, starting from 0. So it's actually element 0. So that's 0, 1, 2, 3, 4, 5, 6. That's why we've got 7. And again, the element 8 is actually the 9th element, which would be this one here, which is the number 9. And that's why the numbers 1, 7, and 9 match up like you can see there on the screen. And finally, there's also a third way to initialize. So if we go back now and actually just comment that out for now. I'm just going to set that up and comment that out like so. So what I'll do is I'll just create a new integer array. So what equals new int 10 again. So back to our 10 elements. So at the moment they haven't got any values, and I'll delete these output lines now because they're no longer appropriate. We can actually use a for loop to initialize them. So we can put something like this. We can put for int I equals 0, I less than 10, I plus plus. Then we can actually put my int value I equals, and let's just say the form is going to be I times 10. So what we're doing there is we're actually going through each element of the array, starting from element 0 with our for loop. And you can see my int array I in brackets means access element, in this case 0 will be the first time it's called through in the loop. We're assigning I times 10 to it. We're going right through to the entire, or for the entire array, and going through saving the values. And just to confirm that, we could do a second loop for int I equals 0, I less than 10, I plus plus. We can do some output. We'll put element 0, or element plus I should say, plus value is my int value, and my int array I should say I. So we run that now, we should actually get some output. Element 0, and you can see the first time we've gone through the value is 0, 10, 20, 30, 40, and so on. And again, the calculation for that is it's whatever the index entry for the for loop that we're going through, multiplying that by 10. So the first time we go through this, we're accessing element 0 because I is 0. 0 times 10, of course, is going to be 0, and I is set to 0, so that's our element 0. Next time we go through, I is going to be set to 1, so we're updating element 1 in our array. So in other words, my int array 1 equals 1 times 10, which is 10, and so on, as you can see, right through up until 9 when the value is 90. So that's a great way to initialize it if you've got some sort of formula that you know ahead of time that you can actually use to assign to the particular element in the array. One of the other good things I recommend you do though is rather than hard coding numbers here, it can be a good idea to use a method that actually is given to you automatically with arrays, and it's called the length. So we do the array name myIntValue.length. I think I said it was a method, but it's actually a property. So it's actually a field that's stored in that comes as part and parcel of the array. And length gives us the length automatically. So Java will actually look into the array and decide or tell you what the length of that is. So the good thing about that is if we change that there, and we also go back in here, and we put myInt.length as well, and we run that, we should get exactly the same result. As you can see, exactly the same as it was before. But the good thing also is we can change this. So we can make this say 25 and run it. And you can see we've now got the values cycled through from 0 to 24. And that's because we've used the lengths field, the value that comes back from the array automatically from Java. Java has determined, okay, you've changed the length to 25 elements, and it's automatically set it up so we didn't need to change the code for that to work. So it's a good idea to use .length with arrays whenever you want to actually cycle through or figure out what the length is, rather than hard coding a value, because you can see there in this example it makes your code, I would argue that it's easy to read, but certainly also there's less work for you to maintain, because literally if otherwise you'd actually have to change 25. In this case, when we changed from 10 to 25 elements, we would have had to change that code as well, which doesn't seem much now, but as you start producing more and more Java code, you'd find that you'd be needing to make these changes in a lot more places, and you'll just be opening yourself up to causing errors. Because one of the things you will actually get, you'll actually get a problem if you try and access an element that's not there. So if we change this and we put 30, we'll actually get an error. So if we run this, so you can see what's happened is we've actually got an exception, and the exception is array index out of bounds. And the reason that it's out of bounds is we've actually used a number that's actually too high. So we've actually only got 25 elements, and we've tried to access an element greater than 25. You'll get an error if you do that. You can only access as many elements as you've created. So if we just undo that change and go back to here and do it, you'll probably see it a little bit better, because it should actually still output the first 25 elements before it crashes in this case. So again, the problem here is the number of elements that we're actually defining is invalid. So we're going to go back and change that. So it's just easier, as you can see, to make sure that obviously we actually use the right number, but we want to actually assign the actual number in as few places as possible, because that then prevents any weird errors coming up. As you can see, came up before when we started trying to override what we knew were the correct values. So that's how to go about, in this case, printing out the number. Now, the other thing you can use, of course, is with any value, with any variable in Java, including arrays, is we can pass those to methods. So what we can do is we're going to take this bit of code here, we're going to create a method from it, and then we're going to call that method. So we're going to create a new one called public static void print array. We're actually going to send it our array, and to define that as a parameter, as an argument, we put int, same definition before the square brackets, and we'll call it array. So, and then if we paste in our code, then what we need to do is we need to just change the definition to match the parameter, like so. And then now we should just be able to call our method print array and pass our array that we've defined called myPrintArray. So it's doing a very similar thing, but we're just passing the array. Notice on the definition that is actually the code that's calling the method, we don't put square brackets in there. If we do that, we'll get weird things happening. We'll get an error. We only define the type in the parameter, as you can see there. So if we run that, we should get identical results printing out, as you can see we're getting. So that's how to go about actually showing it or printing it out and passing an array as a method. Okay, so what I'm going to do is delete this on the screen now. I'm going to show you another use. So what we're going to do is just delete all that out. I'm going to actually show you a real life use of using an array where it would become valuable. And what we're going to do is we're going to accept some input from the console. So in other words, allow the user of the program to type in some numbers. We're going to sum up those total numbers and then figure out what the average is of those numbers that were actually typed in. So this could be a good use of an array. This again, we're dealing with multiple numbers, and that's where arrays are really great. So firstly, let's define something called a scanner, and we'll talk about that shortly what it is, but private static scanner. Case is important here. You can see java.util is coming up automatically. Anytime you see something that starts with java dot, in this case .util, that's something that comes with Java. And we're going to call that scan, and let's call it scanner. You can see it's asking to accept the import, so I'm going to do that. And we'll call it scanner, and it equals new scanner. and we pass a parameter called system.in. Now you've seen system.out before when we've actually dumped code. We do that all the time. You can actually see that to the right of the screen now. We use system out for that. System.in is the opposite in that it allows you to type input into the console that gets returned back to the program. So that's what we're doing there is we're defining this static variable, or field I should say, called scanner, and we're going to be using that in the code to actually retrieve that. So what we're going to do is we're going to start off, we're going to put int, an array int, we're going to call it myIntegers equals getIntegers 5. So what that means is we're going to actually create a method, and that method is going to automatically allow us to type in 5 numbers and to then return those 5 numbers in the form of an array, and those contents will be stored in our myIntegers array. So to do that, public static int as an array, int, 2 square brackets means we're returning an array, getIntegers, and int will be numbers, or number I should say, and the number in this case is the number of array elements that we want to define for our array. So we're going to print out a message first, and the message is going to just put enter plus number integer values. We're going to put a \r there so it goes to the next line, and you'll see why shortly when we're running it. Next we need to define our array. We're going to call it values equals new int number. So we're passing, or we're using the number that was passed to us, in this case number, and that's how many elements we're assigning to this array. By doing it this way, we've got some flexibility in that this will be able to accept any number. We can chop and change that as needed. Then we just need to create a for loop for int I equals 0, I less than values.length, I plus plus. Then we assign the value now. We put values, which you've seen before, values I, so starting on position element 0, we're going to go through the entire array, equals, and it's going to be scanner dot next int. Now the scanner dot next int automatically accepts an integer from the console, and that then returns an integer, and that's going to be stored in our array. And finally, we're just going to return the array back to the calling process. So in this case, what we're doing is we're defining an array called myIntegers, and the actual value of the array is being passed back from this method to automatically, and it's going to be assigned to myIntegers. So at the end of this, after it's made this call, not only have we defined the length of the array, but we've also got the contents of it as well. So just to confirm that, then we're going to put a for loop there for int I equals 0, I less than myIntegers.length, I plus plus. And we're just going to print that message out to see what the typed value was. Let's just run this and see that it works. Firstly, it's asking us to enter 5 values. You notice when I click my mouse in there, it automatically went to the next line. If I didn't put the /r here, it would be actually asking for input as the first one there, which we didn't want. We actually wanted it on this line. That's the reason I put that /r there. So let's enter 5 values. So 10, 26, 52, 66, and the last one, 23. And you can see element 0, type value was 10, 26, 52, 66, 23. So you can see that this has returned that array, and we've got the correct values in there. So we're nearly done. So we've actually got the values. Next thing we need to do is actually create another method. In this method, we're going to pass the array again, and we're going to get it to return what the actual average of the numbers are. So again, the average is calculated by determining the sum of all the values in the array and dividing that by the actual length. So let's do that. We're going to do public static double. We'll call this one get average, and then we need to pass our array. That's going to be we'll call this one array, and we're returning a double because with an average we may actually get a number that's not a whole number as the result. So we want to make sure that the number that we return can cope with whole numbers, or in the case of an average being not a whole number, show that correct value as well. And we'll see that in operation shortly. So we need to define a local variable that is the sum total. I'm going to call that sum and set that to 0. I'm going to create a for loop again for int I equals 0, I less than array.length, I plus plus. We're going to go through the entire array. Then we need to assign whatever the current value is of the current array element as we cycle through using the for loop. We need to add that to sum. So we're going to put plus equals array and the I element. The plus equals, we didn't put a plus equals. course, we wouldn't be recording the other values. It'd be overriding it each time. Plus equals means that we're actually adding to it. So that's good. So we've now got the total sum is now stored in the variable called sum. So now to figure out to return the average is simply dividing sum by the length. But then we want to convert the result to a double. So we're going to put return double sum divided by double array dot length. Again, using doubles to make sure that we're actually returning a double, and it's just dividing the total sum of all the values in the array by the actual length. So the last thing we should need to do is actually just update our main method and print out a message. So we can put something like the average is get average and pass our array. So if we run that, and we'll store our three values, and we'll put something like 3, 4, 5, 6, 7. And put the average is, we should have put a space there. Let's run that again. 3, 4, 5, 6, 7. The average is 5.0. So 7 plus 6 is 13, plus 5 is 18, plus 4 is 22, plus 3 is 25. So that's 25 is our sum there. And 5 elements, 25 divided by 5 is 5. And notice also that IntelliJ is showing you these numbers in green, which is its way of saying that these numbers were actually typed in from the console, which is pretty handy. So that's our function, getAverage, which actually returns an average of the total number of elements. And just one last example, just to show the definition of why we needed a double. So we're into one more number. Let's just use a number that we know is not going to evenly divide. So we'll say 100 plus 50, 15, so 5 and a 2. And that would give us 34.4 because that's 150, 165, 172. 172 divided by 5 is 34.4. So that's why we needed to use the double there. So this video has gone way longer than I had hoped it would go for. So I hope you got a lot out of that. In the next video, what we're going to do is we'll do our challenge for arrays, and we'll talk about that and see you in the next video. Okay, it's challenge time for arrays. So this is the challenge video for arrays. I'm going to type out what the challenge is now. Okay, so the challenge is to create a program using arrays, and it should sort a list of integers in descending order. Now, descending order is highest value to lowest. So in other words, if the array was 5 elements in length and it had the values in it of 106, 26, 81, 5 and 15, then your program should ultimately have the array sorted so that element position 0 would be 106, position 1 would be 81, position 2 would be 26, 3, 15, and position 4, number 5. So in other words, highest to lowest. Now in terms of the numbers that you're going to be sorting, set up the program so that these numbers are read in from the keyboard. I showed you in the last video how to do that. So the methods you actually want to implement are getIntegers, printArray, and sortIntegers. GetIntegers is going to return the array of the entered integers from the keyboard that has been typed in. printArray would print out the contents of the array, and the sortIntegers method should sort the array and return a new array containing the sorted numbers. So what you'll have to do, apart from figuring out how to actually sort the array, you'll have to figure out how to copy the array elements from the past array and create a new array that you can actually work on and sort, and then you're going to return that new sorted array. So it's time now to pause the video, go away and actually try out this challenge. When you're stuck or when you've finished and you're ready to check my version of the solution, come back and I'll show you how to do it. So pause the video now and I'll see you shortly. Okay, so how did you get on? Did you figure it out? So let's go through and create our solution. So the first thing we want to do is we need to create a private field so that we can actually import some data from the console, the keyboard. So we're going to create our scanner class again, our field. System.in again. And I'm going to actually just start down here, leave that in there so we can refer back to it and make sure we haven't forgotten anything. Create our integer array. We're going to call it myIntegers equals getIntegers. And let's start with, say, 5 numbers. We can always change that later. Be 5 numbers that we're going to sort. So what we need to do is create our getIntegers method. You saw that in the last video, but we're going to create that again. So public static int, we want to return the array, get integers, and int capacity, that's going to be the size of our array. In this case, it's going to be 5. And so we'll define our array, new int capacity, and we'll type in a message, enter, put our \r there again to go to the new line. And we're going to create our for loop for I equals 0, I less than array.length, I plus plus, array I equals scanner dot next int. And lastly, we want to return our array. So that's our get integers, nothing particularly complex there because you saw that in the previous video. Well, next we'll create our print array, and that's going to be also very simple. It's going to accept an array and just print out the content. So we're going to type public static void print array, int array, and then we're going to put a for loop for int I equals 0, I less than array.length, I plus plus, and we'll put element contents array I. Pretty simple, as you can see there. Nothing particularly difficult about that at all. So that's the first two methods, and then the third one though was the new one. So this is the sort integers method. It's going to sort the array and return a new array containing the sorted numbers. But we've got to figure out a way how to copy the array elements from the past array into a new array and sort them and then return the new sorted array. So in other words, we need to copy the contents of that array into a new one. We haven't actually seen how to do that yet. So how did you get on with that? Did you have a think about how to do that? So I'm going to come up and show you my version of the code. And what we'll do is we'll put public static, and it's going to be an int because ultimately you're going to be returning that array, sort integers. But it's also going to be past the array, and the array is the unsorted numbers from the keyboard essentially that have been typed in from the keyboard. So there's a number of ways of actually doing this. So one of the first things we need to do is we're going to put int, create a variable called sorted array. So what we're going to do is we're going to set it up and put equals new int array.length. So we're creating an array that is of exactly the same size as the array that's been passed to us. So at the moment that hasn't got any values in it, so we're just going to use a for loop for int I equals 0, I less than array dot length I plus plus. And then we can just put sorted array I equals array I. And that's it. That's creating a copy of the contents that are in the array that's passed to us into our new array that we've created. So again, the first line creates the array called sorted array of type integer, and we're setting it to the same capacity as the array that's been passed to this method. Then we're using a for loop to go through and retrieve each element out of array I, and we're actually saving the contents of array at element I into our sorted array. So consequently, at the end of that for statement, we've actually got an array that contains the same values as has been passed to us. So the next thing we need to do now is, this is where the complex part comes in, this is sorting the array. So what we need to do is we actually need to create a while loop, and within that we need to create a for loop. And I'm going to tell you why as we go through. So first they're going to create our boolean called flag. We'll set that to true, and our while loop is going to continue processing until flag is actually false. Then we also need a temporary variable, which I'll talk to you about shortly as to why we need that. Let's make a bit more space here for this method. So what we now need to do again is we need to go through the sorted array. We need to figure out a way for this to be automatically updated so that we end up having the highest values at the start of the array right through element by element to the end of the array has got the smallest amount. So let's start off with our while loop. So it's going to be while flag. Now, first thing we're going to do in the while flag is we're going to set it to false. And the reason is we're going to have a for loop, and if the for loop succeeds, if the for loop hasn't sorted all the numbers, we're going to assign that back to true again so that the actual while method, or the while loop I should say, continues. So by default, we're setting it to false, which means if we don't reset flag the variable to true, we're going to automatically end the while loop. So next comes the code we need to check. We need to actually do a for loop. So for int I equals 0, I less than sorted array, because we're dealing with sorted array now, sorted array.length, I plus plus. Next, we're going to do a test. We're going to put if sorted array I is less than sorted array I plus 1. But the other thing I should have done here is put a minus 1. And I'm going to explain that shortly. We're going to type temp equals sorted array. I think it's easier if I type in the code and I'm going to go through and explain it all. So sorted array I equals sorted array I plus 1. And then sorted array I plus 1 equals temp. Equals temp. And then we're going to assign flag to true. Okay, the last thing we're going to do down here at the end of the while loop, we're going to return our sorted array. Okay, that's the code. So let's go through this while loop and then the embedded for loop. So firstly, we've got a while flag. So we're basically going to only continue this loop until a while flag is set to true. So initially, when we first created this method, or we first go into that while loop for the first time, it's set to true. So it's going to execute at least once. Then we immediately set that to false. And the reason is we've got a test in here and we're only going to try and continue the while loop if we actually assign flag to true. And what we're trying to do here is we're going to go through each element of the entire array each time we go through this pass, one pass at a time, and we're only going to exit the loop if we've actually sorted all the numbers and there's nothing left to sort. So how does this actually work? Well, how it works is firstly, with our for loop, we're starting always at element 0, and we're always going to finish our ending element is always one less than the total length of the array. And the reason is we've got this I plus 1 here. And what we're testing is we're saying if the sorted array at element 0 is less than the sorted array at the next element in number, in this case, if we started on 0, it would be element 1. What that means is the number in the next element position is actually higher than that first element. So consequently, we need to swap them. So what we then do is we actually store the current value of the sorted array into a temporary variable. It's there just to actually store that number temporarily. We then actually move effectively the element that's in this I plus 1 position into that area. So we're actually swapping them, and then we actually assign the temporary variable back. So really these three lines of code here, what we're doing is we're taking the entry that is at element position 1 for argument's sake and swapping it with element position 0. And then what we're doing, because we've made a change, what that means is we're not sure that there's not more changes to be made. So we need to use the while loop to go through and test, which ultimately will actually go through this entire for loop again, looking to see whether any numbers at a certain position have got higher numbers in one element above them, if that makes sense. And just to so this makes a little bit more sense, let's just presume we've got, say, element 0. We'll say that had the value of 50. Element 1 had the value of 160. Element 2 had the value of 40. Let's just say we had those three elements. So basically we're going through our loop, we're starting on position 0, and we're saying if sorted array I, and I is 0, so we're saying if sorted array I, which is 50, is less than sorted array I plus 1, which is 160. So in other words, what we're saying there is 50 less than 160? So in that case, that is true. So then what we do is we're actually swapping the values around. So in this case, we're putting temp equals sorted array I. Again, I is 0. Sorted array I equals sorted array I plus 1. And sorted array I plus 1 equals temp. So what we're basically doing is we're going 160, 50, like so. So we've swapped those elements around. We're setting that flag to true so that we know that's going to go through at least one more time. And then it actually goes through the rest of the elements. So in the second case, I will be set to 1. So it's going to look at 50. It's going to say, is 50... is that less than 40? Because 40 is going to be element 2, I plus 1. In that case, that's going to be false. So this code doesn't get executed, and that's because we've got them in the right order already. But because flag has already been set true the first time, it's going to go through and start again. So the next time it goes through, we're assigning flag to false again. And this time, the second time it goes through, it does this test. So it's going to start again at element 0 and say element 0 is 160. Is 160 less than 50? Well, in this case, that's not true anymore. So this code isn't going to be executed. And likewise for the next test, that's also not going to be executed. So flag is going to continue to be false. And we're going to exit out of the while loop at that point and then return the sorted array. So that's how that actually works. That's what that sort is doing. It's just going through one element at a time in the array and figuring out what needs to change. So that's basically it. That's our method, our code to actually perform this, get this to work. So what we now need to do is just update our main method above to process this. So what we're going to do is actually go up one higher. So at the moment we've only got the numbers. So we're going to print those out after we've sorted them, because we can already see, we'll be able to see on the screen what we've typed. So we're going to put int sorted equals sort integers my integers, like so. And we're going to put print array sorted. So let's run that and see what it does. So enter 5 values. So let's enter the values. We'll do the values that we had on the screen. 160. Sorry, we'll start. Whoops. We'll actually end that. I'll stop the program and we'll actually run it again. Okay, so I'm going to enter 50, which is what we had initially. 160, 40, and let's say 23, 200. And you can see what's done there. It's actually element 0 has now, the contents is now 200, 160, 50, 40, and 23. So it's actually gone through this loop there multiple times until it had nothing else to change, and it's actually sorted in the right order, highest values to lowest values. So that's what the sort array method, or sort integers method, is actually doing. So one last thing that I'm going to show you, and we're going to be talking more about this in future videos, but the method that I showed you here to create, well actually this line as well, to actually copy an array, that's one way of doing it. There's actually a number of built-in ways to do this sort of thing, to copy methods, and more as you become more familiar with Java, you'll be wanting to use some of the features that are built into Java, because it just actually saves you a lot of time, less code, and you're actually using code that has been heavily optimized, much faster, and it's just less code to debug. So an alternative method to copy an array, copy the parsed array to the sorted array method, would be to do something like this. So I'm going to comment that bit of code out. Certainly optional, but it's just for future reference. So we can put sorted array equals. This time I'm going to use an inbuilt method called a class called arrays, which is built into java.util, as you can see there. Arrays dot, and we can type copy of, and you can see by looking at a lot of these different methods, they're overridden. You can booleans, bytes, characters, doubles, floats. There's lots of them there. We're going to use the first one, copy of, and all we need to do is pass in the array. And then how many characters we want the new array to be. We're just going to put array.length. So that one line there effectively takes a copy of the array with the right length and automatically creates the new array called sorted array for us. So we'll be looking a lot more at, as we go through the course, as I said, about different functions that do things like this that are built into Java to save you a lot of time. Now just to confirm that, 50, 160, 200, 43, 770. And you can see it still works. 770, 200, 160, 50, and 43. So that's the solution to the array challenge. I hope you enjoyed that, and I'll see you in the next video. Alright, so let's recap what we've learnt so far about arrays and discuss some of the common errors that occur with arrays. So an array is a data structure that allows us to store multiple values of the same type into a single variable. Now the default values of a numeric array elements are set to 0. Arrays are 0 indexed, so an array with n elements is indexed from 0 to n take 1. So for example, 10 elements, the index range would be from 0 through 9. Now if we try to access an index that is out of range, Java will give us an array index out of bounds exception, which indicates that the index is out of range, in other words, out of bounds. We're trying to access an element that is outside of what we've defined. To access array elements, we use square braces. This is also known as the array access operator. So let's see an example of how to create an array. So we use square brackets after the type. In this case, it's an int array, so we've got int square braces, then the name of variable, in this case array. So it's int square brackets array, Then after the equal sign, we type new int. In this case, since it's an int array, and 5 in square braces, representing the number of elements in the array, in other words, the length of the array. So you can see in this scenario that the array contains the elements from array 0 through to array 4. It's got 5 elements, and the index range in this example is 0 to 4. The new operator or keyword is used to create the array and initialize the array elements to their default values, remembering that an int, in this case, will be defaulted to 0. Now for Boolean type arrays, if you used Boolean instead of int, they would all be initialized to false. If you used string or other objects, they would be set to null, but we'll be talking more about null and what that is later in the course. So in this example here, we've got int, left to right square braces, my numbers equals, and we've got left to right curly braces with the numbers 5, 4, 3, 2, 1 in it, then at the end there's a semicolon. So this is a way to initialize an array in line using an array initializer block. And that's what that is there, the left to right curly braces with the contents in between. And notice that we're defining the values for the array separated by a comma. So this way of initializing is also known as an anonymous array. It's got 5 elements and the index range is 0 through 4. And in this example, you probably figured out that the array elements are initialized to 5, 4, 3, 2, 1. Right, now here's another example of our array. Int square braces, my array equals new int, 5 in square braces and a semicolon. You may recall that when we first used variables, I said a variable is a place in memory. So think of it like a box that you can store something and you can store something in that box. Well, the same goes for arrays, but with arrays you can imagine an array as a row of boxes or slots where each box can contain a value. So in other words, we can store something into each box. So in this example, I mentioned we created an array with 5 elements. So in other words, 5 boxes, and they are by default all initialized to 0. So every box in this example contains an integer value of 0. So every box or slot's got an index so that we can access the values by an index using square braces. So in this example, we've initialized the array with values in the same line using an array initializer, which we talked about, and that's also known, as I mentioned, as an anonymous array. Now each box or slot contains a value. The array again has 5 elements, but we're putting the values into each box. So each box has got a different value, so the box or element at index 0 contains number 10, the box at array element 1 contains 35, and so on. Right, so let's see some of the common errors that occur when working with arrays. So here's an example of the first common error, accessing index out of bounds. Now as you can see, we're trying to assign the element at index 5, and that index doesn't exist. In other words, it's out of bounds. And the same goes if you use a negative index. Arrays can't have a negative index. So in other words, the number has to be 0 or higher. But note that an array can hold a negative value. So in other words, we can put a negative number into one of those boxes, but we can't try and access a specific box or element using a negative number. But in this particular case, you can see that we've defined the array on the first line, int left to right square brackets, my array equals. Then we've got the left to right curly braces 10, 35, 20, 17 and 18 separated by commas, and then a semicolon on the end of the line. So that's a 5 element array, but remembering that our array index starts at index 0, so therefore my element square brackets 5 in between, trying to set that to 55 is giving us an error. And you can see there on the screen in the bottom right hand corner, in that scenario we're trying to basically update a box that doesn't exist in this particular array. So be careful when accessing array elements. Remember that array index positions start from 0 and go up to the length take 1. So in other words, here we've got 5 elements and the valid ranges to get access to those elements is 0 through 4. Alright, so a second common error happens when you loop through an array. Now there's a logic error. In other words, we're starting here from element 1, but remember that the array index starts from 0. So if we printed out the elements of the array starting from index 1, the first element, which is at index 0, won't be printed in this scenario. So if this ever happens to you, just change the variable in the for loop to start at 0. So you can see what's happened in this code. We've assigned the values to the array of 10, 35, 20, 17 and 18, but the output, as you can see, has bypassed the value of 10. And that's the value from index 0 in the array, because the for loop, as you can see in the red box, we started from the value 1. And of course, index position 1 contains the value 35. So the last common error that happens would again cause an index out of range exception. Now this is because the condition isn't correct. So here we're using the less than equal operator. You can see that highlighted in the red box, but we should be using the less than operator. The problem happens because the last iteration of the loop I variable will have the value 5, and the length of this array is 5. So we've got 5 elements in the array, but the index range is from 0 through 4. So when I is equal to 5, the condition will be true because we've mentioned less than equal there. So 5 is less than equal to 5 is true there, with 5 being the value of I and 5 being the length of the array. So this will cause an out of range exception. So most importantly, remember that again that the index starts at 0 and ends at length take 1. So when looping, it's easier to use the less than sign than having to use length take 1. So here you can see that we could change the code to put I less than myArray.length, which would work just fine. Alright, so that's a recap of arrays. I hope you got a lot out of it, and we'll move on now to the next video.
It's break time. Do you like this video? Don't forget to subscribe to get new videos. Share this video to open new premium videos and ebooks. We'll be a Starfreelancer.
So let's discuss reference types, value types, and the main differences between those. So far we've seen primitive types like int, double, and bool. Now all the primitive types are value types. In other words, they hold a value. Now unlike primitive types, an array is a reference type and string is also a reference type. But we're going to talk more about string in later videos. So let's start though by going through this to make sense of it. And I'm going to start in my main method that I've created. And by the way, I've created a new project that you can see here in IntelliJ called References versus Value Types. I'm going to start by typing some code in the main method. Int myIntValue equals 10. And then we're going to do a second line, int another int value equals myIntValue. Okay, so we've got two variables there, myIntValue and another int value, and we've assigned the value 10 to myIntValue variable, and on the next line we're assigning the value of myIntValue, which is 10 in this case, to another int value. So in other words, both variables now have got the value of 10. And let's just quickly confirm that. So we'll just do a simple output. myIntValue equals plus myIntValue. We'll do the same for the another int value. So another int value equals plus another int value. Let's just run that to make sure that it works. And of course, there's no reason why that won't work. So I've got the value of 10 there. And let's put the window down the bottom there. All right, so next what we're going to do, let's increment another int value by going down to the line under the print statements and do another int value plus, then a semicolon. And let's print out both values again. I'll just copy that and then paste the code in again. So we've got a before and after there. We'll run the code. And you can see the second time that I've run it, this time another int value's got the value 11. And of course my int value is unchanged and still has the value of 10. So that's all fairly straightforward, and I'm sure that you understand how that's working, given what we've been through the course so far. So that's value types. So when we created an int variable, this value type, a single space in memory is allocated to store the value, and that variable directly holds the value. Now if you assign it to another variable, the value is copied directly, and then both variables work independently, as you can see, and they've each got their own copy of a specific value. In the case of my int value, it's 10, and another int value, 11. Now, reference types, like arrays or classes, work differently. Now, I've already discussed what a reference is, how it works, and the new operator. So whenever you see the new keyword, that means that we're creating a new object. So let's create a new array. And I'm going to come down here after the second printouts and type int, an int array, so int left and right square braces. My int array is equal to new int, and in square brackets 5, a semicolon on the end. So this array has got 5 elements, and we have a variable, or in other words, a reference, myIntArray. Now arrays again are reference types. So what does this mean again? Well, reference types are used by a reference. So a reference holds a reference or an address to the object, but not the object itself. So again, a reference holds a reference or an address to the object, but not the object itself. So in other words, the variable here, myIntArray, holds a reference or address to an array in memory. With reference types, we're using a reference to control the object in memory, so we can't access the object directly. So a reference is like an address of some object in memory. In this case, again, myIntArray is actually a reference to the array in memory. Now this might sound a bit confusing. I'm going to show you some slides in a little while that should hopefully make things a bit clearer. But let's see what happens if we write some code that was similar to what we've done with the ints so far in the program. What I'm going to do is create another array here on the next line. Int array again, int left and right square brackets, and we'll call this one another array is equal to myIntArray. So what have we done on this line 19? Well, here we're declaring another reference to the same array in memory. So now we've got two references pointing to the same array in memory. So in other words, both myIntArray and another array hold the same address. So as you can see, one way to know it's a reference type is the new operator, because that creates a new object in memory, and we're using the new operator on line 18. And we created an array of 5 elements on line 18. So basically new here means new object. On the second line, we haven't used the new keyword, we've just used the equal sign. Now to print them out, we're going to use a useful static method from the class arrays, which is built into Java. It's a method called toString. And hopefully from the name, as I type the code, you'll probably understand what this will do. Let's try it. So in double quotes, I'm going to put myIntArray equals, and I can type plus arrays dot toString. Then parentheses, I'm going to type myIntArray. And again, that's a useful command built into Java that will print out the contents of an entire array. So this method toString, which you'll see more frequently as we go through the course, joins multiple strings or objects into a string using a comma as a separator. So in this case, we've got an array of integers, so the toString method is going to convert every element in the array to a string, and then return a new string where every element is separated nicely and we can print the whole array on one line. So it's a pretty useful method, and you'll soon see how nicely it prints out our array. So let's do the same for the another array variable as well. Print that out. Another array equals plus that's arrays dot toString, in parentheses is going to be another array. The two right parentheses to close it off. And we'll just run that. And you can see that it's nicely printed out the values. We've got 0 because so all we've done is defined the ints in the array. They're initialized because it's an int to 0 by default. We've also got the same output for another array there. So let's actually see what happens if we make a change to one array. So I'm going to come down in the code below here, and I'm going to type another array, and in square brackets 0 equals 1. So 0 in the square brackets equals 1, semicolon. And let's just take a copy of that line again, paste that in. But just to make it really clear, I'm going to change the text to put after change. That way we can see the change hopefully easily. So what do you think is going to happen at this point? Will it change just another array, or will it in fact change both variables? Well, let's run this and see what happens. You can see what's happened down the bottom left hand corner of the screen there. Both were actually changed. So both variables, in other words, again are references to an array, and because we've updated another array to 1, it automatically updated the other array, and that's because both variables are referencing the same array in memory. So there's only one copy of the array that both variables are pointing to, and that's why the array has been updated as it has. Now this might look a bit weird, but that's how references work, and you'll soon see on the slides that I'm about to bring up on the screen. And it's because reference types represent the address of the variable rather than the data itself. So in our case, again, both variables represent the address, pointing to the same array in memory. So in effect, we've only got one array in memory that both are pointing to. Right, so let's check out those slides to hopefully make things a bit easier to understand what's going on. So here we've got the same code from IntelliJ. When the line int left right square bracket my array equals new int 5 in square brackets executes, the line creates a new array in memory with 5 elements and initializes all elements to 0, and that's because by default numeric arrays are initialized to 0 because of type int in this case. So now we've got a reference that points to the array address in memory. And on the image, you can see an arrow from the reference pointing to the array in memory. My int array pointing to that array. So in the next line, we're creating another reference to the same array. Now notice on the image, we've still only got the one array, but we've now got two references that point to that same array in memory. So in other words, to the same address in memory. Each reference or variable has a different name, but that doesn't mean there's two different arrays. We've got two references, but both, as you can see clearly, point to the same one array. The next two lines, well, that is printing out the array to the console. We're printing the same array again because there's only the one array in memory. Every element has the value 0, and that's exactly what's printed out. On the next line, another array 0 in square brackets equals 1. So we're assigning the value of 1 to the first element of the array. And you can see that in red down the bottom left-hand corner. That puts the value 1 into the element at index 0. So in other words, we're setting the element at index 0, the first element of the array, to hold the value 1. Now since another array and my int array are two references pointing to the same array, we can say that both references can see the change. So in other words, we've got one array in memory, so whatever reference to the array we use, the other references are still pointing to the same address, and we're getting the same output back as a result of making that change. Alright, so we're printing out now the last two lines. And again, since we're printing the same array out, and since we changed array element at index 0 to 1, we see the change for both lines for the first element at element 0, now showing the value 1 instead of 0. So both references again see the change that we made, and we get 1 as the first element in the array. Now the same behavior happens when we pass reference types to methods. So let's jump back to IntelliJ to see another example using methods. So what I'm going to do now is just close down the run window for now, and we're going to create another method here. I'm going to type private static void modify array in parentheses int left and right square brackets array, and then we'll open our code block. And what we're going to do is change the array position, the contents of the array element 0 to a value of 2. So I'm going to type array left square brackets 0 right square bracket equals 2. Very simple, as you can see. Now what we're going to do now is call this array, this modify array method. We're going to type modify array. We're going to pass my int array. So we're passing a reference type to the method. So in this case, we're using the reference to my int array. So what do you think is going to happen when we pass the reference type to the method? Well, the address is copied to a parameter. So in other words, now we've got 3 references to the same array. The parameter is the third reference to the array. And just to confirm that, let's actually print both references after the modify array method call. So I'm just going to copy and paste the 2 lines above. Paste that below the modify array. And I'll change this after change to after modify. So let's run this and see what happens. And you can see what's happened down there by the output on the bottom left-hand corner of the screen. The first element in both cases now holds the value of 2. And this is because all references point to the same array. We've just had the one array in memory still in this scenario. So you may think that a method can modify a reference itself, but it can't. We can only dereference it. But let's see what happens if we do dereference, or in other words, reinitialize the array that we received via a parameter to our method. So what we're going to do is in our modify array method, after that line, we're going to type array equals new int left and right square brackets. Then we're going to initialize it by using a left and right curly braces. We're going to put 1, 2, 3, 4, 5. So in this case, we're creating a new array. So we have to use the new int square brackets and then initialize the array with the contents in the left and right curly braces. Now you may think that references in the main method, myIntArray, and another array will be able to see this change. But you'll see that they're not able to see it because we're dereferencing the reference. In other words, this parameter is a reference that points now to a different array since we used a new keyword. So now it points to a new array with the elements 1, 2, 3, 4, 5. To see what I mean, let's run this. So you can see in the case of myIntArray and another array, they've still got the values 2, which was set on line 39. Again, the reason for that is because the parameter reference, the one that has the name array, points now to a different array. Once we use the equal sign, we're effectively dereferencing that reference. And an array has been created in a new area of memory that array points to. However, myIntArray and another array are still referencing the original array and nothing's changed. They're still pointing to that original array. Now the same would be if we change the other array. So let's just see one more example before finishing this video with dereferencing. So just before the modify array method call up here, I'm going to change the another array. Let's try and do that. So another array equals new int, left and right square braces. Then we're going to put the values there, 4, 5, 6, 7, 8. So now we're creating a new object in memory, and myIntArray and another array, they point now to a different object in memory. So now we've got two references and two different arrays in memory. So let's run it once more and see what happens. So you can see now we've got different results here. You can see now that the another array no longer gets the change from the modify array method call, because before calling the method modify array, we're dereferencing the another array reference, and it now points to a different array in memory. And again, the hint for that is the fact that we used a new keyword again on line 31. So if this was hard to grasp, try to rewatch the video and play around with these examples, because it's a very important concept to understand. But once you get it, you'll see that it does make complete sense. So that was it. That's reference and value types. They can be sometimes hard to grasp, but we're going to use references in the course more often, and it'll become easier over time the more you continue to work with it. Let's finish the video now and move on to the next one. Alright, so it's now time for another challenge. This is the minimum element challenge. So to start with, write a method called readIntegers that's got a parameter called count that represents how many integers the user needs to enter. So the method needs to read from the console until all the numbers have been entered, and then return an array containing those numbers that were entered. Secondly, write a method, findMin, that uses the array as a parameter. So the method needs to return the minimum value in that array. So in the main method, then read the count from the console and call the method readIntegers with the count as parameter, the count variable as the parameter, and then call the findMin method, passing the array returned from the call to the readIntegers method. And finally, print the minimum element in the array, which should be returned from the findMin method. And a few tips here. Assume that the user will only enter numbers. So in other words, you don't need to do any validation for your console input. For simplicity, I recommend you create a scanner as a static private field to help with data input. And thirdly, use the project name min element challenge when creating a new console project in IntelliJ. So that's it. Pause the video now and try out your challenge, and when you're ready to come back and see my solution, you can restart the video at that point. So pause the video now, and I'll see you when you get back. Alright, so welcome back. I hope you managed to do well with that challenge. Let's go through my solution to it. So I'm going to start by creating this static field that I mentioned that you should do by typing private static scanner, and it's equal to new scanner. It's going to be system.in. That's where I've usually defined it. And in terms of the input there, I'm going to make sure that I've selected java.util. And again, that's what we've done each time. Now, by setting the scanner as a static field as I've done there, Well, we needed to do that so that the other static methods, like the existing main method and the readIntegers method that we're going to create, they'll then be able to access this field directly. In other words, the static methods can use scanner without creating separate instances of that class. Now, since we've only got this one main class, the methods in main can also be static and should be. And you can see by default, the main method has got that static keyword there on line 9. Now, additionally, I've set scanner to private so that other classes can't access it. Even though this doesn't necessarily matter for this program since we don't have any other classes, it's a good idea to keep all fields private to encapsulate the data. Alright, so let's now break this down into smaller pieces. First, we need to write the method readIntegers that's got the integer count, or the integer with the parameter name count. So let's create that. I'm going to put that just below the main method. So I'm going to use private here as well. So private static, and we're going to return an int array, so it's int left and right square brackets. readIntegers is the name of the method. Parentheses int count. Then a left and right curly braces to create the method. Now this method needs to return an int array, and it contains the parameter count as we've defined on line 13. Now the parameter represents how many numbers we're going to read from the console. So let's now implement the method. Firstly, we have to create an int array and then populate the array with the user's input, which will be retrieved obviously from the console. So to create this array first, I'm going to type int left and right square brackets array equals new int and left square brackets count. Now, as we've learned previously, this code creates an array and initializes all the elements to 0 so that every slot or element, if you will, in the array contains the value of 0. So moving forward, we're going to assume that the user will always enter numbers only. So in other words, we don't need to validate the input at all. So with that in mind, we're going to use the next int method. So we need a for loop now to read the numbers. So for the for loop, we're going to type for in parentheses int I equals 0, I less than array.length, semicolon I plus plus. Then I'm going to type a system output line, and we're going to put enter a number and a colon on the end of that, just so the screen is actually showing what the user should do. And we're going to type int number equals scanner dot next int. You've seen that before. We're just retrieving an integer from the console and storing it, in this case, into a variable called number, which is of type int, of course. Then we need to call the next line method from scanner, so scanner.nextLine. And we're doing that to make sure we handle the enter key being pressed once we've entered the number, and they can then continue to enter more numbers, so we're avoiding the problem that will happen if we don't do that. We now need to record the number that's been entered, in other words, populated into the array. We do that by typing array, left and right square brackets, and we put I in that left and right square brackets equals, and the value entered on the console, which was number. And then finally, what we want to do is just return the entire array. So we do that by just typing return array. Right, so that completes the method readIntegers. Our next step then is to call this method from the main method, but before that we need to read the count from the console using the next int method. In other words, we need to determine how many elements are to be entered. So to do that, we're going to come back to our main method. I'm going to start with a message and type enter count. Then I'm going to type int count is equal to scanner.nextInt. So retrieving how many elements, and then we're going to do scanner.nextLine to again process the enter key. And now we need to make a call to the readIntegers method. And we need to save the value that was returned, the array in this case, to a variable. So I'm going to type int left and right square brackets. I'm going to call this one returned array equals readIntegers, and we're going to pass count, which was the number entered from the keyboard or on the keyboard. So basically we're assigning the return value, which is the array, from the readIntegers method and saving it into a new local variable called return array, which is itself an integer array. So the next step now is we now need to write the findMin method, which will find the minimum number in the array. So let's go and below the last curly brace, closing off the readIntegers method, and create a new method in there, or below that I should say. And I'm going to start by typing private static int find min. In parentheses, we're going to have an array as an argument, so it's int left and right square brackets array. And I'm going to start by setting a local variable called min to the highest number that an integer can hold. So I'm going to type int min is equal to integer dot, I'm going to select max underscore value. Now we used that previously in the minimum and maximum challenge earlier in the course, so refer back to that if you're unsure what the max underscore value is all about. But a question you might be asking at this point is, why am I actually setting the min variable here to the maximum value that an integer can actually hold? Well, every number the user enters must be equal or less than the maximum value an integer can contain. So if we were to set this min variable to 0, and the user were to enter, for example, all positive numbers, then the method would return 0 as the minimum, since all positive numbers were greater than 0, even if the user never actually entered 0. So by starting with the maximum integer value, what we're doing is ensuring that the minimum value returned was actually input received from the user. Now, another approach would be to set min to the first element of the array and then compare it with each of the others. But you can see an example of that if you go back and check out again the minimum and maximum challenge earlier in the course, because I discussed that in detail and in fact showed some of that as a potential solution. The point here is that there's many different ways to code a particular challenge solution. But in any event, we've gone here with the max underscore value version for an integer. Alright, so the next thing we now need to do is we need to cycle through the array and find the smallest number, the minimum value. So we're going to create another for loop that does the same as what we did with the for loop in the read integers method. So for int I equals 0, I less than array dot length, then I++, obviously separating both with semicolons, and open the code block with the left and right curly braces. So to start with, we need to retrieve the value of the element at position I, and we do that by typing int value equals array in left and right square brackets I. So we've got the element from the array to compare, and now with each loop iteration, we want to compare the element we've just retrieved with the current value of min. So to test if value is less than min, we can use an if statement. If parentheses value is less than min, then we'll open another code block. Then I just type min equals value. So if value is less than min, meaning our condition is true, then we've found a number lower than the current minimum, so we then assign its value to the min variable. And finally, after the for loop ends, we can add a return statement, return min, which will then be the smallest or minimum number in the array. Okay, so that's our find min method. So we now need to place a call to that inside our main method. So let's go back up to the main method, and we're going to put that on the line after our call to the read integers method. We're going to save the value return. We're going to go int returned min is equal to find min, and we're going to pass as an argument returned array to that find min method. So we're passing the array that the users entered from the read integers method to the find min method, so that the minimum value can be calculated. And then finally, let's print out the minimum value. So min equals, in double quotes, plus returned min. So that should complete the challenge, but let's actually run the application to confirm that it works. Alright, so firstly it's asking us to enter count, so I'm going to enter the number 8 elements. And we now need to enter a number, so I'm going to enter some numbers: 11, 55, 7, 4, 3, 99, 22, 9. And we can see down the bottom there it's got min equals 3, and since the number 3 is the lowest of all the numbers we entered, we know that our application is working correctly. Alright, so that was my solution to the challenge. I hope you enjoyed it and managed to learn a few new things. Let's move on now to the next video. Alright, it's time for another challenge. This is the reverse challenge. So firstly, write a method called reverse that's got an int array as a parameter. Now the method shouldn't return any value. In other words, the method is allowed to modify the array parameter. So in main, test the reverse method and print the array both reversed and non-reversed. So to reverse the array, you have to swap the elements so that the first element is swapped with the last element and so on. So for example, if the array contains 1, 2, 3, 4, 5, then the reversed array would be 5, 4, 3, 2, 1. And create a new console project with the name Reverse Array Challenge for this challenge. Alright, so that's it. See if you can figure it out. Pause the video now and try your hand at this challenge. And once you've completed, come back to see my solution. So pause the video now and I'll see you when you get back. Okay, so welcome back. Hopefully you managed to finish that. So let's go through and solve this particular challenge. So what we need to do is start off by writing the method reverse. So let's go ahead and do that. Let's go ahead and type private static void reverse, then in parentheses int left and right square brackets array, then our left and right curly braces as per normal. So within this method we're going to use a for loop to go through the array elements. The tricky part is the condition needed for the loop. So inside the loop we have to swap the elements, as in the first element will swap with the last, the second with the next to last, and so on. Now later in this video I'll provide some images demonstrating this swapping pattern. So before writing the loop, let's declare an int variable. So int max index, we're going to set that to the maximum value that an index can use. This variable will represent the maximum index that we can use. Now we already know that the index range is from 0 to the length of the array minus 1. So that will be the value that we'll store in here. So we'll set that to array.length minus 1. Now as stated, this max index variable represents the maximum index. Our next variable will be called half length, which will represent half of the array length. Now this is where it becomes tricky. We need to loop through the array and continue swapping until we get to the halfway point of the array. So let's declare that variable now. So it's going to be int half length is equal to array.length divided by 2. Now you might be wondering here, Tim, why do we only loop through until we reach the halfway point of the array? Well, the reason is we're swapping elements, so once we reach halfway, the second half has already been swapped with the first, so the array is now fully reversed at that point. Now the image that I'll bring up later in this video will show you and hopefully make that more clearer. Alright, so next though, let's start generating the code for our for loop. So in the next line I'm going to type for, in parentheses, int I equals 0, I less than half length, semicolon, then I plus plus. And open the code block there. Now inside the loop, we want to swap two elements. So to do this, we need to create a temporary int variable, which I'm going to call temp. So I'm going to type in int temp equals array I in square brackets. So we're saving the current element position or element I as we're cycling through the array. So basically, since the I variable represents index starting from position 0, in the first iteration we have to swap the element at index 0, which is our first element, with the index at the max index, which is our last element. So to accomplish this, we want to type array, and in square brackets I is equal to array, square brackets again, it's going to be max index minus I. And closing off the square brackets and semicolon to end the line. Now in our temp variable, we save the element that was at index I. Then on the next line, we moved the element from index max index take I to index I. So now all we have to do is move the first element to the last index, which is where our temp variable comes into play. So we can now type array, then square brackets, max index, minus I in square brackets there equals temp. So we're putting that value in there because the element originally at index I was saved to the temp variable on line 14. Now that's all the code we need to swap the elements. It might look strange at first, but basically as I progresses from 0 to the index of half of the length, each element swaps with its mirror element, meaning the first with the last, the second with the next to last, and so on. But we now need to test this out to confirm that it does work. So let's write some code in the main method to do just that. All right, so we're going to start by creating an array we can use for testing purposes. So we're going to type int left to right square brackets array is equal to, then we're going to put curly braces there to initialize it to 1, 5, 3, 7, 11, 9, 15. So there's our array. And obviously that's not ordered at the moment. So now that we've got this array, we need to reverse it. But before we do that, we should print it out since the reverse method is modifying the array parameter. So let's actually try printing this out first. So we'll print out array is equal to plus arrays dot to string passing our array to that as an argument. All right, so after we've printed out our unmodified array, let's call the method reverse, and then we'll print out the array again. So on the next line, I'm going to type reverse array. So we're passing our array as an argument. Then let's just print out the next line. We're going to put reversed array is equal to plus arrays dot to string again, and the same array as an argument. All right, so let's now run the application to test out our code to see if it works. All right, so you can see first my original array, 1, 5, 3, 7, 11, 9, and 15 were the elements. Then on the next line, we've got the reversed version, 15, 9, 11, 7, 3, 5, and 1. So that means that we've achieved the desired result of reversing the array, or the elements, I should say, in the array. Now, just to see what happens, let's go back to our reverse method, and let's actually remove this divided by 2 component. I'm going to remove that to show you what happens if we don't divide the array length by 2. All right, so I'm going to run it again. Now you can see in this case, we're now not getting the correct result. Since the elements continue to swap until the end of the array, even though the original first element correctly swapped with the last, when we reach the last element, it then swaps back into the first position. So in this case, we swapped 1 and 15 as the first iteration, and then swapped them again in the last iteration. As a result, both lines in the console have the same elements. At first glance, it might look like our code is not working at all, but it actually is working. We just happen to swap all the elements back to their initial position again. So let's revert that change and run it again. You can see we've now got the correct result again. So as I stated earlier, we're now going to review some images showing the execution steps of the for loop and the functionality of the array, just to hopefully clarify any doubts you might have on how it's working. Now for our example, we're going to use an array with the elements 1, 2, 3, 4, 5. Now for the first iteration, the variable I equals 0. And if we look at the lower left box here, we can see what this code would look like in the for loop. As you can see, we're storing the element that is at index 0 in our temp variable. So in this case, the element at index 0 has a value of 1. Next, we set the element at index 0 to a value of 5, since that is the value in the last index, index 4. Finally, the last element is set to the value of temp, which is 1, and which is also the original value at index 0. Then these steps are executed during each loop iteration. On the right-hand side of this image, there's an illustration showing how the array transforms. When the line int temp equals array, left square bracket I, right square bracket is executed, we're storing the first element in the temp variable. The next line sets the element at index 0 to the value of the last element. In other words, 5 is now at index 0. And the last line changes the last index to a value of 1, since temp has a value of 1. Then each iteration of the loop follows this process. Now, after the first iteration is complete, the array is now 5, 2, 3, 4, 1. So let's now move on to the next iteration. Now, in this iteration, I equals 1, and our array reads as 5, 2, 3, 4, 1 due to the processing in the first iteration. So this time temp will be the element at index 1, and the logic will follow that of the first iteration. So to sum up, the element at index 1 swaps with the element at index 3, and our array is currently 5, 4, 3, 2, 1, meaning it's now fully reversed. The I variable will still increment and become 2, but the for loop will stop since half length equals 2. So in other words, in our loop condition, we now have 2 less than 2. Since that condition is false, the loop won't continue. And as demonstrated before, if we continue looping through the whole array while following the same logic, then the elements would actually be moved back to their original index, and the array in fact wouldn't have been reversed. Alright, so that's it for the challenge. I hope the looping logic made sense, and I look forward to seeing you in the next video.
This video is over. Go to starfreelance.eu to download these videos, materials, and sources. Watch more videos to get premium videos and ebooks. We'll be a Starfreelancer.